Testing. Testing, testing. It's there. Are we all set? Yeah? We're on. We're live. Let's go. All right. Hello and welcome to the third edition of Playing Models. My name is Adil Bukhari. This is Agostino Nickel. We are both PhD candidates at the Chair of Digital Architectonics. And then together with Carla Saldana and Li Su Huang, we've organized the next 2 days for you. So we want to warmly welcome you to this event of ours. So we will have 2 days of playing models, artificial intelligence, architecture, and storytelling. And this has been a series of early symposiums that began in 2022 as a collaboration between our chair, the Chair of Digital Architectonics, and between the University of Florida, the shared lab by Carla. And we are in our third cycle, and the symposium aims to develop a platform to share thoughts on the mathematical, political, philosophical shifts emerging with the spread of AI in its many phases.
So what we like to do is to think of architecture as an intelligence of joining and connecting seemingly disparate things, concepts, methods, and also telling stories about the world while also being firmly present within it. Next 2 days, as you might have seen from our posters, are structured into 4 panels. We will start today by looking at how we might measure distances in the manifold and how to project dimensions in the sensible. Tomorrow, we will explore how to sculpt bodies in light and how to tell stories in synchronicity. We are very excited to kick off this third cycle with you today, and we look forward to many inspiring talks and thoughts being shared here at ETH. Now is the big time for thank yous. We would like to thank all of you for being here, especially all our presenters who came all the way here to Zurich and who are going to share their thoughts with us. We'll introduce them in more detail before their individual contributions. We would also like to thank our sponsors, the University of Florida, the Chair of Digital Architectonics here at ETH Zurich, NVIDIA, the UF AI Center, and Mark III Systems, who kindly supported us and made this conference possible. We would also like to thank our fantastic event management team, Janelle Jacquay and Maud Haas, and Jimmy Cheng for all the tech and streaming setup that makes this conference live on for many more days.
Yeah, and a special thanks goes out to Professor Ludger Hovestad, who has supported us from the very beginning. And maybe, Ludger, if you would like to add a few words to say hello to everyone.
Yes, welcome, everybody. It's nice to see you in Zurich after 2 times in Florida. And I prepared a small talk about 10, 15 minutes about AI and as an opening talk, and want to welcome you with these words because I can't be there in person. Okay, about AI. So it's so easy to talk about how AI works and so complicate what to do with it. These days, I'm shocked about the developments the last years. I did not expect this. I think nobody did. These shocks came from all sides. I had this naive belief that things on the global perspective over time get better. Life expectancy up, literacy up, the rate of homicides down, global wealth up, and so on and so on. We can make an endless list, as a lot of people do. We played around in this optimism with robots, with drones, with scanners, cameras, remote controls, networks, with words, with pixels, with code, with AI, and now, bang. I feel lost. I feel I lost innocence. Not an academic talk, but really, I lost innocence. AI is radical. Take, for example, Lex Fridman and his podcast. Sitting there with his slim black tie and his calm, deep voice, and I paraphrase to characterize him, I know nothing, I love you all, and I'm learning fast. He is almost a living manifesto of AI. Take, for example, the term weather, the massive condition of our existence, I would say. In contrast to this overused and wrongly used term of climate, which constitutes the questions what to do, very few would say. And I take as another ingredient Bruno Latour and his traces of data. His view on data as something massive. Data as weather, not as climate as I would do it. Heating up by technology, and now it starts boiling because we think of it as real. And I start to get a sense of McLuhan's The Medium is a Message. Everything is heating up by the new media. Everything AI touches starts boiling if we treat data as something real. And today I feel myself in a super modern condition. Everybody is right, everybody knows everything, nobody needs to be convinced or informed anymore, be enlightened, educated, people know. Everybody in their own way, and they are shouting. I look around, things are out of proportion. They are overwhelmingly massive, so massive that they kill you. Our enemies are not nature or technology, it's us, heated up by media. It is a media I want to liberate from to become a digital human. Liberate like Leonardo did 500 years ago, or like Vitruvius did some 2,000 years ago. Therefore, calm down. Do not do it. We have to talk about it. And there's good news. I paraphrase Jan LeCun of Meta. AI can't do pixels. They just can do words. So it's not in the synchronicity of space, how it can work. There's no success there. It's just on the resonance in sequences of terms. So AI can't do pixels, just words. No numbers, but characters. No circles, but lines. No light, but matter. No yang, but yin. No heaven, but earth. Or for us architects, no floor plans, but sections. No space, but walls. No iconography, but orthography. AI is, metaphorically speaking, only with the walls, these massive things. Walls which know everything, which remember everything, and because they know everything, they are dead. They are of the past, watching us, what we call orthographia traditionally, as architects. The statue, the column, the wall. And there's a space in between, with these vivid things of presence as guest. They are not AI. Yes, they show up in the new light of AI, but they are not AI. This is where I want to play. Here it is, in front of the walls, where I want to learn to talk with a calm public voice. In the light of today's AI, learn to talk with my own tongue as our ancestors did. So in this sense, have a good day. Have a nice conference. And these are my words. Warm welcome to Zurich, and have a good time. And enjoy.
Thanks a lot, Ludger. And I think now we can move to our first panel and our first moderator. Carla, please, the stage is yours.
I would also like to welcome you all. Zurich has been my home for 6 years. I'm not here anymore, but when I come back, I always feel a warm welcome. I hear myself like 3 times. I hope it's okay with you. So we're going to talk, I'm going to introduce the first panel that is called Measuring Distances in the Manifold, Dimensions, Measures, and Distance. And I wrote a little description of what we're going to hear and what we're going to experience, and I would like you to give a context of our fantastic speakers. So here I go. Our planet is a complex and often inaccessible object of understanding. Therefore, it can only be described with abstractions, dimensions, and measurements. Throughout history, we've developed tools and instruments to synthetically and precisely describe its complexity. In this relationship between the world and its representations, we've crafted maps and articulated specific models to render the inherent complexity of the world. Derived from the Latin word modus, or modo, meaning manner or to measure, a model both abstracts and measures dimensions, projecting them onto a reduced geometric space. Thus, a model serves as a particular rendering of the partial map of reality. Today, our models have evolved with artificial intelligence taking center stage as the primary tool of the digital world, serving as a contemporary map and its various representations on the models that we can produce with this data. Architects utilize instruments to process this digital data and create specific articulations, bridging the gap between the abundance and specificity. This iterative and cyclical interplay among different models enables architects to create spaces where abundance coexists, catering to diverse users and their modalities of usage. The upcoming panel will offer a comprehensive example of these concepts, showcasing how AI models embody the abundance of space. We have our first speaker, Andrew Witt. Andrew Witt is an associate professor in practice at Harvard Graduate School of Design, teaching and researching on the relationship of geometry, data, AI, and machines to architecture, design, and culture. Trained in both architecture and mathematics, he has a particular interest in a technically, synthetic, and logically rigorous approach to form. He's also co-founder with Tobias Nolte of Certain Measures, a Boston-Berlin-based studio that combines design and data for systematic and scalable approaches to spatial problems. The work of Certain Measures is in the permanent collection of the Centre Pompidou and has been exhibited at the Barbarian Centre, the Museum of the Future, the Canadian Centre of Architecture, among others. Welcome, Andrew, and thank you for joining us.
I don't think so. Okay, Carla, thank you so much for that introduction. It's wonderful to be among friends, old and new today. And it's a complete honor and pleasure to be here. And I'm glad that we have such an intimate gathering. Maybe we can consider this more like a fireside chat than a lecture. Probably over-prepared with the notes, but anyway, we'll have a good conversation, I hope. So today, I'd like to consider how designers use AI and ML to restructure how we access, analyze, and categorize the vast body of historical data surrounding architecture. And I'm thinking about historical data in relatively broad terms, things that we typically think of as historical documents, but also the kind of detritus and remnants and fragments of all of culture that have gone, that's gone before. How can AI and ML help us navigate the cultural, material, and ecological legacies of the past, and how can it relate and recombine these pasts into fresh ways? So I'll begin with this term spolia. Many of you may be familiar with it, the Latin term for spoils, the fragments or remnants of conquest, conflict, or struggle. It's that which remains after a sort of unthinkable end. The idea is sort of most literally applied to material fragments and the logic of spolia, but the logic of spolia actually mirrors that of the data set. It's images, 3D scans, all of those things sort of constitute a kind of like cultural spolia. On the other hand, there's a complementary concept, which obviously is going to be fundamental to everything we talk about today, which is data. And for our discussion, we'll define a datum as a recorded fact indexed in a larger collection. And data is a collection of such indexed facts. So both recorded and indexed aspects are essential. A fact that's unrecorded is merely an observation, while a recorded fact that's not indexed to a larger collection is merely a record. So data, as we've taken a sort of linguistic turn in the presentation today, is the plural of Latin datum, a gift or present, something directly given presumably by another. So data sets of physical phenomenon could arguably trace their origins to so-called ephemeris, which were tables of astronomical observations of stars and other celestial bodies that date from the 1st century AD. So since then, data has proved to be a semantically elastic word, taking on all of the valences and meanings that we, of course, associate with it today. So I might add a third term, the portmanteau of the two before, data spolia. So a peculiar product of our current age, data spolia are data that are proxies for spolia or are themselves cultural spolia, ripe to be vivisected and recombined into new configurations as much as physical spolia might be. So machine vision, reality capture, classification, and segmentation processes have made the forms and formats of data spolia almost limitless. So with the right tactics, architects might see these data sets as media in their own right, as well as instruments of reflection on architecture's past. So the presentation is organized into 4 acts. First, scanning the city. So notions of spolia and architectural data are intimately related to how we see and represent the city. In an increasingly digital environment, seeing and scanning the city through machine eyes is an essential way to come to terms with it. And though we think of scanning as reflexively digital, of course there's a whole series, a whole lineage of historical practices that foreshadow in a way the way that we approach scanning today. And those use serialized images, image matrices, to induce coherent views of very complex territories. Likewise, the scale of urban data sets is new, but the basic concept has long been with architecture. In his 1757 pairing of paintings, A Picture Gallery of Views of Ancient Rome and Picture Gallery with Views of Modern Rome, Giovanni Paolo Panini depicts dozens of nested paintings of then contemporary and antiquarian Roman buildings. It's a kind of Pinterest board of Enlightenment classicism, and it offers a kind of precursor to our more comprehensive contemporary architectural data sets. And what I think is perhaps most compelling about this is that there's actually a world room that's being created here. It's not only a data set, but a spatialization of that data set, which we'll return to. So today, of course, we think and design in image matrices. Vast collections exist for almost every conceivable building type, style, and element. But AI is changing and radically expanding how we as designers understand these images and also imagine our own history through them. So styles such as the Beaux-Arts, which were once communicated through a canon of a few exemplary drawings, can now be summarized through an exhaustive and completely comprehensive data set. So where we once looked to specific examples to convey ideas, we can now encompass them entirely with every instance. So so practices of data design engage with art and architecture's longstanding fascination with the catalog as creative medium. Architects and historians from Serlio to Bannister Fletcher have looked at catalogs as an essential way to map architectural form. And what AI is providing us with is a way to not only organize the catalogs which we currently have in a structured format, but also to create structured catalogs from heretofore sort of unstructured data. So let's see. Oops. So many of the projects that I'm going to show today are emerged from my office certain measures, which Carla mentioned. I have a short trailer to sort of orient you to what you're going to see later. Certain Measures is a studio that designs using computation and culture. We're multidisciplinary systems designers who embrace the possibility of digital media. We're really inspired by how data, computation, and AI can be used to design across disciplines, industries, and scales. From the material to the planetary scale, we partner with companies, institutions, and governments to transform multidimensional systems. We're exploring how water rights are shaping drought, how democracy can be more Yes, here in the back. transparent, and how we'll live in the homes of the future. We look for ways that design and data can change systems for the better through visualization, physicalization, and action. In our work, the digital and physical align to drive systemic and creative transformations. We look at both industrial and natural systems as computational processes, which opens up new ways to connect them and address ecology and circularity. One of our major interests is combining machine vision, geometry, and material analysis to imagine radical new ways to reuse materials from product to building scales. Our process combines speculative fiction, experimental prototyping, software development, and spatial experiences. And at the heart of our work, we tell stories to situate unfamiliar technologies in a social and material world. We're curious and open to the sciences, mathematics, engineering, technology, history, and art, and we aim to create a truly synthetic design process. We work to imagine and prototype a vision of our world in which culture, nature, and technology can all flourish together. We're pioneering a new kind of integrated design that we hope can build a richer, more human, and more beautiful tomorrow.
So I thought that Carla's introduction of this session in relation to worlds was very apt, because our process is consciously trying to connect the worlds of culture and nature, and at the same time the digital and physical realities into one sort of coherent set of artifacts, or rather dyads of artifacts. In all of our projects, or most of our projects, there's a sort of imbricated dyad of a physical and media entity, mutually supportive and entwined in their conception, execution, and epistemology. And the idea is to sort of connect these all in a sort of virtuous cycle of creation that uses data as an essential medium of design. So with these vast urban data sets and powerful generative tools, new frontiers in recombinant form open. By developing bespoke software to see and recombine the city, we can gain a much more comprehensive insight into what the city is and what it might become. So how might a machine see and organize the world's cities? How might ML quantify and map the morphological space of architecture? An answer is our machine view of London, which presents a bot for scanning, categorizing, and mapping the shapes of the 1 million buildings in central London. This project is part of an ongoing architectural research project that aims to compare and create a complete catalog of building patterns from cities across the planet. So we've applied this method to London, Berlin, Boston, Liverpool, Tokyo, Shanghai, and several others. In effect, the machine view of the city begins to map out the space of architectural morphology itself. So we're attempting to isolate from this universe of particulars some, I don't know if it's rules, but at least sort of like patterns of aesthetic composition and morphological structure through a relational comparison of every building. So it's really an attempt to actually inventory the entire corpus of architecture and make it legible, interoperable, and comparable. So such techniques have a lot of, I think, important implications not only for the history of architecture, but particularly for the practice of preservation, actually. So data spolia, I would argue, can facilitate new views of conservation that consider entire populations of buildings instead of merely archetypal exemplars. So as a proof of concept, we collaborated with Charles Waldheim at Harvard University's Office for Urbanization to develop a neural model to help identify 18 regional building typologies in various locations in China in danger of essentially redevelopment. So covering a range of areas from Guangdong, Fujian, Hunan, Shaanxi, Jilin, and Anhui provinces, the typologies range from large fortress-like compounds to smaller courtyard residences. And the objective was to build a tool that could automatically scan huge swaths of territory, essentially turn the tools of surveillance towards a more beneficial cultural end. These are typologies which don't
actually currently have complete censuses. This was a way to actually effect a census of these buildings. So analysis of satellite imagery could show architects, historians, and preservationists how to trace the geographic distribution of a particular building typology and draw conclusions more accurately about the diffusion of those building types across regions. And moreover, the identification of building outlines can chart morphological variation within a particular typology, or even quantify the range of similarity or difference in the built fabric of a city or region. So really, this was a way to try and make this longstanding practice of sort of comparative morphology somehow a little bit perhaps more scientific, but also at the same time vastly increase its scale. So with the extant plans of our scanned building outlines, we can also infer the interior organizations of extracted building outlines. So on the one hand, we have a series of neural networks that are affecting this classification, and on the other hand, a parallel series which are inferring the particular interior plans. So that provides us with planimetric information on each of those typologies and allows us to essentially infer not only the sort of exterior envelope or understand the exterior envelopes in relation to each other, but also infer the variation of interior properties and spatial conditions. So we can really generate the sort of deep structures of those buildings from those classified outlines. So the collection of these floor plans produces self-organizing maps of spatial relationships. And such a metamorphological chart offered us a glimpse into the natural affinities and similarities, as well as differences among these diverse typologies. So essentially what we're trying to do is kind of like map the world of architecture. And if you look at a repository like OpenStreetMaps, for example, which has nearly every building footprint on the planet currently documented, this is an amazing time to actually reflect on what architecture is. What are the sort of like boundaries and limits of architecture, and how might we go beyond those? So we can take those data spolia and turn them also towards generative ends by using them to train neural networks that might imagine endless cities. So our project Horizons, which now is actually one of the earlier projects in the sort of like generative AI genealogy, I guess, is a journey into an endless elevation dreamed by neural networks trained on these vast archives. The piece represents an infinite panoramic view of catalog data, an endlessly generated elevation, and a catalog raisonné of each new building created by the system. So there's a sort of like complete feedback loop where we have the original data, the generated objects, the classification of those objects, and then the reintroduction of those into the training process. So Horizons invites you to step into a city that bridges human and machine imagination. And I think these sort of like ways of representing worlds, including things like panoramas, are kind of essential precedents and essential sort of like lenses into these rich and vast and capacious worlds of data. So this process of using kind of spolia as the base input for some much richer kind of combinatorial approach to architecture, I think we've tried to play out a little bit in some of the student work at the school as well. And so these spolia are used to create relational assemblages that revisit historical elements in sort of radical new configurations. AI also allows us to think about the remixing and recombination of styles as spolia in multipolar and meta-modern ways. So in this study by thesis student Ryo Kobayashi, pre-trained models are fine-tuned and augmented, fine-tuned on specific periodizations of Japanese domestic architecture, and then augmented with custom data sets from those historical periods. So standard neural models are thus inflected and extended with a specific authorial hand. And Henry Chung, who's a current thesis student, is using diffusion models to imagine construction details generated from construction waste. So the waste itself, on the one hand, is taken as spolia, but so also is the sort of lineage of the isometric representation. So at this moment, I'd like to consider briefly the idea of noise. Right? So data is a very structured thing. Noise feels in some ways like it's antithesis. It's a sort of denatured condition of data. So historically, noise was at least partially a consequence of media preservation through what's called the generation loss encountered through iterative copying, for example, of analog media, photographs, cassettes, records, films, and so forth. It's an entropic effect. It's something that's creating where structure is dissipating on some level. But it's also a very particular kind of like cybernetic feedback loop that gives rise to this through duplication, replication, and a kind of genetic drift. AI is interesting because it reverses that process. It's kind of like anti-entropic. You begin with noise and then converge towards higher and higher fidelity representations. It flips the gradient of what you typically think of as information entropy. As continuous and differentiable models, they have the remarkable ability to map any input, any kind of noise, as it were, into a kind of structured and legible and coherent result. And so this is one of the I think kind of like remarkable things about these models is they're sort of sense-making machines. You can feed them complete garbage and they'll create something which is actually feels entirely coherent. So all of these images are actually generated from the same prompt, right? And that prompt, in this case, is this, which is complete gibberish, noise, as it were, right? But at the same time, these models are able to produce kind of finely detailed, very specific and coherent sorts of images. So it's somehow like a testament to the fact that from any starting point, you can reach a sort of interesting, sort of curious conclusion. But this also calls to mind, actually, some of the very kind of Oulipo experiments around language, which were essentially creating something kind of like, I don't know if it's exactly noise, but some random combinatorial process which would create some sort of poetic expression. In some ways, these diffusion models are kind of like a way of making very coherent kind of like Dada structures from input, which can be completely incoherent. So we're kind of fascinated by this sort of relationship between nonsense sentences or sort of like paradoxical sentences or paradoxical input and the results that might come from these kind of diffusion models. So we tried to extend this inquiry recently with a project that we called Twilight Crystalline Models Hunt Wistfully, which is a multi-channel video projection that tests models and language as entangled modes of architectural representation. So the project was partly informed or inspired by linguist Noam Chomsky's grammatically illogical but poetically evocative nonsense sentences, such as colorless green ideas sleep furiously. So Chomsky wrote a sort of series of essays around these kinds of nonsense sentences and what they meant as a way to sort of like reveal the structure of language. It also sort of like extends ideas and notions around impossible objects from perceptual psychology. So the project originated with a purely textual exercise around the creation of hundreds of strange, cryptic, or indecipherable descriptions of models in an attempt to find moments of failure, actually, in these diffusion models' sense-making abilities. Could we find a way for it to create somehow incoherent images? Could we find a way for it to create noise? So the video shows a recombinant image of that process of sense-making. And then on the right, you have this diptych of sort of like the human legible image and then the machine process, human legible image on the left and the machine process at the right. Now, one subtle but important piece of this visualization is this activation map. So we've talked about maps so far as things which are very expansive. Here we're talking about a map which is very specifically about perception around a specific image. So this activation map shows the machinic view of an image, which is noisy, but also sort of suggests a sort of like level of attention or specificity about what the machine is transforming or attending to at any particular moment. So it's revealing not necessarily the psychology of the machine, but it's revealing something about how it's operating. And we also actually tried to visualize, to the extent possible, the sort of like underlying weights of this very sophisticated matrix operation. So here it's a little bit subtle, but you can kind of see these very light sort of inflections or fluctuations or transformations of the underlying weights as the neural network is converging towards a coherent image. So if we can use AI and machine learning to reimagine architectural form, perhaps we can also look towards insights for better use of material, and in particular, seeing material waste not as noise, but as spolia, something which can be reconstructed or can be reused, can be placed in sort of like a recombinant frame. So architecture and cities are calamitous engines of waste. Our industry has to confront the enormous volume of demolished waste, something like 30% of landfill volume. But what if AI might hold the key to turning this waste into new building? So our answer to that question is a piece that we call Mind the Scrap, which is a data-driven process that designs new structures from existing waste. Using a custom-built 40-dimensional machine learning engine, the project stitches together irregular construction scrap into new forms. Like assembling an unknown puzzle from denatured fragments, Mind the Scrap finds the unique best use of each piece in a new structure through a process of scanning, classification, ML sort of segmentation, and computational geometry. So with it, we can match what we have with what we want to build and find beauty and intricacy in neglected waste. So Mind the Scrap essentially uses big data to tackle big waste. So recently we opened a new show in Shanghai that featured a large version of a kind of geometric proof of this process, a fractured, fragmented form negotiating past and future. So this object essentially begins, the architect can sort of like specify a sort of desired form, but then that desired form is matched to the underlying library of scrap that's available. And then as that happens, there's a kind of negotiation between that desire and the sort of envelope of possibility. So we've tried to take a little bit of this process into the field by disassembling existing buildings and scanning their components to create catalogs of waste as a resource. So here we see a disused vacation home from an East German nudist colony that we were gifted, which is deconstructed and exhaustively cataloged. And the forensic scanning process allows us to go beyond the sort of geometric dimensions, which in this case are relatively simple, to also aspects of sort of color, weathering, and with the right sort of tomographic scanner, also certain aspects of structural properties. So this scanning process then enables us to reconstitute all of those fragments into possible new dachas. And we see buildings actually as temporary states of matter whose initial and final states are actually part of the design process. And we can imagine a database of scrap pieces that exists on the digital cloud becoming a sort of shared resource for that project. So here you see sort of like a full-scale fragment of this, this dacha of the past future, sort of assembled at Futurium, Museum of the Future in Berlin. And one of the things I kind of enjoy about it is we also have these sort of like fragments of 70s wallpaper which have somehow been Rubik's cubes together. And so there's this idea of sort of like the cultural spolia, even of those interior fragments, which remain and are sort of echoed in this new structure. So we've extended this process to some industrial partnerships as well. So in collaboration with the Austrian concrete company Reeder, we've been using Mind the Scrap techniques to design intricate panels of fiber-reinforced concrete from Reeder's waste stream. So fiber-reinforced concrete is a sheet material. It's cast, and then it's sort of water jet cut. And it produces, like any sheet material, often produces offcuts and occasionally waste. So as I mentioned, with all of our projects, there's a sort of like dyadic investigation on the one hand of a sort of like data mapping project, and on the other of a physical manifestation. These are the sort of data visualizations and navigation tools that allow Reeder to sort of like recombine those elements into new panels. And here you can see recently the sort of proof of concept of this project for a new building on Reeder's sort of factory campus. So this is a very interesting process, which I won't get into too much detail around, but for this particular process, we're actually taking a certain percentage of offcuts and sort of waste, and a certain percentage of new material, which is basically wood. It's not exactly new material. It's sort of somewhere between completely new and sort of like partially reused. But anyway, you can see that here you have some very large pieces, which are the original scrap pieces, and some longer linear elements, which are these partially recycled pieces. So yeah, you have this sort of like patchwork gradient effect, which I think is, I don't know, it's pleasant in the alpine environment maybe. So we can look at this process at a sort of larger scale, but also at a smaller scale, at the scale of products. So we have obviously been very inspired by the sort of like Japanese craft of kintsugi, which many of you may be familiar with. It's this practice of sort of like reassembling shattered ceramic vessels with sutures of gold as a process of repair. Now, we're not interested in reconstructing sort of shattered vessels in exactly the same configuration, but rather interested in thinking about that as a sort of pretext for imagining new kinds of vessels. So this project, Kintsugi++, uses our ML process to imagine a machine trained on the delicate art of mosaic. And so the project is a response to the intentional shattering of those kinds of ceramic vessels in very high-end ceramic studios. So we produced a series of these pieces that we couldn't quite afford gold, so we had to go with a 3D print. And so we have a custom 3D printed frame for each of these pieces, which has been, again, sort of reassembled from this ML process. So here you can see a few of the resulting prototypes. So this is also staged as sort of an immersive projection. It allows the viewer to enter this kind of like dream state of the algorithm, to be surrounded by this galaxy of fragmented shards in the process of recombination, reconstitution. So many of our sort of media installations are trying to communicate a kind of intuition about what's happening with these sometimes very arcane and very black boxed sort of processes. So, of course, architecture is fitted everywhere with ceramic fixtures. We recently partnered with Laufen, a high-end Swiss fixtures company, to apply these processes to sinks, toilets, and other essential but oft overlooked home technology for an exhibition in Vienna last year. So here you see a similar machinic scanning process of fragments of ceramic fixtures. And the patchwork zones in these reconstructed fixtures actually indicate the use of biomaterials. So one of the things that we're more and more interested in is actually not necessarily the reconstitution of things entirely from scrap, but how can you think of a sort of like hybrid or multi-material sort of assemblage that leverages the strengths or the sort of possibilities of other materials as well. So in this way, we're trying to enable the sort of right to repair and perpetual circularity through data models and generative processes to rematch and reassemble. We were interested in this process of sort of like reuse of spolia down to the level of the ephemera that were used to advertise the exhibition. So these are actually old flyers for the Laufen Gallery that were reprinted with our information. So trying to go all in on the circularity here. So this, eventually we hope to think about the scaling up of this idea to a global material bank, stitching cities together in a common cause to create a more circular and open building process. So this artificial material database, combined with current and future biomaterials, might offer the possibility of a city whose perpetual reconstruction is a living process, a city more alive in every sense than we've seen before. Okay, so as we consider AI not only as a medium of design, but also as an increasingly common embedded capacity of our built-in manufacturing environment, data as a representational medium offers a way to construct worlds in which AI agents are autonomous occupants and shapers of our built environment. So in effect, a post-human condition demands that the design of worlds, or it demands the design of worlds suitable for artificially intelligent occupants. So if we were thinking about AI and ML as a sort of like medium of design investigation representation, now we're shifting slightly to think about, well, what is the world in which those capacities of artificial intelligence are ubiquitous? So autonomous vehicles and robots offer the possibility of a city that's literally reshaped on the fly. In its promotional video for the 360C concept car, Volvo trumpets a world in which autonomous vehicles shuttle passengers safely while the interior transforms itself into innumerable configurations, quote, a sleeping environment, a mobile office, a living room or entertainment space, close quote. The house that travels of its own accord, stuff of myth and legend, is rapidly becoming a tangible possibility with the advent of autonomous vehicles. So autonomously reconfigured homes are part of an ongoing research project in domestic logistics that reassesses the architecture of home on technological and logistic grounds, particularly in relation to artificially intelligent entities. So in particular, is very interested in looking at this history of home robotics, the history of sort of like speculated artificially intelligent sort of compatriots or domestics. It tries to inventory the many ways that autonomous robots have been imagined to transform the home, and also speculates on how those transformations might continue and intensify. So these are a few sort of like house robots, for example, that we imagine could appear in the coming years. So. In a complementary fashion, we've undertaken a series of projects that imagine the robotic home as a kind of recombinant urbanism in miniature, a platform for recombinant space. So on the sort of like very geometric level, we imagine these sort of like pirouettes and sort of like synchronized choreographies of domestic robots creating dynamic and recombinant space. But then we also think about how these artificially intelligent entities will have their own loves, desires, passions, hopes, aspirations, and how the space of the home will increasingly become this sort of space of negotiated interactions between networks of agents. So will tomorrow's house come alive? So wondered architect Roy Mason and futurist Lane Jennings in 1969 when they ruminated on the coming computerized home. Riffing on Le Corbusier's famous dictum, they argued, quote, today the house is a machine, But with the addition of a computer brain, the house of tomorrow may more closely resemble a living creature, or perhaps a collection of living creatures. So this is our project, Home is Where the Droids Are, which explores the proliferation of autonomous objects that will surround us and that increasingly define their own trajectories through whatever the analog for life is for them. It asks the question, what if we don't insist on the humanization of domestic technology, but instead animalize it? Here we see a vignette of this future home populated not only by human occupants, but also animalized machines. So if in the previous video I showed a bit of the sort of like human experience of that space, this is the machine experience of that space. So through the lens of machine vision, you begin to sort of understand or gain an intuition about how they're navigating that shared social armature. So in an extreme case, the house could dematerialize into a constellation of choreographed house robots. That's exactly what we imagined with the Berlin buoy, a house composed of autonomous droids. So in the Berlin buoy, every human activity aligns with one or more machine services. An entourage of drones, droids, robots, smart objects, and other digitally augmented devices is matched to the specific actions of domestic life, and then synchronized in a minute-by-minute daily schedule of its occupants. So here we see a spatial diagram of that hour-by-hour pulse of life. Helper drones and autonomous furniture create on-demand sort of living for the occupants. The spatial diagram becomes tangible architecture in the context of the Berlin buoy, which is really more like shelving for these drones than a real house. But it evokes this line from Khalil Gibran, which I found kind of beautiful. Does not your house dream, and in dreaming leave the city for a grove or a hilltop? So as we imagine worlds shaped by AI, we may well reflect on the role that data will play in the shaping of our future planet. But first, a brief look back. On December 24th, 1968, the crew of spacecraft Apollo 8 became the first humans to witness the shimmering Earth ascend over the barren surface of the moon. Their Earthrise photographs electrified humanity, activating a sense of collective destiny not only between human nations, but with the Earth itself. Historian Benjamin Lazier called this the Earthrise era, when the image of a delicate world could, quote, organize a myriad of political, moral, scientific, and commercial imaginations. Of course, the space age coincided with the information age. At the other end of the call, on mission control, we see a fragmented array of monitors, images, text, charts, readouts that collectively paint a patchwork portrait of the closed world of the space capsule. So what you have are two worlds that are tethered by telematic information processing. On the one hand, an entirely coherent picture, and on the other, this sort of like patchwork assemblage. And I'm always kind of like fascinated by that sort of dichotomy of the sort of like data view of things and the sort of more coherent, somehow human view. At the same moment, experimental media environments brought visitors inside closed worlds of light and image projection, communicating intuitions of increasingly complex world systems in ways quite similar and parallel to mission control. Projects like Stan Vanderbeek's Movie Drone or Ken Isaac's Knowledge Box constructed mediated worlds within the confines of a single room. So we drew inspiration from these data worlds as well as the many planetary architecture of the past century and a half for work on the final project which I'll present. This is a project which is an exhibit for the newly opened Museum of the Future in Dubai, which I think I'm required to say this every time I talk about the Museum of the Future. It's built to transform our very perception of the future. Okay, there you have it. It's a home for immersive environments that position the visitors in an empowering version of the world of 2070. And so the premise of the museum is you walk into the world of 2070 and experience a range of different environments that try to anticipate that world. So for the museum, we imagined a future observatory for planetary ecology enabled by AI. It's a kind of control room, panorama, and incubator for endangered species developed to address the ongoing challenges of the climate crisis. It's a culmination of a floor-wide exhibit that presents a fictional HEAL Institute, which is an NGO tasked with the gathering of the planet's genetic material, engineering species capable of meeting the challenges of that extreme climate, and redeploying these into the world. So the space consists of two experiences, the geoscope and the nursery. The geoscope is a quantitatively driven global monitoring system that visualizes the progress of bespoke species deployed in threatened biomes. It combines physical models and dynamic projection mapping to show symbiotic interconnections across scales. So you may recognize the term geoscope. So this is a conscious response to Buckminster Fuller's geoscopes, which saw the world as, or which saw Earth as a kind of world game, really thinking about processes of extraction. What we're trying to do is kind of like reformat or recalibrate or reassociate, recode as it were, this idea of a geoscope to center the Earth itself. And to think about this as something which is not extractive, but rather remediative and therapeutic. We see a world in which this geoscope has a replenishing role, in which humans have a vital role. It represents a continuously changing view on a network of monitoring stations across the planet. The coordinating AI dynamically connects with a number of human and non-human agents, connecting them together in a sort of post-human sociology. An integral part of the geoscope are the myriad vignettes that show in zoomed-in detail the thriving species introduced by the HEAL Institute. These include, for example, signal comb jellies and cryptobiotic wildflowers shown here. The geoscope also affords glimpses into the research of the scientists who work tirelessly to confirm the success of re-greening the Earth. So we got to play a little bit of dress up for this, which was actually quite a bit of fun. We sort of demonstrate a little bit the field work that these scientists would continue to engage in to document the progress of those species. And we even witnessed some moments in the labs of careful analysis and preparing those samples for review. So the geoscope becomes an integrated multi-scalar panorama of an optimistic possible biofuture. Now the second part of this experience is the nursery, where visitors peer into incubators nurturing dozens of species that could revitalize a struggling planet. So we collaborated with a geneticist, sort of different kind of data, to design 80 species of plant, insect, and animal, each with special remediating characteristics. The nursery shows the accelerated growth of each of those, enhanced by holographic data profiles of each of the specimens. So drawn from a range of biomes, we imagine species such as nutrient jelly cactus, radiation sequestering flowers, seed dispersal snails, which collectively create a sort of biological menagerie. So this is a supercut of all the physical models. We worked with a highly skilled German art fabricator, ID3D. They're basically sort of doing things that I think is hopefully at the level of a natural history museum, because our thought was that this is sort of like a natural history museum for 2070. Each species, including the microscopic ones, was carefully researched, complete with scientific names, specific climate robust features, and estimated life cycles. So across 7 major ecosystems such as desert, aquatic, arctic, forest, swamp, alpine, grassland, we imagined the biochemical talents that would be necessary to respond to those 21st century threats, orchestrated by a consortium of humans and artificial intelligences. So through all these projects, just to conclude, we probed the possibility related to fragments of spolia: digital, physical, biological, spatial, cultural, for certain vocabulary of the future of design. Through data, designers can probe paradox, map pasts and futures, metrize what was once unthinkable, and hopefully dimension the space of design itself. Thanks.
I do have some questions, but we're going to hear from the crowd.
Thank you so much for the inspiring presentation and work in general. Simple question about when you were talking about the diffusion models, your use of diffusion models, and how they are in a way sense-making machines. I was wondering if in a way, and this is a bit of a speculative question,
The most fun kind.
I hope. We could, in a way, think of these models as replicating particular types of, let's say, structures or modes of thinking that have been with us for a long time. And I'm particularly thinking of, particular models in philosophy, such as Neoplatonic philosophy and so on, in Renaissance times, and so in which, in a way, what we do is nothing but recombining and refinding sources and meanings that are already kind of contained within structures. And of course, these are widely different worlds, and I'm aware, but in a way, I see certain parallelisms as if we, from a cultural perspective, we could comment on these models, specifically thanks to these types of experimentations. And we have a glimpse of what they mean generally for our endeavors, beyond the specific technical specificities of how, denoising and so on and so forth. But actually, what do they do with our epistemological structures? And of course, it's very wide kind of comment and question, I'm aware, but I'm really curious about your views on that, in the sense like, do you think, are they helping us push the boundaries to get to new things, or are we, in a way, recombining our sources in different forms?
Yeah, it's a really interesting question, and I think there's two aspects of that. I think first, implicitly, there's this question of, which I think is like it's a very live question, obviously, in philosophy. Is like, is there a theory of mind for AI? Is there a theory of mind for neural networks? And I think it's been an open question for some time. Has become very relevant, I would say, in the last couple of years. One of the things which doesn't answer entirely, but I think begins to shed some light on that question, is this sort of like black box quality of many of these kinds of models makes it difficult to sort of validate or falsify any sort of claims around that. But I think there's been a fair bit of work actually in the last couple of years, and just in the last year especially, where there have been processes which allow basically like the automatic interrogation of models in ways which are not intended to produce something specific, but are rather intended to test it. And so what that testing does is it begins to reveal specific patterns of response, which indicate deep structures within the model itself. And so that's beginning to actually like shed light on what the kind of like, deep structure of those models are. And I think at that point we can begin to say, okay, well, if this model has this particular sort of like characteristic deep structure, this model has this characteristic deep structure, and the two are like not isomorphic, then maybe something interesting is going on. So, again, I think it's sort of like a developing question, but I'm optimistic that process is sort of like essentially feature extraction from the models might begin to give some insight. And then I think there's also this sort of like what you alluded to, sort of like this convexity question, right? So if, even if we have this sort of like vast amount of data, are we essentially just navigating within this sort of like very bounded horizon? And, I think it's an interesting question. I mean, I think there's a question of whether the horizon itself is so vast that maybe it doesn't matter, it like crosses somehow some cognitive threshold where it's close enough to infinity or something like that. But for me, it's actually, I'm probably more interested in asking a slightly different kind of question, because I'm interested in exactly those kinds of cognitive boundaries from a human perspective. So, are there ways that AI can begin to sort of like represent or indicate or sort of help us to understand the boundaries of a discipline as they've existed up to this point and potential ways that it might move forward? So that's part of the reason why we're so interested in these mapping processes is, I'm interested obviously in not only in mapping the space of existing architecture itself, but also even more potentially, the space of terra nullis. It's like, where do you fall off the map? And what does it mean to fall off the map here? So even if AI is sort of like creating, even if it is convex, it's bounding what we've given it and what we've created so that we can better understand where we might go next. So I think this idea of seeing the blanks, the void space here, and the sort of like charted space as complementary and equally interesting, for me that's important, and I think maybe a promising direction to think about these kinds of issues.
I would like to complement what you're asking in relationship to two projects that you show. The first one on the paradoxical sense-making machine.
Yeah.
So you have a paradoxical input, and then anyway something the output is already produced that we can read sense on that. And then you have your artificial agents. So I want you to if you can make a connection between these two projects, because lately these artificial agents are powered by these large language models, which means that they are supposed to understand our sense. They're supposed to know what we mean. And if you're having these two projects in parallel, how will you, if you could make a link between them, especially with this idea that you're talking about knowledge, which I think they know. Like this would, I agree with Volker saying that now with these large language models, those models they know, and that brings possibility for humans to imagine what will be there if it's already known, since they've read and seen everything. So I really wanted to see if you could map these two projects in a senseless knowing manner. I don't know if I'm making sense. I was reading them in parallel since you brought them to discussion. If you had any idea or your reasoning behind having them in the same presentation.
Yeah. I think it's a really interesting parallel. I mean, one of the things that I am really fascinated by with respect to certain applications of AI is not so much, well, I mean, obviously I'm interested in this sort of like cognitive or epistemic issues of the models themselves, but also how do you think about models whose main function is actually translation, right? So I recently did a piece for AD that talked about this specific application of AI. In this sense, the AI doesn't necessarily need to know things in sort of like a very expansive sense. It just needs to be able to sort of facilitate communication between two systems which may be very, very different. And so there's been a lot of really interesting work around the application of those kinds of processes for machine translation of animal language. And this is what I think is actually really interesting about this question of kind of like large language models and their sort of like knowledge status. You can imagine alternate models which are somehow not trained on human language, but are trained on animal language, for example. And the question would be like, okay, well, are there deep structures there which are common, or are they fundamentally different? Are you knowing something differently by sort of thinking through or sort of like representing that knowledge through that kind of language? So, I think that question of meaning then becomes, it becomes a broader question than meaning that might be understandable or legible to humans. It becomes, can you talk about meaning when you're representing these other forms of communication? So, I mean, maybe that's to sort of like take the post-human interest. Maybe it's like a bridge too far, but I think it is kind of an interesting question. It's like if you were to think about a large language model based on, whale song, is it going to be something that's fundamentally different? Is it going to tell us something different about reality than what our large language model is? Does it represent a different kind of knowledge? And I think that's also kind of my interest with those agents also, is that they may not be based on large language models, but actually totally different kinds of models which give them a different kind of epistemology in a way.
I'd like to keep asking them. The idea of knowing and communication is built on language, but that's not the only way that we create thoughts or what we imagine, right? So we have different ways that our story, that and only language is one way to decode that to the world. And I think it's a very interesting way that you're talking about these agents as being able to decode something that is not language, but it's something else. And I would like to ask about, will you, like, I think your last project was trying to test us on the limit of how we're living in the future. How do you imagine now us, I mean, you show us, yes, but could you elaborate a little bit more on this idea of these artificial agents, not in the sense of these big tech companies that are saying a robot will cook for you, but more about be an active agent within your living, within your existence, that is not trying to please you, but is trying to really inhabit a space. Like the house itself, it becomes a space for your agent to actively inhabit together.
Yeah, I mean, I think one of the key things, and it's maybe kind of like elementary, but I still think it's sort of like it bears pointing out, is that I think as we're sort of in like the very early stages of a like Cambrian explosion of AI, right? We have a few different species popping up here or there, but there's still some very large kind of like monolithic models which are taking a lot of space, right? But I think over time, those models will probably diversify further, and we'll really be thinking about, or we'll be living in a society that has a whole range of different agents with very different kinds of capacities. One of the things that we're really interested in is this sort of like idea of sort of like sensory ecology, which is like how do species sense differently? How do they make sense of the world differently? And then the corresponding question of kind of like mental faculties or mental capacities. Inevitably, what will happen is that as these species diversify, we'll be dealing with them in very different tactical ways, and also they'll ultimately sort of engender different kinds of legal rights and political rights potentially. And I think that's a huge open question. One of the biggest open questions I think around AI in the future is like, okay, once you do have these autonomous agents, what does it mean in terms of those kinds of rights? So it goes, it goes well beyond the sort of like question of pragmatics to those sorts of legal status around ownership, around liability and culpability. In fact, I think one of the main reasons why architects will be around for some time to come is that you have to have someone who's legally culpable and who you can punish for things going wrong. And you can't do that with AI, really. So we have that on AI, I guess.
That's a very interesting bridge to the idea of ethics and responsibility that comes to every single AI model that is being released. And if you think about civil engineering, I'm just making a very clear distinction between what's happening with software engineers and civil engineers. Civil engineers are responsible for the bridges. If that collapses, we know who to blame. But now we're living in a world that software engineers are developing these models that are bringing a lot of new ideas, concepts, and even helping in decision making, but non-responsibility is being attached to someone yet.
Yeah.
So I think what you're saying is probably the idea of designing environment is not about only the physical matter, but everything that is sensed through these agents.
Yeah.
That's very, very interesting. That it comes, if you use those instruments, right? If you use those models, if you are aware of what's input-output, then you become attached to how people will experience. I don't know if I'm like maybe also.
Yeah, you're imbricated in sort of like a chain of events, and one of the things, of course, people are probably familiar with this like landmark case around Uber and sort of like, or not Uber, around sort of like what was it? It was like the Google self-driving car fatalities, like the early fatalities from those kinds of experiments. The question was, well, is the software at fault? Is Google at fault? Ultimately, there was a driver in the car who was only there as a safety factor, but they were found as fault, and it's partially because AI is understood as a product still. There are things under US law, at least, called artificial persons, but artificial and natural persons have very distinct sorts of rights. And so, for the time being, the only natural persons are the people like we see in this room. But it'll be very interesting to see how that develops in coming years.
I feel like I'm about to share it, so please do.
Yeah.
No, I just, I really, really love the work, and especially the strain of humor that runs through it. I am specifically a fan of these characters that move around in the house.
A little twitchy.
Yeah.
Yeah.
But I'm curious about this kind of age-old architectural question that does space emerge out of things? Do things, do objects, do active characters, do they engender space? Or is it that there's another level of abstraction where a space hosts these things? You know, and I know that there's no real answer to that, or let's say lineamenta and ornamenta with Alberti as well. So I'm just wondering, how do you see the future of the home? Does it become a landscape of things that become disparate? And I don't know, how do you set boundaries within that? What would be the spatial implications of that if these agents start to engender their own spaces?
Yeah, I think it's a fair question, and I think for us, we see ourselves as sort of like transdisciplinary designers as much as architects, and so we're very omnivorous actually in thinking about how these questions could be made relevant in different scales and contexts. But yeah, this boundary between sort of like space and furnishing, I think is a completely apt one. I mean, I think pragmatically over the next years, what you'll see is sort of like a dematerialization of different aspects of the home, but not the entire home, right? There's an armature that will always remain. But I think the interesting question is going to be sort of to what extent that becomes dematerialized. I mean, already most of our entertainment is dematerialized, and there are certain things which will continue that. You know, there's also services which we think about as typically kind of like individual or sort of like in a specific apartment or house, which can be also sort of like shared, and so there's a kind of like arbitrage that can happen there as well. You know, I think ultimately, look, I mean, we've lived for a long time with sort of kinetic architecture in one way or another. We have doors, we have windows, we have all these things that actually operate in a kind of dynamic way. I think the possibility is that those things will, with this kind of autonomy, begin to rebel. And then that is when things really become interesting, is when we start to have arguments and disagreements with the house, and then that becomes very, very, very messy. Yeah.
To this kind of project, where do you see the possibility of scaling up these kind of projects, and what do you think the role of generative AI could play in this kind of vision?
Yeah, I mean, one of the problems that we were most intrigued by in that sort of set of projects was, how do you take very, very unstructured data and somehow make it usable? How do you create noise and make it data on some level? And so, there's a whole bunch of like tactical questions about how you sort of like scale that up more widely. But the basic premise is that, or the sort of like, the focus of the project is to make that kind of process very flexible and very general and very sort of like adaptable. So to the extent that you are really just sort of like, that you are taking this raw unstructured data, it can come from sort of like a whole range of different sources. So like the feedstock that we were working with originally was actually just like random offcuts that we found. It wasn't, in the case of the reader material, they had a lot of data about what they were actually cutting. But with our first experiments, we were just taking very, very random sets of information. I think where it starts to get tricky, and one of the biggest challenges in this space is like, how do you regrade materials after they've been used? And this is one of the biggest issues around sort of like especially reusing structural elements, for example, there's a very rigorous kind of process that usually has to be gone through in order to regrade that and recertify it, which is really makes this, that's one of the most sort of time-consuming and sort of like cost-intensive parts of this process. So I think that's an area of some very interesting further research is like, okay, well, how can we think about the regrading of materials in a sort of like efficient and productive way? Because I think other aspects of like the geometric aspects of the problem and things like that are a little bit more tractable, but a lot of that stuff has to be very material specific. But there's a lot of work to be done there.
Maybe I have one more question.
Yeah.
So I've also this Kintsugi project that you showed earlier, and then this idea of spolia. So I guess an observation would be that these diffusion models sever ties to any kind of data that they have been trained in, and they start blending things together to a level where they become you cannot possibly unfold them, let's say, to their indexes. And then I'm wondering what would be a possibility of the stories to remain present there. Much like spolia, for example, it's important that in Venice that it's the history of the Fourth Crusade and this and that. So you
That's
know
interesting.
where things are coming from.
Yeah.
I'm wondering what would be a take on indexicality, because they completely kind of chop it off, right?
That's a really interesting question. There is some work being done currently around traceability of training data, which I think is, it's very closely related to your question. And I think that's, it's funny because the process of training a model it's an encryption process. Basically, you're taking all that stuff and you're encrypting it into a weighted model. The question is, how can you create something sort of like through that process of encryption, which is basically throwing a bunch of stuff in the meat grinder? How can you retain certain aspects of that? And that's an area of research that I don't know a lot about, but I know that there is some really interesting work on that. I think it's related to this wider question in architecture of provenance. There have been a couple of really interesting companies recently. SourceMap, for example, I know is one that's looking specifically like provenance of consumer products for carbon chain mapping and things like this. But there are other applications, and that's sort of it's the flip side of all of this. It's like here we're thinking about how do you sort of like take those things forward, but really how do you sort of like connecting it with these sort of like deeper historical, cultural, possibly carbon chains, I think it's a relevant question. It's related to this question of kind of like regrading, right? It's like how do you analyze something and determine its provenance later? Yeah.
I might have another question to you, and just following up on Anna's point. I really enjoyed your talk a lot, and I love many quotes, like for example this idea of like buildings as these like a temporary state of matter, something like this.
Yeah.
You were speaking about how these neural nets, they are these kind of machines that try to make sense out of noise, and there's this like constant process from a noisy and entropic kind of process to like this like trying to recombine again to make something that makes sense, then again like a loss process, and so that this race. And I can think of maybe building as a long-term process.
That's interesting.
As well.
Yeah.
So like you have building, it falls into disrepair, it's patched up, then things are taken apart, and it becomes a new whole that is made from parts, but like we don't see the parts, we see it as a new whole, one building, and then again it falls into these like cycles. And then what I'm quite fascinated thinking about is what kind of new roles can the architect open up if one sees oneself in this kind of position of picking up these things. So like what things to pick. For example, when you were showing this project in the allotment, the kind of the constraints of the range of your picking, let's say, comes from a very physical location, and all like trying to make the most beautiful thing out of the things that you find in this place. If now one thinks that like we are also like if one thinks of spoils, there are of course the spoils that come for very pragmatic reasons, the things that are being taken from nearby to build that new cathedral or build that thing out of that old temple that nobody uses anymore. But there are also the spoils that are completely charged with meaning, like I don't know, like the obelisks in Rome in the 16th century and so on and so forth. So how is this picking process, like picking things, bringing them together into a new whole, things that might be very distant, either geographically or semantically or like from the history, like if you can see and you have a IKEA race and then you put a moon race next to each other, like really generate something that has of more value or of less value. And I'm just speculating or thinking like what kind of new place do architects can tap or step into when these possibilities open up?
Yeah, I think it's a great question, and also kind of like brings us, I think, to a different linguistic approach, which is, obviously there's this very specific kind of approach to reading and legibility that comes from postmodernism, right? So there's this famous essay by Mario Gendelsonis, which is all about legibility and reading. And I was rereading that essay recently, and he has this very funny moment where he's like, reading, I'm not going to be able to quote exactly, but he's basically like, reading is the antithesis of engineering, and in fact, when you're reading, you're like surpassing those kind of like mathematical processes, for example. And I'm like, well, we're in a moment where actually machine legibility and human legibility are sort of converging. So that dichotomy is sort of no longer relevant. But one of the things that was, I think, that postmodernism sort of like brought to the fore was a sort of sensitivity for those kind of like cultural references. And I think there's an aspect of architecture which, I don't think it was ever lost, but maybe need to sort of like reattune or resensitize itself to exactly those questions of cultural associations of specific artifacts and remnants. So it's no longer about sort of like creating something as a whole which has those sorts of associations. It's about creating like this, or thinking about this sort of like polyvalence that comes from all of those fragments. And when is it appropriate to have those fragments together, and when is it more appropriate to do something that's new in combination with them? I think it's a really interesting set of questions. I mean, I think to answer it precisely, you'd have to think about a very specific project and work it through in a sort of, work through the particulars of that. But one of the things that I think is also great is that you can begin to think about maybe wider or broader sets of meanings for architecture than may have been typical before. And you could begin to think about those sort of like intentional juxtapositions or intentional dissonances, which might then create, which can also be sort of calibrated and refined for specific architectural meaning. So it's, I'm not necessarily a fan of postmodernism, but I do think that aspect of sort of like semantic sensitivity, as it were, is something that these processes bring renewed relevance to that, and in fact to the whole practice of reading carefully, actually. Reading at a sort of like cultural level. Yeah, it's, AGI, we're obviously not at AGI yet, but some of the ways that we're currently working with AI tools, I think will be sort of, will set the stage for how we might encounter or work with AGI later. I mean, already people, Copilot, this idea that AI is sort of like part of the team, it sort of like has a place at the table or something like that. There's already a kind of like sense that that's the case. But at the same time, I think people feel, there's some way in which there's some anxiety about AGI having an almost like omniscient quality to it, and having this sort of like, I don't know, it will be superhuman, but at the same time, I think there can be limits to that, because there are certain ways in which humans communicate that sort of bound them automatically and sort of create some sort of limits. And I think that those AGIs, as they develop, will tend to see them less expansively than we imagine we will now. I can imagine that we see them as sort of like, I don't know if it's coworkers, but sort of someone that we delegate something to, right? An assistant or something like this. And I think a lot of the sociality that currently exists will sort of carry that forward to some extent. I mean, the truth is, I don't know, and I'm very curious to find out myself. Hope for the best, yeah.
So we're running out of time. I want to thank you, Andrew, for your presentation and for your kind answers to the questions.
Thank you.
We're going to just like 2-3 minutes.
How does it work actually? So like, can I still get the slide, like a presenter view?
I'm not sure about
So is it freestyle for me? Do you or?
try. You can, or do you want to put something like that?
Then I have to double. So so it's not extended. It cannot be extended. I see. Maybe I have to read some script. Is there a power for this? Oh, yeah.
How do I pronounce your last name? Frederic?
Kim.
Kim. Should I say Chando?
Chanda? Yeah, Chanda is good. That would be amazing.
Okay, thank you. We're going to start the second lecture to panel number 1, and we're happy to have with us Frederick Chando Kim. He is an architect, researcher, and educator based in Lausanne, Switzerland. Frederick is pursuing his doctorate at Media X Design Lab at EPFL, where he also teaches at the School of Architecture and Computer Science. His research examines the generative and analytical possibilities of machine learning and computational geometry and architectural form. Previously, he taught as a junior faculty member at ETH Zurich and conducted workshops at ETH Singapore, SUPSI in Mendrisio, and D-Lab at Kyoto Institute of Technology. He holds a Master of Architecture from Harvard GSD and a Bachelor of Science in Art and Design from MIT. In collaboration with Michael Johannes, he heads creative data critical design, exploring innovative ways of using data for architectural and urban design approaches. Frederick has worked with various architectural firms, including Convergio in Lausanne, AGPS Architecture in Zurich, Los Angeles, Safdie Architects in Cambridge, Massachusetts, SOM San Francisco, and Gensler Los Angeles. His recent work on artificial Swissness, Design Brain, was featured at the Seoul Biennale of Architecture and Urbanism in 2021. He co-authored a journal paper on GANs, NLPs, and architecture, winning the 2023 ACSA Best Article Award. Welcome, Frederick. The floor is yours.
Oops. Thanks, Carla, for your introduction. And it's really nice to be here in Zurich. And I just wanted to introduce myself. I'm actually also part of a media and design laboratory, and a lot of work has been done in collaboration with the team members there and the students with teaching and research. So just wanted to thank them for this body of work. And the title today is called Deep Architectural Form Towards a Machine Understanding of Architecture. The talk will highlight the potential of AI and deep learning in architectural design, in bridging the multidimensional aspects of architectural form, in emphasizing the role of creative methodologies and computational tools in crafting future designs. I just wanted to start off by this photo of, actually, is it me? Sorry. All right. Is it better now, or can you hear me? Can you hear me? Okay, sorry. Yeah. Oh, the fan. All right. Okay, cool. So this image of Zurich Main Station in 2008 is actually by BSA, the architectural organization of Switzerland. They asked all the architects in Switzerland to donate provide their competition model, this wide massing models, which is kind of critical element in architectural competitions in Switzerland. Now is the microphone working, or actually, or no? Sorry.
We're sorry.
No, I'm like, just wanted to make sure everything. Oh, it's better now. It's working, yeah. Okay, so, and I also wanted to mention in Formulations, a book by Andrew Witt, which is presented as the both conceptual and formal archetypes are the models of the architects, where the collections of models opens a range of formal aspirations and methodological strategies. So architectural form and models are deeply interrelated, as models serve as a crucial tools for visualizing, experimenting with, refining, and not just physical characteristics of design, but also enabling architects to transform conceptual ideas into tangible structures. So traditionally, the role of form in architecture has evolved significantly. Like what began as a form giving with architects as the sole creators has shifted to form finding, where technology and computer-aided systems enable deeper exploration and analysis of form. Now with the machines capable of learning from vast data, we are entering an era of form searching, where these tools offer unprecedented contributions to the design and research processes. So actually, I just submitted my thesis yesterday. So this is like kind of a summary of that work, and also like past 5 years of work, which is completely outdated with the technology that we have now. So I just wanted to say that in the beginning. And so basically, the operating at the nexus of form and data in architectural design. I'm going to share these 4 projects from teaching and research at our lab, talking about the 4 dimensions of architectural form and exploring a new way of looking at form with machine learning as a dynamic, multi-dimensional entity influenced by various factors in architecture. So those are collection of form, imagery of form, and language of form, and anatomy of form. The first, the collection of form actually deals with the figurative dimension, expanding the tangible and geometric properties, emphasizing the formal and volumetric attributes of architectural entities. So that data set we were investigating is actually a competition data set. And I don't know if you guys remember this competition in 2015, Guggenheim Helsinki competition was kind of one of the biggest competitions, and kind of controversy because it never got built. So this is the view of the website they had, to showing all the projects. And of course, as a human capacity, we can actually, this was their tagging system that they used to search the projects. So as a human, there's a limitation on how we can actually categorize this, this kind of a lot of data that we have. And in terms of a formal understanding, you can see on the left that these are like pretty much how we can comprehend, like straight, curved, circular, kind of a primitive way of kind of categorizing this data set. And the actual data set that was used was the Swiss competition data set. And the Swiss competition system is very well organized, as some of you might already know. And this particular collection was selected for various reasons. And one of them was the consistency in the data set, and also this the regulation that they have to make it all consistent, and also the data that is available in the jury report is one of the assets that was used. And during the competition, you can see kind of an example of these boards that ranges from 3 to 10 boards for certain requirements, such as like 1 to 200 drawings, 1 to 20 facade details, as an example. And a lot of times you can see this kind of a jury scene where a lot of conversations happens around this wide massing model. So even though that people actually, we look at the boards and drawings and concept, a lot of conversations tends to happen on this abstract model, because it's actually the kind of a representation of the project itself. So this model, wide massing model, became kind of a key driver of this research, where not just looking at the formal characteristics of this model, but also the competition data. And within this formal, just by the abstract form, we can learn a lot of these things by looking at the complexity of the geometry, and also the context, and also when it represents from wide massing model into a certain kind of a data format, we can learn a lot of things more than what we think. And this is an example of like one competition and all the submissions of the massing models. And the ones that were actually used for the experiments is actually the ones who got the prize winning, so who won some prizes. Because only those data were available in the jury report, like all the plans and sections to reconstruct this massing model was a part of the process. And you can see kind of on the bottom, you can see we collected basically, we collected 600 3D massing models from 63 school competitions past 20 years. And then on the top, you can see kind of the examples of it. And this was done manually, which took a lot of time. But we can see also the integration in the whole process together, because nowadays you also have to submit like a BIM models in the competition system, so we can see kind of how we can actually use these data sets for future research. So these were done in a kind of tedious way of reconstructing them, and also, of course, we also have to think about how actually back in the day, like nowadays you can actually use any number of points in the machine learning process, but 4 or 5 years ago, it was very limited. So the points, we transformed these massing models into inspired by the G code and then getting points out of all these lines and the curves. And at that time, we used 2,048 points for each massing models. And here you can see kind of the transformation of the samples of the massing models into these points. And we use the unsupervised machine learning 3D adversarial autoencoder, and basically to encode these points and then also to reconstruct these points. And during this point, we get this kind of, we call it as latent points, where we can actually spatially arrange these forms in and then figure out the formal affinity. So you can see kind of the process of how these points are learned and then reconstructed. And this is the method that we use, as also like Andrew suggested, with a lot of mapping. This is a very critical point because this is how machines read these forms, and then as a human, we have to actually kind of understand how they, how the machines actually look at these forms together. In this process, one thing that we thought about is because we're only using 600 models as data set, when these models are actually created for like thousands of data sets of cups and airplanes. So as an architect, we always have to think about how we can actually meaningfully use these models in an architectural context. And at that, if you only have 600 models, you question it, is it going to work, right? Like, so we try to like kind of optimize this process of creating something called architectural point cloud, meaning like compared to before using a uniform point cloud, that is, points are distributed equally. We try to think as an architect, can we find a way we can actually better to assist the machines to actually learn these models. So that's why the architecture point cloud was created. And then you can see how by slicing in a different ways, we can actually kind of give focus into certain aspects into the formal quality of the models. So here on the left, you can see the reconstructed model of the uniform point cloud. And on the right, you can see kind of taking a slicing in the horizontal way. So this actually represents that we can already kind of hint at it, that where there is no points, it means that there is a flat surface, right? So this kind of things that we kind of thought in the process for how we could actually help the model to learn. And also in the different factors too. What does it mean by having an actual scale of the model versus actually normalizing the scale to 1 to 1 to 1? Does this matter to machine? Does this matter to human? Like what's the difference? And there's also a way of how the point cloud was constructed in like a horizontal manner or vertical manner, or like what happens if you orient the models in a certain direction so that they're all parallel to each other. What does that mean in the machine? So these were kind of part of the investigation, and then using Tissany or UMAP to understand the formal affinities, how machine understands. So this is kind of a back-to-back human and machine collaboration. And also this research also taps into the traditional way of archiving architectural data, architectural competition. So this is one of the Swiss architectural competition archiving system, and it's very like, it's just like posts, right? Like, and then if you do more, you can actually kind of categorize it in a geographical location, different types of programs, different types, which year it is or which area it is. So like there's certain things that we can the traditional has been done before. So the new way of kind of thinking is actually looking at this kind of a spatial mapping and then affinities of the formal qualities of the models as a form. We can look at into a new way of looking at architectural archives. So this is basically, we create a platform where we can actually input the machine learning results, and then also the data set, also the metadata, not just about this formal affinities, but also like the actual traditional, the data set that we have goes also on here. So we can actually look at all these things in a comprehensive way, in a transcalar way, but looking at through the formal affinities of models. So all these metadata is still included in the part of the archive, and also looking at how these models are deployed out into in the formal affinities. So here on the right, you can actually also see a different way of organizing. I will show a video of this, and here you can also see like different colorization could emphasize on the different formal clusters or different types of competitions, or what are the rankings. And so you can actually look at this archive in a different way. So here I'm just going to show kind of a quick demonstration of the interface, so you can actually see how things are deployed. and you can actually organize like all the point cloud learning in a different point cloud system is also embedded into, see the differences between different point clouds. And also you can see you can also search by different architects also, if you select, let's say, Zurich, which is a Zurich architect, you can highlight where the Zurich Zurich's architectural projects are in terms of for the schools. So here you can actually you can also look at the formal, the similarity between the models, not just in one competition, but across different competitions. So it actually provides a lot of different way of reading these competitions all together holistically, not just one specific competition. And the gradient also represents how closer the formal affinities are. And here you can see kind of the one competition that there is an outlier within this competition. The rest of it looks very similar, but there's one outlier that has kind of different types of formal. And you can also see that who won, who in this process. Also, this tool is capable of creating a new models, basically by interpolating different forms. That was actually in the learning process. And I mean, the quality of the form is not as precise as the original one because it's only using 2048 points. But you can also see, but you can also starts to mixing unlimited number of kind of forms together. So by here you can see by choosing one form, you can actually see the in between of these two forms, and you can also start to add more forms to it. So to look at how, by basically generating more forms. So here is the third one that you can add actually. So you can see control in a way to create forms that are go in between. And this research is keep going, it's ongoing, and now that the text with the large language model, the text is used in the jury report is combined with this process. So by fine-tuning the large language model with the 3D model and a text, we can actually kind of create a system where we can actually have a dialogue with this system about each specific form itself. And the next step is the part that I was talking about. By typing these kind of formal qualities, we can actually create the 3D forms basically using these data sets. So that's the next step that this research is going. And the next project is about imagery of form, and with the introduction of GAN, we used a lot of images like a few years ago. But as images for architects is very important because it's used as a precedence, but not only helps designers to jumpstart their designs and overcome their inertia, but also grounds the resulting design in a geographical context and gives a cultural relevance and meaning to it. And the data set that we used was the Swiss alpine cabins. We basically scraped 6,000 images on the web and then downloaded 6,000 images of photos capturing the 150 Swiss alpine nuts, and then had this process, created this process of generating these images, but in a way that we can actually curate. The idea of the creation was about how we can actually, how can machines understand Swissness? So a lot of a lot of the students actually basically they curated their data sets based on what they think the Swissness is. And here you can see kind of the examples of the GAN images that was chosen by the students, and analyzing them in not just in a image, but also in a mathematical or in an architectural in definition, and also collecting this kind of a catalog of excuse me. Okay, catalog. Sorry. So something is not okay. I'll skip this one. But the most important thing in here is how we can actually translate these 2D images to 3D images. Because this is also when the creativity happens, how we interpret the 2D images into 3D. And of course, like perspectival machine has been, I mean, we've been using as an architect how we can represent this 2D to 3D. But with the GAN, it's a different game, because there's also these machines, these models are actually trained based on this kind of a human photos in the beginning, and humans, I mean, the face has actually a very structured system with the eyes and nose, but as an architecture, I mean, for architecture is very complex. So how we can actually navigate this world of 2D images with GAN into a 3D world, and you can see. Sorry, all the videos are not working at the moment, so I don't know. Okay, so, and these are some examples that, one of the sample of a data set that was, I mean, the generation of the images that was created, but you can kind of see that they're all perspectival views. So what we try to do in this research is how we can actually connect with the machine on this kind of a perspectival mindset that we have as an architect. So all the data set that had a frontal image was all deleted, because of course if you click, I mean, choose the ones that have more views, more facades, you can actually has more information than just the flat images itself. So all the the flat images was eliminated, and also with the machine clustering system, you can actually, by the results of the images that was created, you can actually cluster these with the by different perspectival views. So you can kind of map out these images are actually looking like from this view. So here's kind of a zoom in. And from this, we can actually also cluster in a way that, I mean, this is the clusteration in Ticiny that I show you as a representation, but you can also see this family of refuges that gets created within different clusters. So these becomes kind of a way to interpolate as if, sorry, I think I have to, what could be a problem? It doesn't work in my computer. I'm just going to delete all my slides and see if it works. Oh, it's not working. Okay. Could be the problem actually. I'm trying to think.
It works here, but not there.
No, it works. It doesn't work.
Could you just play the video in this view?
Yeah,
without
it's
the-
not.
Just that for the video. Stop sharing.
Maybe extending is not good.
Could you do it without the...
Yeah. Should turn off my computer now. So the idea was with this interpolation, the idea was choosing the family of refuge, Kaban, and then as if we interpolated as if we're actually turning the model itself from 3D. So that was kind of the idea of choosing the views, different types of perspectival view. That's why the clustering of different perspective views was important, to choose the images that goes across this cluster. And here you can just kind of see how you can kind of almost like as if once you kind of turn around the model, you start to see this kind of hidden part that you don't see in the one image to another image. And here you can see other examples where this is chosen kind of the same system of looking at different perspectives. So from this, as a human, we can actually understand what could happen in between by turning these views. And of course, at the end, we also have to construct this in 2D to 3D. But as an architect, we also has been traditionally and historically, we've been building 3D objects from 2D images. And one of the idea that was used was the inverse perspective projection system by Brooke Taylor. So basically, from a perspectival view that shows 3 sides, we can actually get all the informations about the facade from a single point of view of image. So this was actually used to create a grasshopper tool where we can actually put this image in and actually choose the point of vanishing points, and also actually input all these kind of architectural details that goes onto the image, and then transform that into, this is a process on the left where choosing the vanishing points and then going through the script, you can actually kind of automate this process of getting the facade, 3 facades from the image. So this was reconstructed into 3D, and this was a system that was used to create these of 3D forms that actually from a GAN image. And of course, it's important that these images actually carry all these kind of knowledge that we have of environmental and this kind of cultural resiliency that we have in the Swiss Alps. So all these image that actually holds this kind of data that can be employed into the form itself. So as students, they also interpret these images into actual facade details. Here you can see the examples. The third exploration is actually on basically on the language form, which is happening right now with all these large language models and image, text to image. So basically, wait, what? Oh, yeah. So the third chapter actually deals with the semantic dimension that utilize. So the third chapter actually is on semantic dimensions, basically utilizing the formal language-based generative AI to develop a formal vocabulary and embed semantic richness into architecture. So as an architect, we've been using language, we've been using the language in order to, in our design processes, and we make it into kind of domain-specific formal vocabularies. Here you can see Richard Serra's 84 verbs and 24 possible contexts, and also other examples of Farshid Musavi's functional form, FOAs of phylogenetic trees that shows the classification system on their projects, how the morphological characteristics of it, and also other kind of verbs that was used in the process of designing. The book that the data set that we use is actually, I don't know if you guys have seen this book, but it's 1,001 building forms, sketches done by Francois Blanchard called Silas. And basically this images was used into actually a fine-tuning process of a stable diffusion. So with the 1,001 images, and then the formal domain-specific formal vocabulary was created on this 5 different categorization, from entity to shape to direction and operation and effect. So these 5 words was used, and then this is kind of the prompt that was used to regenerate these of images. So this process, 1,001 images was tagged also manually to explain the formal characteristics of these single images. And it was done by myself because it's also Francois Blanchard's mindset of these sketches, but it's also my interpretation of how these formal characteristics are explained. So if I start to kind of divide the work, you start to lose like the consistency in how you call this, how you tag these images. And even for myself, like one day later, I forget what I tagged. So it's like, it was a very kind of process that was kind of tedious tedious to do. And this is samples of kind of the images that was generated, which is very similar to the original images. And another tool that was created is actually looking at this kind of statistical reading of how these words are connected. So the stronger the lines are, actually there's a strong affinities in how words were connected, how many times the words were connected. So we can assume that kind of if there's a less connectivity, there's going to be more variations in the image generation. And if there's a stronger connectivity, you can kind of guess that there's going to be a reproduction of the original image again and again. So here is a zoom in of this kind of system, and here you can see the results of testing the original image with the text. So on the top, you can kind of see it was able to kind of reproduce the words of the original image to the new fine-tuned model. And then on the bottom, you also kind of, it's not perfect, but on the bottom, since it's a fine-tuned, you can start to like pick up those images where there's a courtyard. So like if you type a courtyard, it will start to remember the courtyard that was learned previously from the large language model and shown again. So here's some other examples that basically using 5 different words to recreate this original image. So sometimes there's more variations, and sometimes there's more consistency in terms of the generating the images again. And then by using kind of the matrix system, you can actually start to hybridize these different vocabularies that was used in training. So which is actually quite hard as a human to kind of just imagine what could actually look like if you start to think about these vocabulary with this vocabulary and this vocabulary. And so this matrix can actually expand further to almost infinite combinations of this formal characteristics of combinations. Here's some zoom-ins of the examples that was generated with the vocabulary. And then you can also inverse this process of, by just putting the sketch into it, machines can actually read what could be the formal characteristics of this image. So at that test, it showed kind of a very good result of actually machines can regenerate that the vocabulary that was used. If they were not able to successfully predict what the vocabulary used, that they still predicted kind of a similar verb that was actually described in the image. So this idea of kind of fine-tuning is very important as an architect with all this large language model, because it's really hard to generate something that you really want to do. That's why there's like a prompt engineering now. So this is kind of a power of how, as an architect, we can fine-tune to domain-specific data set these large language model, which is also impossible to just do it with only 1,000 images. And now we can capable of using the large language model to combine this kind of 2 different domains. And the idea is that we can actually generate now with the models that are out there, that we can actually generate the text with the 3D. So hoping that we can actually move into this step from using the text into 3D. And another thing that was kind of using this stable diffusion, the idea of the textual inversion is also interesting, because this is also, as an architect, it's hard to reproduce certain things that you want to and by just typing it. You have to type in like endless trials to kind of get what you want. But with this textual inversion, you can actually just kind of choose like 3 to 5 images and basically embedding this knowledge into the large language model. And so here you can see kind of different steps of, first one is the data set, and the second one is actually just reproducing that data set with the embeddings, and also how can that be in the kind of architectural context. And here you can see kind of examples of students, they did the idea of conceptualizing this data set with the different elements, architectural elements, or aesthetics, or kind of tectonics, so that they can test from the top to bottom is actually increasing the complexity of the context to generate. So the idea of in this research is also kind of how you can actually hybridize existing structure. This was a Kyoto matcha, traditional house of matcha, and how you can actually use this technique to use like these embeddings and also in painting to actually kind of create a design where you can actually hybridize, or like adaptive reuse of a glimpse of kind of going into that direction of adaptive reuse in terms of images and language. The final chapter is actually on the anatomy of form, and this dimension actually is it's basically looking at the use of parametric computational tools in combination with the graph learning to model and visualize kind of complex flows within the built environment as a novel way of looking at architectural form and design. Traditionally, the discourse of flow in architecture is much tied to the relationship between diagrams and architecture. Flow and bubble diagrams manifest biological analogy with circulatory systems and organs and how they have become the basis of the rational approach in architectural design. The rationalization of architecture into flow plan diagrams allow for clear objective to taken into the design process and become the image of modern organism. The computational geometry allows for the extension of the concept of flows into architectural language, manifested in the continuous expression of malleable surfaces, enabling a new way of organizing flows through architecture. The flow becomes a formal expression that can be materialized and experienced. So these developments contrast the two distinct architectural flows. First is the flows as a rational and scientific means, and second as a formal expression. So kind of Mobius House by UN Studio kind of represents this kind of the dual natures of flows and incorporate them into a design process. So in this process, we created a tool inspired by the Sankey diagram, which is originally developed to quantify the efficiency of steam engines. And we basically create a parametric Sankey where we can actually, using the system of nodes as inputs and outputs. And the core principle is to kind of conserve mass and energy where the inputs and equals output in the system. And then also the width of the band actually represents the amount of flow that goes in and out of the system. And by positioning and the direction of the volumes and layering and plays important roles in this representing of understanding of flows in the city. And this tool actually allows these parameters to be configured, enabling a degree of interactivity to explore different spatial conditions of flows. It's almost like a mapping where this approach offers a new perspective on urbanism, reimagining the city through the lens of material flows. And this context, this is a zoom in of it. And then this was actually tested in the studio, circular studio in Seoul, on this building in the neighborhood. This building is called Seonsanga, which is a 1 kilometer long brutalist structure that was built in 1960s. And this became kind of our catalyst to deploy this tool for design process. And here you can see the current situation of this building. And also what is interesting about, this is the first kind of a multi-complex building in Seoul where there's like a residential on the top and the commercial on the bottom and different offices in between and shops in the floor, on the ground floor. And then what is interesting is like around this building, this is where all the manufacturing in the city started to occur. So you can see different clusters of different specific industries that gets built up around this neighborhood, like from building material stores, linings, tool shops, and also like publication, for publishing and also steel processing, woodworking. So a lot of things that happen, the manufacturing things happen in this area of Seoul. And like there's also like the first open source satellite was built here in this area. And also you can see kind of how it works. Like in order to build something, you kind of have to look at different venues to actually build something together. And this is why this site became interesting for us. And this like different locations became the nodes for the experiments. And here the idea was to turn kind of the city waste into a circular product. And in this process, you can see all these different processes that happens, but also like this process that students embed in as a circular process. So basically they mapped out this kind of a process of turning waste into a product by this diagram of parametric Sankey. And this you can already see kind of different variations of different projects of how they kind of visually also look like. And this tool actually allows for deploying into the city context and also actually kind of transforming the dimensions into a 3D as well. So this tool can actually, this tool was also to look in folding the tool from 2D to 3D and then deploying into this building of how these flows can actually, how do they adapt in the building. So here's some case, samples of a project that was students' project where they embedded this kind of acupunctural gesture into this building to kind of revive the whole area and by adding the circular process into it. And here you can see kind of a glimpse of the tools that was used in this is kind of obsolete typologies in the building. Here you can see kind of the section throughout the building, but actually this tool expanded further into the machine learning process in this studio where we looked at the artisanal architecture in Kyoto to kind of revitalize the city from kind of a historical city into a circular one. So the process was the same, how we can actually make this process more circular. So students had this kind of different processes that they embedded in to make this process more circular. And the only difference between the previous one and this one is actually the component of kind of using this kind of diagram into creating a 3D models, human interpreted 3D models of different flows. So this process, this actually basically represents the process of this kind of one kind of artisanal work, and then by using this Sankey diagram, we can actually volumetize this flows from these 2D flows. So here you can see kind of the 16 different of 3D flows that was actually transformed into a 3D color printed model to represent different flows, and then how they blend in by combining different processes. And the thickness actually represents different weights of the flows. And the human interpreted diagram became a way to actually use it into machine learning process to optimize the space. So and this time it was only 16 models. So the idea was like, how can we use these 16 models to actually create something that is efficient in terms of how we can actually arrange the space for these kind of artisanship. And then so that's why we also looking into kind of a formal understanding of these diagrams, and then kind of topological understanding of this diagram of the graph. And here you can see, so with the 16, it's impossible to do some kind of experiment. So basically what we did is we dissected the whole models into around the nodes of processes, and then combined them all together to see a holistic view of processes. And we use this as kind of a formal understanding of nodes, and then also, of course, we use the point cloud, and then use the pre-existing models to deploy where these kind of point clouds actually are in the space. So we can also cluster these the forms of nodes into different clusters, and so you can kind of identify what kind of different types of formal nodes are there. And also looking at the graph, we can see how the network is, how the processes are connected to each other. So using these two systems, we created this kind of graphs where we can understand how the formal nodes are connected with the processes. And in this process, this is an example of one kind of artisanal project, one project that represents this formal and topological understanding. And we use the obsolete typology again as kind of a way to, like the previous project with the Seon Sangha, we used the matcha as kind of our catalyst. And using also basically human in the loop optimize the system to use these two things that we learn from formal understanding and then topological understanding to create different types of options of how we can actually arrange the space in the system. In the building. So here you can see kind of a one optimized of a space configuration, which is actually still yet primitive, because there you can start to understand, you can create a zones where there's a circulation system or structures, so you can go further in terms of optimizing space. This was just basically on 3 floors, and also just a different, arrangement of spaces. So here you can see kind of the example of the student project that actually using this matcha and how they can insert their new project. And this is the last slide, the zoom in of the models, where like some say the form is a concept that has outlived its usefulness and has become frozen and no longer in active development. But I consider form as kind of a specialized token, the models that embodies a wide range of data and information from cultural norms, semantic meanings, human preferences, climate conditions, energy efficiency, and material properties that could help identify innate bonds between tangible form and intangible narratives of data that it incorporates. Thank you. Yes.
Because there are so many very interesting things that I think will link to the previous talk and discussion that we had. And I will allow myself to try to read below the lines into your first two projects that you present, where for me read about against generalization, and therefore the title of the Swissness, right? So you're trying to really capture what is the essence of one particular thing, not only on the archive that you're creating for the competitions, but as well on the object. And my question is precisely on that experiment that you did when defining the forms and then labeling them based on 4 dimensions. I wanted to know if you thought about this as an inverse parametric generative algorithm, where you are trying to learn or trying to revert what was the generation for that model itself. When you have the output, but then you're trying to identify how this output was produced through series of parameters. Will you? What will you react if I say that this could be something?
So like basically parametric process versus machine learning process.
Well, I think this is just the inverse. I'm challenging you to think of this as an inverse parametric generative algorithm.
Yeah, so what I think is that parametric system was basically you, as an architect, we know what we want. We have the parameters. This is kind of thing that we can actually like imagine. And with the certain parameters, you can actually, that's basically the designing process in the past. And now I feel like by machine learning, we actually have to learn what the machines actually think. So a lot of times in the cases in our teaching studio, we basically would try to figure out what machine sees it and we understand, and then we actually parameterize what machine thinks. So if there's some kind of design element that the image is actually represented, we try to parameterize that again. So it's never like a kind of like a, this is parametric era, this is a machine learning era. We always use all the tools together by using just few images. We still use just few images to actually have a design. So at the end, it's adding kind of another layer of thinking, giving a chance for machines to kind of interpretate what the data actually holds, that what we don't see, because they can pick up on the things that we don't see, definitely. And as a human, we also have to critically understand what they are representing. So I think in that question, I think it's still an inverse parametric, but I think the thing is, before we defined as architect what the parameter is, but now we can also learn from what the machine thinks as a parameter.
Yeah, this is very interesting if you think about knowledge, because the idea of you bringing meaning to an existing output relates that you are training based on an existing knowledge that you have. So it's embedding sense from your perspective.
Yeah.
And that's what I said about personalization, or the essence of this one thing, instead of doing the generalization of everybody should label these based on these 4 dimensions.
Yes,
and I think this is really interesting to emphasize the idea of personalized models, and how do you embed knowledge, like the human knowledge into
Yeah, I think that step is quite important, rather than letting just giving everything the machines and then trying to figure out. I think the creation is like one of the important things that we have to do with this machine learning processes. And that's already the design, as you said, yeah.
Any other? Yes.
Very interesting presentation, Frederick. I'm from University of Florida. So you created, like say, using AI, thousands of options in 1,000 forms, right? So that's the advantage of AI. But the next question is, how do we train the AI to optimize those forms or choose a certain form that meets certain criteria? And then ask the AI to help us to understand what is the impact, or what is the effect, or what is the consequences of different forms. So that will help the humans make decisions or help the AI make better decisions. So this is like a three steps. First is you create forms, 1,000 forms. Second, you choose the form that meets certain criteria. And third one is optimize that form to the extreme. So any thoughts on that process, or are you working on that? Specifically, you have working on in the Korea case, like using different street form or road form, and what is the consequences of that in terms of traffic flows?
Yeah, so there's a project that we are actually in our lab working on. We call it Blue City Project. It's basically looking at the flows of the city and understanding the city in terms of flow. And one of the aspects is actually what happens if you insert this kind of object or architecture or certain kind of nodes into the system, what could actually happen. So I think the last part that you mentioned is one of the most important part, where what the future is going to look like once you actually implement those forms in it, right? So I think that's something that just came to my mind once you said it, because usually it stops after you design, right? Like it's after form you design, but actually predicting with the machine learning process of how that could impact to the society or the built environment, actually that's quite another aspects of machine learning that is quite important, I think, that could be implemented. I mean, no, it should be implemented, yeah.
Yeah, thanks a lot, Fred, for the presentation. I'm curious about this last project that you showed, how to think about the word form itself. You know, because what I see happening is a kind of concretization of the world of flows, right? So it's a concretization of a topology, a concretization of an infrastructural movement. I'm just wondering, where would the will of the architect be present? You know, if architecture is defined through the flows of data going through it. You know, so it's, I mean, we have this building here, which is a result of this infrastructural optimization. And I'm just curious, how do you see that, and where do you see the role of the architect if it is a purely data-driven process, something like that?
That's a very good question. By these diagrams that we generated of these models, it was quite interesting because students start to understand, to talk about their processes or the flows through these diagrams, right? So they can actually, makes something that is intangible very tangible. So you start to understand what could be a potential in how these different flows actually affect each other, which we cannot see in the reality. So I think as an architect, it's very important to see this kind of processes, also with the existing context of where the structure goes, where the air flows. So I think we've been using kind of aerodynamic way of thinking in terms of designing spaces or buildings, right? So I think, but now we can actually combine multiple different flows in the building by not just looking at one thing together. Visualizing it, but in terms of calculation, that's another part where we cannot do that. But I think that's this kind of visualizing this kind of model of what you don't see into something physical is something that we can actually communicate between different parties. Just as a representational tool, but also hopefully that actually it impacts the design of, somehow it influences the design. That's the ultimate goal with this project, which a lot of times it was hard for students to actually interpret these diagrammatic flows into an architecture. That step I think was very hard. Yeah, it's basically different than just looking at the programs of the building and putting things are, but now looking at the energy and how people flow, we can kind of specialize the space in a different ways of looking through these diagrams and to the architectural design itself.
So I was fascinated by the approach to linguistic description that you took in a few of the projects, and I sort of share that interest. I think in particular there's what was, I think, clearest as a signal was the linguistic description of a specific static form. And I think it's really useful for creating sort of like comparative maps. It's useful for sort of beginning to sort of understand that territory a little bit more qualitatively. One of the things that is sort of like a corollary to that would be if we have a building or a proposal of one type and we actually want to transform it into something of a different type. I'm curious any thoughts you might have about the description of that transformation, or how we might think of data models, or how we might think of a sort of like data set that allows us to think about those kinds of transformations. Does that make sense?
Like you mean building transformation in terms of adaptive reuse, or?
Yeah, so what you've kind of created is something like an autocritic in the sense that you're able to generate some very particular descriptions qualitatively of these projects. I think the next step for an autocritic is to say, well, this project has these kinds of qualities, but what we really want are these different qualities, and in order to get from here to there, we have to go through these series of steps, or this kind of process. Yeah. And you've touched on process a little bit. I mean, one of your projects actually indicates certain kinds of verbs associated with the project, but I was curious about this almost like meta level model which we might be able to create, which allows the description of those kinds of transformations or operations between models. Yeah,
so I think this is very good. I think that's also the reason why I kind of got so interested in this form, because it's like the representation that actually is an abstract representation that could hold a lot of meaning to it. But if we start to looking at beam, like machine learning a beam, that's going to be a very complex exploration where you cannot grasp that kind of idea very quickly. So the abstraction in terms of representation was very important by choosing the form. So that Swiss architectural competition, the idea is that basically by just inputting the form in it, you will get the qualities, the description of the quality of that project. But then, like, what happens if you start to add different qualities, and then would it have different forms? So I think this is very interesting because, and it's also the step towards that I would like to go into by using this language in a more meaningful way than just generating images. I mean, how we can actually generate forms that actually understands the quality of the project. And also there's a lot of data sets out there with the ArcDaily. Every single post with the project can be potentially a data set for understanding the quality of the project. But I feel like there needs to be some kind of a thing that can hold those together to compare different projects together, not just through images, but something that is, in this case, is basically form for myself. Yeah.
Do you want to react to that?
We just want to follow. Maybe this is more an observation than a question, but I think, one really interesting way, or a sort of like step between qualification and operational or transformational description might be to think about actually the activation maps that are associated with a particular quality, right? So you have an image, for example, or you have a model. You have a quality associated with that, but then there are certain features within the model which are related to that quality. Not everything is relevant to that quality, right? And I wonder if there's some way to sort of relate those specific qualities to the specific maps in a way that you can say, okay, well, if you want to remove this quality, then you need to focus on these particular areas of the project, or if you want to add this quality, these are the areas where you can that you need to concentrate on, almost like localizing the qualities within the model itself. It could be an interesting. It's not at the operational level, but it does give you a hint of where to attend to.
Yeah. That's very nice comment. Yeah.
So in a way, my question is not intended as a follow-up, but kind of connect to this question of language as well, and also questions of translation that I was mentioning before, because what I see through especially the first projects that you were showing us about Swissness and about the Swiss competition system and so on, there's this tension I see in a lot of our work in general between trying to grasp a certain genericness that is meaningful, that is that can be turned into operationality, it can be activated, can be used, can be queried, can be somehow, can help us understand. And on the other hand, the realization that the specificities are key to that understanding. And that is, of course, and there's awareness of this. And these kind of models and these kind of technologies, kind of in a broad sense, start to allow us that fine grain combined with distant viewing or distant reading, and this is key. However, whatever syntax we might infer using these systems also depend. This is not the key to meaning in a way. They depend on the semantics, and that's when the language comes in as one of the angles of reading this type of data, and how we can try to translate or try to turn one thing into another in a still relevant and coherent way. And I want to point here to the question of foundation models, just because you're mentioning now in your answers to Andrew, okay, there's a lot of data sets out there, we should maybe use them, we should maybe train or fine-tune models into this. And however, we're still in the hands of very, very few, very powerful foundation models that are still key to those translation operations. Clip is one of them, is the elephant in the room and these kind of things. And how do you see this? I'd like to hear you on that. Is it because those things are still trained on gigantic common crawl data sets of dubious status, whatever? What do we do with that? Do we embrace this? Do we embrace this kind of internet trash pop culture genericness that is still key to these operations of translations that we still depend on? Or do we really need to, no. Let's go for like higher quality data. Let's do somehow collegiated effort to try to curate the actual data that will allow us to perform those operations in a meaningful way.
And we also, the foundation model, we also had this discussion among our team, but foundation models are amazing. It's revolutionary. Like, bringing all these knowledge into one model, it's so ideal to me. It feels like, but then fine-tuning doesn't work without the foundation model. So you cannot just create a domain-specific knowledge with just that, because it doesn't have rest of the knowledge in it. So I feel like back in the day when we were using GAN, we only focused on this small data set, and that's it, right? But now with the fine-tuning, we can actually, fine-tuning the foundation model, it's another level of using different types of data with this foundation model. So it's not just about image, now it's multi-model, right? So it's like sound and language, but what is important is, I think, is this kind of data interoperability, how the data transforms different models. But again, back to the thing, I think the fine-tuning is, as an architect, I feel like it's, as a designer or someone who wants kind of a specific design intention, I think it's very important. But we cannot underestimate the power of foundation model of mixing the knowledges, I think. So I think that's something we have to kind of operate in between, I feel like, as an architect. Like my language, my foundation model, my fine-tuned model is going to be different than yours fine-tuned model, depending on what kind of architectural agenda that you have. So, but I think using these foundation models is like important because it has a power to it. Without this power, it doesn't work. Yeah.
Hi.
Hi.
Thank you for that presentation. Also
Thank
very
you.
interesting. One thing that we might learn again when they upgrade the models, the words and the meanings that the model interprets is sometimes completely different. So how do you think it's happening too fast and they're changing too fast? How can you keep up with this, and how can you, like, every time you have a new model, you have to relearn what to say, and the outputs are going to be different.
Yeah, I know. It's like from ChatGPT 4 to ChatGPT 4.0, they have completely different. Not completely different. They have different answers, and I don't know why that happens, but I think at the end, it's still us that we have to define if it's good or not. So I don't see that we can rely everything completely on the knowledge that they produce. We still have to guide the machines to go in a direction that we want it to be. So a lot of times, I don't know if you experience this, like you try to train the ChatGPT 3 to the way you want to think. Have you guys done this sometimes? I don't know if you like, I direct ChatGPT to say, think like this, okay? Like you have to think like this, and then sometimes it works. So I feel like we still have to guide the machines in a way that.
Very more like for the image generation.
Image generation.
When you have like you do the prompt and we show them the words and sometimes they just upgrade it and it's completely different. The words are gonna come up with different outputs.
Yeah, that's why I like fine tuning or embedding, because then it's consistent, meaning like.
Even if it upgrades, you think that
Yeah. I mean, because you have to embed it with the data set that you give them. So, I mean, also different models act differently. So then there's hundreds of different models, so it's not going to be like same. But at the end, it's going to be, and then what you get as a kind of a, if you inverse that process of giving image and then giving the text doesn't completely make sense at all too. So that's why in order to keep the consistency in terms of image generation, you have to know your language. And also I don't know, like from the process that we were teaching the studio, like embedding process was very important to kind of control the concept that you want to generate the images. At least this past experience.
Thank you very much for your presentation. I am a little bit curious about maybe the technical part, which was the logic behind transforming the vectorized models into point clouds that you showed in the first and fourth project?
The first project was mainly about trying to find the right, like what could be available for, I mean, we tested different models, but it was just a decision on kind of using the optimal models. I mean, there was not like a specific reason why we use a point cloud. If there was any other mesh system or I mean, there was also voxel, right? There's a voxel, and back then, and what stuck in my mind was this kind of a architectural way of representing the data. And then point cloud was basically, it's just points, right? It's the simplest data form, but you can actually arrange the points in a way that you can get something that you might not get out of by just using the typical uniform way of representing the data. So that was just pure speculation. It's going to make a difference. And then by looking at the Tissany, it did make a difference by learning like how the forms were finite, like forms were close to each other. For the last project, there was only 300-400 models of point clouds, right? So it was, I mean, even after dissected. So there was a limitation on using those points to kind of learn the optimal results from machine learning process. So we used the pre-existing model to just put where these points go. So sometimes that's why another case of using kind of a pre-trained model as for architects to kind of using the knowledge to kind of just embed the things that you want to embed to see. That was the second answer for the second project.
Can I ask maybe a simple question? I think you mentioned earlier with the flow to form portion that, you know, with these sort of models of energy that the students sort of struggle to interpret or convert that into architectural proposals. And maybe if you can kind of elaborate, or I'm curious to see what kind of things the students ran into, because it seems to me the model is a sort of, you know, it's a design tool, right?
Yeah.
Ultimately.
Yeah.
And because of the flow to form, that the flow is almost intrinsically a gradient, right?
Yeah.
But then oftentimes we're trying to decide where thresholds are or how to turn the corner, right?
Right.
So that's what I'm curious about. What sort of situations did you encounter?
So I think the step that was missing is actually transforming. Another step that was missing in between the final design and this diagrammatic model was actually transforming this diagram model into a form of the building. That was the part that was missing. and we didn't have time to go through that process. So a lot of time the models was lost in the final stage. But I think that because the tools actually allows to shift the points, shift the nodes, so that nodes could actually be kind of shifted in a way that it could be arranged in the spatial. That's why the machine learning part actually came after the studio. So from that, we can actually kind of shift the nodes in a way that we want, that optimal in the space. So that process was actually missed in the design studio, which was kind of rethought and then reinforced by this machine learning process. And also like looking at different processes, not just as one single artisanship, by looking at 16 different artisanship, you can see actually some process actually do share same processes. Yeah. So you couldn't actually go across just the whole thing. That's why the machine learning actually looked at the whole thing together. So that step was very important that we kind of left it out.
I think
we're
almost ready to go,
yes.
but there is a slightly change of plans. We're going to go for lunch, and then we're coming back for the last lecture for this panel. Thank you.
Thank you.
If I just have one last statement.
Yes.
Large language English models. That relates a lot with the idea of mapping back what English means to any other culture. I think there is the need to try to describe what exactly that translation means in the way that we speak.
Yeah,
right?
agree.
Yeah. Well, thank you so much.
Thank you.
Welcome everyone to the afternoon session. We're gonna have the last presentation of our first panel, and I'm really excited to introduce two of my friends, colleagues, and researchers, Adil Bukhari and Agostino Nicol. Adil is a PhD candidate at the Chair of Digital Architectonics under Professor Dr. Ludger Hofstadt at ETH Zurich and conducts the architecture design studio of the chair, Studio Meteora. He has held the position of guest professor at the Peter Behrens School of Arts in Dusseldorf and has worked as a visual studies at studio tutor in the Saar Institute of Architecture Städelschule architecture class and National College of the Arts. He has also been a practicing architect at Nahmi Bilgrami Collaborative in Karachi. I will apologize, I will not pronounce this correctly. Svit Hecker Architect in Berlin and Atelier Manfredini in Los Angeles. Agostino Nicol. Agostino is a doctoral fellow at the Digital Architectonics Research Group at ETH Zurich, studying under as well Professor Dr. Ludger Hofstadt and Professor Dr. Bea Buhlmann. Before joining ETH Zurich, he worked at Arab Studio in London, an interdisciplinary design innovation team, and taught architectural design at the Oxford School of Architecture and landscape design and video game urbanism at the Bartlett School of Architecture. Agostino graduated with a master's degree with distinction at the Bartlett School of Architecture at PG Unit 11 under Mouth Allen. His work was awarded the Sir Bannister Fletcher Medal, the Bartlett School of Architecture Medal, and the St. Gobain Innovation Prize. Thank you and welcome. I will not this, leave this.
To get into this presenter view. New slideshow and go presenter view. And then this needs to go on the other screen.
But it's can you help us out?
Here.
I just need to extend it instead of mirroring it.
This is yours. I'm here. This is mine.
Because right now it says mirrored. It should be in the display settings, right?
And it's also
you want the... Okay.
what we know. Then I know what we need. That's more like it. Let's go try.
Or if you just do this. Oh. All right. Okay. Can we start? Yeah? Okay.
Right. So thank you, Carlo, so much for your generous introduction. We are both architects, at least we think so. We are in love with computers, with the internet, and the fertility and abundance that they afford us. Today, design disciplines, as much as the role of the designer and architect, are being challenged by learning machines that can simulate and modulate all sorts of existing mechanics and media. They were brought to us by both deep unsupervised learning and natural language processing. From Wittgenstein, we can learn how to think of language analogous to how an instrument or a game is invented. We are involved in many nested language games, even when we are speaking right now. Together, they form this complex manifold we simply call language. Large language models learned about many of these games through all the worlds that the World Wide Web was able to catch in 2 decades of its existence. Now we have access to them via computers and code, and they allow us to play with these large consolidations of language, not at the speed of our tongues or of our vocal cords, but the speed of registers, logic gates, signal transmission through glass fiber, in short, in light speed. In some way, the sparks of AGI or artificial general intelligence are in the air, as LLMs consolidate both specialist and general knowledge, conserving a snapshot of the world as we know it today. How can we incorporate both programming and natural languages, so to open up new plays on language? How can we collaborate and cohabit the design space with machines that we do not fully comprehend nor understand? How can we step out of limiting ontological distinctions between machine and human to enable something like future LLM-aided design practices? And what new games do they allow to play us? First, we do not want to collapse machine intelligence or human intellect into one or to build hierarchies between them, but established a kind of logistic framework where many of these distinctions and roles can be hosted, and then contracts between different intelligence can be continuously negotiated. Logistics, we took up that term quite willfully because it steps out of the logics of systemic analysis and production and help to deal with huge quantities of data. And what we want to do is to emphasize that we are interested in these contracts with machines beyond the cybernetic rhetorics of control and power, but those that we find in relationships of love, hate, humor, joy, and all the rest. Relationships that go beyond the glitch, beyond the aberration, beyond the hallucination. Large language models, or LLMs, such as OpenAI's GPT 3.5 or 4, which then got popularized as JetGPT, showcase outstanding capabilities across numerous language-oriented tasks, such as understanding instructions and generating responses in natural language. They use transformer architectures, which many of you might know, use very efficient stacks of neural networks. Making use of self-attention, these models then can capture long-range dependencies and then continue sequential data based on input sequences. Being trained on vast quantities of textual data, as well as on interactions with human users and reviewers, allow LLMs to effectively follow prompts and also to display somehow surprising reasoning capabilities. This intelligence, which we literally want to understand as a kind of a reading between the lines, makes them surprisingly great foundation models for all sorts of applications. When we now combine these neural networks with image generation nets, then LLMs excel in these generation tasks that many of you have already seen over the last year proliferating all over the internet. Noteworthy examples include DALL-E, Stable Diffusion, Midjourney, and all of them have already found applications in architectural design practice. But LLMs are also able to undertake a wide range of tasks online. I mean, being able to write text, describe images, generate images. They can do a lot already in our connected world. From teaching online classes on Khan Academy, from selecting appropriate models on Hugging Face, or performing complex web-based tasks autonomously as demonstrated by AutoGPT. And this is what sparked our interest in the beginning of last year.
Yeah, so today we would like to talk about 3 experiments that we have conducted in the past year. All of them started as side quests to our personal PhDs, but now have become integral to them as they try to find new ways of engaging with LLMs, a technology that was adopted faster than any other in recent times. So we have Automata at Court, where we let LLMs ideate a constellation of events for the Palace of Versailles, taking the mythology and rituals of each location and the canonical palace into account. LLMs in the city, where you see in the middle, is an attempt at unfolding multiple scales on an urban level and tapping into the repository of the city of Barcelona and bringing it into conversation with LLMs. And on the right here, we have 1001 in 1, the rewriting, restaging, and recontextualization of 1001 nights through LLMs, together with Miro Roman, who is not here. Noted. So all of these experiments work with LLMs in a logistic manner to tap into the quantitative, productive power of these models and role-playing mechanics to snap out of the genericity of their production. Each one of them steps into different realms of architectural history and theory as well, albeit in a naive, topical, and above all, humorous level, to get into contact with them without locking them down. Automata at Court, which is the first project, is formative of the next experiments that will follow, as well as through it we build an attitude to these algorithms, biases, quantities, qualities, characters, and AI at large. And it will be published in as a book chapter in Synthetic Realities, edited by Manuel Kretzer, coming out any moment. This experiment came about from first an observation that in architectural renderings, LLMs have been rapidly adopted in the shape of Midjourney, Stable Diffusion, DALI, and the list goes on. But their practical and theoretical integration into architectural design processes still remains untapped, unexplored. How can we go beyond just the visual? And secondly, one other reason why we started this whole thing is just Agostino and I thinking about how to establish an architectural practice together with LLMs, employing them as experts or even as interns, you know. And of course, working together with them in this new scale of automation rekindles anxieties related to faceless machines that we do not fully comprehend. And this very idea of machinic automation and our relationship to it has been historically troubled, to say the least. Already from the invention of the robot as slave, as in Capek's RUR in the 1920s, to the eschatological prophecies of a technological singularity that we hear today. Paradoxically, writes a philosopher of technics, Gilbert Simondon, already in 1958, we tend to ascribe to machines the role of a sacred object, giving rise to an intemperate technicism, but haunted by seeing a permanent danger of aggression and insurrection. We also banish them to eternal servitude, placing machines under the service of man, in the service of man. However, he argues this dualism is not an appropriate way to think of machines. This might be even more true today. Donna Haraway writes, while pre-cybernetic machines could be haunted, but were strictly speaking not self-moving, self-designing, autonomous, with today's machines, we are not so sure. Our machines are disturbingly lively, and we ourselves frighteningly inert. To escape the paralysis of facing automation, we think we need an abstraction to communicate with these new machines, taking into account their whims and unique characteristics. Here, the ancient notion of the automaton might provide some insight. Automata as self-thinking or acting beings have existed in human imagination across various cultures for millennia. They feature prominently in mythological narratives, including Homer's account of animate statues from the Hephaestus' workshop. Did I pronounce all the S's? As well as in mechanical thought models and mathematical treatises. Their significance spans historical periods, from classical antiquity to the Islamic Golden Age to the Renaissance, from Baroque courts to the academies of early Enlightenment. Automata have characteristically appeared within multiple cultures of the world, signifying their cosmology and symbolizing contracts with the state-of-the-art machines of their time, giving a figuration to functional roles such as mechanical timekeepers. They render characteristic behaviors, placing their respective functionalities in a larger philosophical, cultural, and historical setting. One of the most famous automata, the Strasbourg clock that you see here, is much more than a chronometer. Instead, it theatrically stages the cosmic order at work and the mechanical philosophy through the dramaturgy of the technological spectacle. By addressing abstract questions throughout history, from Al-Jazari's elephant clock to John Conway's game of life, automata do much more than just link technological innovations to the past.
we propose to think of automata less as anthropomorphic personifications of automations, like robots, but more as embodied characterizations of constellations of technologies. Through automata, technological innovations can be brought to a table around which they can be discussed, and abstract philosophical questions posited. So a mechanically defecating duck asks what it means to be alive. A mechanically moving karakuri doll asks what it means to go as human. And a mechanically drawing doll asks about what it means to memorize. A figure, a role, and a location are introduced to the technologies, transcending their means of construction and purely pragmatic concerns. They become characters on stage where they can play in relation to others, us included. Beyond the totalizing notion of automation, automata work with paradoxes. They are both closed and open, animate and inanimate, stationary and mobile. In accepting their ambiguity, we find in them a kind of individual that invites us to position ourselves in relation to it. Can ancient automata help us in thinking about LLMs of today differently? Now, an LLM can definitely be seen as an individual, as running half a model will not work. If any of you tried it, it doesn't. And they are often addressed as a single specific character, for example, as chatbots, coding co-pilots, sidekicks on TikTok, and the list goes on. On the other side, LLMs, with their capability of so-called task-agnostic few-shot performance, can also individuate into multiple roles when they are fine-tuned on specific datasets. While Bloomberg GPT is a ChatGPT model trained on financial news and jargon and sentiment analysis, Marv, the sarcastic chatbot, mimics natural language mannerisms. This demonstrates how large language models afford multiple scales of individuation. An automaton itself, it can play several automata. Embedding such a role play into a larger play can be used to abstract from automation and of these current chatbot-based use paradigms that we are so used today. And instead, we can envision a new framework. We call such a framework a logistic framework because through it, these constellations of multiple models and levels of abstraction are put into motion as characters. And this idea is the idea that we put at the test with automata at code. We brush all engineering concerns aside and rather try a coded thought experiment with the following ingredients. First, a coding environment, in our case, Wolfram Mathematica. Then we use GPT, at that time still 3.5 Turbo, accessed over the Open API. And then we use Midjourney version 5 for image generation. We are deliberatively going for the most performative public models to abstract away and not get sucked into like engineering optimization rabbit holes. The next ingredients are 32 roles. These are 32 notable architects as well as 20 expert domains that were involved in inhabiting spaces. Then 32 places picked from the Palace of Versailles as speculative sites, and 32 motifs reflecting historic notions addressed by automata. And finally, we have one table serving as a receptacle for all the generated contributions stored as a digital spreadsheet.
Yeah. Whether for logic or multiplication, for recording movements in the Babylonian sky, managing the construction of pyramids, or planning novels, as in the case of James Joyce, the table serves as the format for the logistic framework of our experiment. It is both the dinner table and the multiplication table. It is the place where we come around to talk, to draft, to drink, to eat, to record, to document, to fight, and much more. We embrace the myriad instrumentality of the table. Its rows stand for 32 chosen locations in the Palace of Versailles, to which we allocated the name of a notable architect and a leading motif of historic automata. To individuate the LLM into characteristic automata, we focused on the few-shot prompting role-play method, or LARPing as you might call it, combining a specific role, for example, an architect, with a specific figure, for example, Corbusier. Only the figure of the architect, the motive to be addressed, and the location of their intervention at Versailles are predetermined. This automaton then suggests a theme and title for an event, as well as an appointee with whom they propose a program. The columns stand for multiple roles and trades needed to inhabit the spaces, spanning expert domains involved in architectural design. We have set 20 more specialized roles from which the architect and the appointee can choose and suggest figures appropriate towards the location, theme, title, and program of the event. Again, role played by the LLM, these characters suggest individual contributions in parallel to each other. covering different facets of the space, including visual, for example, an artist, sculptors, gustatory, chef, olfactory, perfumer, auditory, musician, and tactile interior designer or textile designer. All the cells are then algorithmically filled by the LLM, following a cascade of prompts. To further concretize the textual outputs, we chose Midjourney version 5, as Agostino mentioned, which comes with its own set of challenges. The full detailed descriptions were too extensive for Midjourney, so we kind of tried to invent a formula for that. The LLM enacts yet another role as a prompt engineer for image generation. GPT-4 was tasked with synthesizing 32 texts describing each room into concise and targeted prompts following a given formula. The latter focuses or forces the LLM to identify the most relevant information for a visual representation of space, while also assigning weights that can be interpreted by Midjourney's interface. Even with the LLM chose contributions that were not visual in nature, such as musical experts, they nonetheless contributed to the atmosphere, synesthetically rendering each space. The Palace of Versailles serves as the setting for our thought experiment. It is a place of absolute power and a kaleidoscope of knowledge, of exuberance and restraint. It is both troubling and intriguing. It is a world on its own and a model of the world. Since it came into being, the Palace of Versailles sparked the architectural imagination from the social utopias of Charles Fourier's phalansteres. I always have trouble pronouncing this. To Corbusier's Unité or Lucio Costa's modernist urban planning for Brasilia, to the postmodern expressionism of Ricardo Bofill. Where once mechanical automata came to flourish in the theater of courtly life, now 32 characteristic indoor and outdoor spaces from its current layout are brought back to life by a new kind of automata. For them to inhabit the palace, we chose the highly abstract Wolfram language to code what we call tabular prompting cascades. At their core is a simple function, taking a text prompt as a string and a temperature hyperparameter controlling the model's determinacy as arguments, and passing them on to GPT 3.5 Turbo model via the OpenAI API. This function is then called upon in fixed prompting templates with placeholders for predetermined and generated values. Prompts start relatively simple and become gradually more complex as they incorporate previously given answers.
So these responses were then stored in this table represented as a data structure. All of this is not rocket science. The main technical challenge for coding the play lies in the different nature of the two computing paradigms that are involved. GPT uses natural language as input and responds in natural language, working probabilistically, so you never get the same answer. The Wolfram language administers prompts and responses and is very precise, symbolic, and following this like very simple rule-based structure. So through multiple rounds of iterative testing and tweaking of our prompting templates, we made the LLM output very concise responses as numbered lists without lengthy caveat or explanations. And then on the other hand, the code was written in such a way that it would handle error messages, empty answers, or responses that were not following the right format. And so we iterated through all these rows and columns of the table at different temperatures, and then we would save all of these as text files, and then the results are 32 events that were ideated through role-played characters and having undergone only what Lado McDowell calls minimal pruning. Complex programs, spatial qualities, and atmospheres emerge between the rows. The table begins to work as a screen, rendering each cell into a multitude of colors. The palace comes spectacularly to life. Claude Nicolas Ledoux welcomes the contestants of a weightlifting competition when he appoints Arnold Schwarzenegger in the billiard room at Versailles. Tom Cruise makes protein shakes, and DJ Khaled plays the final countdown. Julia Morgan addresses cosmical motifs in the Bosquets, hosting a guided meditation session between beds of wild bergamot and trees decorated with wildflower garlands, and Deepak Chopra gives a speech. Gian Lorenzo Bernini reenacts the eruption of Mount Vesuvius in the Salon of Diana, while smoky mezcal margaritas are served in ceramic replicas of Pompeii artifacts crafted by Damien Hirst. It seems that, as Ludger Hovestad notes, the machines know everything, but everything to them has no meaning. And this is the part that falls to us architects, to configure meaningless global elements meaningfully in a concrete location. Now that the Palace of Versailles is full of color, life, and God knows what else, we decided to push the resolution and scale of the project. The attitude to algorithms and technologies at large is again at play here, Also, this idea of tapping into these large databases and beginning of fine-tuning them with simple prompting. This is how we step over to the scale of the city. And this piece of work was presented at the IAC Responsive Cities Conference in Barcelona last November. And as you know, metaphors for the city continue to be invented. We know the city as a body, as a machine, as an organism, as handshakes, as eyes, famously even as eggs. Defined neither by any singular theory or model, cities remain inexhaustible objects of fascination beyond disciplines, generously hosting paradoxes of the local and the global, the generic and the specific, and the local and the migrant.
Models of speculation on the city are not merely replaced by newer models. Instead, they become part of the spectrum of possibilities and realities of the contemporary city. Much like cities themselves, models continue to reinvent themselves as they are cyclically applied, analyzed, simulated, and realized. Along with the history of computational approaches applied to urban modeling, today's LLMs are also being explored as convincing simulations of individual and communal behaviors. However, we choose to employ LLMs not as anthropomorphized robots, the reason for that we already explained, as simulations, or for infrastructural analytics, but instead we propose a versatile schema adaptable to specific city contexts. The superblocks located in and outside Barcelona's 10 districts might, should they ever become a reality, help surmount the infrastructural challenges of the 20th century city, brought as much as its blocks did in the 19th century. However, cities exceed their urban infrastructure. If all super AIAs, I think they're called, were to go ahead, then up to 500 former traffic intersections outside the old blocks would become internal courtyards of the new superblocks, each having to be intelligently reimagined to become characteristic and lively places for the 21st century city. This prospect serves as our setup. For each of the districts planning to implement superblocks, including the 2 districts that are outside of Barcelona's city council, we imagine an exemplary infrastructural intersection at a speculative superblock. Itself a city model, this block becomes a site for our experiment. At the heart of this venture is again a logistic table. This is our drawing board. Rows depict 12 distinct intersections, each themed on one of Barcelona's districts. Columns embody the diverse characters, roles, and expertise required to conceptualize these places holistically. Taken together, columns and rows take the role of prisms through which the intelligence of LLMs gets rendered, or we might say diffracted. This also created an opportunity to address the shortcomings in the schema that we know from the previous project we presented, where we let the LLMs choose the most appropriate figures to role play. We face the issue that LLMs would overly associate certain professions with the oeuvre of certain individuals, possibly due to limitations in the training data. For example, the LLM proposed Piet Oudolf, who I still don't know who that is, as a landscape designer for most of our rows. Secondly, all expert roles are aware of the program of the event. However, the prompt cascade collects their contributions in parallel, without the possibility for any horizontal coordination or synthesis, which would sometimes create contradictory suggestions. To address the first point, for Barcelona, we decided to take these figures, these prisms, from the city itself, literally picking them up from the streets. Barcelona's streets reference authors and artists, architects and inventors, but also local plants and global places, which we extract from the open data sets provided by the city of Barcelona. From up to 1,000 streets per district, we tasked GPT-4 to find a representative for each category. Highly local, specific, and improbable for the LLM to come up with it on its own. They become a kind of obstacle course for the LLM to run through. In channeling the global general knowledge of GPT-4 through local prisms, this logistic framework becomes an instrument on which the city can begin to talk.
The LLM now mechanically populates the table following this cascade of prompts. Formulating this cascade is an architectonic task in itself, striking a balance between adding enough alienation and yet remaining consistent and somewhat coherent. Each of the 12 chosen districts has at least one author among its street names. They and their characters form the starting point for our cascade. While the prompting cascade of Automata code was still very limited in its number of prompts building up on each other, and would not allow for any kind of coordination, as Adil mentioned earlier, here we implemented more prompts building up on each other and feeding back on each other, or also prompts that would synthesize previous responses. The prompting cascade starts by tasking the character to undertake 3 trials: walking through another city, talking to an inventor, and inspecting a plant. And these findings are now synthesized and given to the architect who, also present in the local street names, is now tasked to develop a design theme for the pedestrianized intersection and to jot it down in their notebook. Then the architect's design vision is passed on to a list of 8 key professions that are instrumental in delivering any urban scheme: tile makers and stonemasons, engineers and woodworkers. Again, all of these suggestions are recorded for benches, bins, facades with different finishes, planting and paving schemes, lighting and water features. In the final step, all these designs are given back to the role of the architect for a design review. Together with an artist, the duo develops an artistic vision for rendering. Then each individual contribution is algorithmically transformed into Midjourney prompts with a formula. The full prompting cascade can now be run at different temperatures. Midjourney can synthesize all these contributions, as we had it in Automata code, into these tangible impressions that make it a multimodal model that can generate really a lot of different flavors for each intersection. After reviewing all variations for all 12 proposals, we consolidated the most interesting options into urban mood boards for each superblock, accommodating different scales. Now, characteristic planting schemes complement intricate tiles, adorn facades, frame a new city square fitted with bespoke elements. Together, they form a possible urban imaginary for a city that had the opportunity of playing its own inventory, a probable constellation of improbable moments, a section of a model city arising from a language model. Around and on this table, bodies of knowledge converse with others. In Nubaris, Platero, the donkey from the corpus of Juan Ramon Jimenez, communicates with the entirety of quantum mechanics and the oeuvre of Antoni Mias, virtually establishing lateral connections. The logistic frameworks hosting these conversations, however, are very agnostic towards the intelligence that is at work behind them. Columns can be reviewed and curated by human professionals who can also complement, alienate, or delete single suggestions, or play certain roles exclusively. And this works on paper as much as on screens.
In this way, the hypothetical superblock becomes itself a model of how to generate and facilitate public discussions. Done in light speed, its outcomes allow the staging of public debates where possible, and probable perspectives can be opened up. One can, hopefully, imagine how a citywide conversation can begin on the back of this instrumentation. So we've traveled from Versailles to Barcelona, and now we step into yet another world, the world of 1001 in 1, which we developed together with Miro Roman, who is not present here, noted again. An exhibition, a book, a scenography, and a party, articulated out of 1001 Nights, or Arabian Nights as it's sometimes called, which in itself is a large language model of sorts. As per tradition, we also published a text on it in the last edition of Trans Magazine. 1001 in 1 taps into the tradition of framing stories, a literary device that consolidates disparate stories, packaging them, encapsulating them through the invention of characters that can then narrate them. The Decameron, Canterbury Tales, Hazar Afsane, even the Odyssey and the Mahabharata employed this compositional trick to bring together folklore. Stories hosting stories. This collected folklore can then be colored through the temperament of the characters telling and receiving the stories. It also introduces a temporality. Some stories are told over the course of a night, and some might take many days to tell. No edition of 1001 Nights contained 1001 stories. For the time, it was purely a large number, the navigation through an unfathomable quantity, like Google today. It also introduces locations, performing like a theater, where stories from any time can be told and retold on a new stage, like this one in late 2023. It all happened on one night with all the people we know, at least invited, and quite a few showing up. 8 large LED screens. A table faces a window, domesticating the industrial laundry space that was assigned to us. A physical dimension is introduced to the ephemeral stories. A new story unfolds. The schema here works sequentially and in parallel. Past responses partake in future prompts. The table knows the window knows the place, and the place knows the time. A daytime of choreographed computation projects an image rendered in natural language. Each row, each pixel harboring formulaic imaginaries for Midjourney to be written in RGB. We sit down with our characters and go through a final round of selection, attempting a harmonic whole between sets of differently tempered texts and fourfold of images. As we hit enter, the most powerful LLMs today soul search their latent space to resolve improbable tasks along our obstacle course, taking each of Scheherazad's nightly tales as a seed. Texts are rewritten, characters cast, places located, windows opened, tables set, objects chosen, songs selected, and flowers picked to enact a new scenography. A space of synchronicity sets the stage and is set on stage. Soon, a new time of the day will bring us to a different place. Every 30 seconds, the scene changes from sunrise to sunset. Every 9 minutes, a solar cycle ends, and all its recycled stories flash by in an instant. The flicker stops, a new track plays, a new day begins. We are again at sunrise.
This latent logistics runs through our own unique databases. So this includes our chair's very own corpora, notably Xenoteca and Paradiso. And these resources, they guide the interactions that we have with these kind of AGIs. Xenoteca paired with ChatGPT directs the text and narratives, infusing them with distinct flavors and styles. Paradiso, paired with Midjourney, influences the coloring and direction of images with its cinematic content. Both of these databases are private, valuable, adaptable, and also consciously biased. The commonsensical world of concept art and endless fan fiction shift when influenced by the works of hand-picked writers, directors, characters, and artists. A carefully crafted optics alters probabilistic predictions, guiding responses. All 1001 newly rewritten and staged nights then came together in a massive book, presenting itself as a new light edition of 1001 Nights. A new edition of an ancient tale brought to life once again. 1001 also conceived a table, which you can see there. The screens utilized at the exhibition in Zentralwäscherei now are hosted by another much smaller frame, the AnyTable. It's electric, it's alive, and you can just plug it in. It was designed and produced together with Guo Zifong and Studio Nuvolari and was showcased now at Drop City at this year's Milan Design Week. And we also made a new tablecloth for it just for today and tomorrow. Our experiments showed that where long single prompts to an LLM would result in fairly predictable and generic results, our table-based schemata and coded prompt cascades allow the LLM to develop way more detailed and specific responses that are infinitively replicable for different places, cities, books, you name it. Of course, human individuals and their work and all language games they ever played enable the present and future workings of LLMs. They contain, as Gilbert Simondon might put it, human reality, human gesture fixed and crystallized into working structures. However, our 3 experiments provoke us to reflect on how we might think of new forms of collaboration across intelligences, whether residing in humans or machines. While we, as architects, did not design a single artifact in all of this process, abstracting away from these common usage paradigms of ChatGPT or Midjourney allowed us to discretize LLMs into discrete roles. By inventing schemata, identifying decisions, we could then make selections from a whole sea of characteristic outputs. So in this sense, these logistic frameworks don't replace neither the event or city planner nor the architect, but rather augment their possibilities and capabilities by establishing conceptual communication with other characters, be they artificial, natural, or even human. Here, intelligent teams are at work. With Gilbert Simondon, we can say that on the one hand, the architect becomes the permanent coordinator and inventor of the machines that surround her. On the other, her presence to machines is a perpetuated invention. Tables host and record the theater of the project. A vivid conversation takes place between language as instrument and language as invention, between the role-playing architect and the architect as role-play. Thank you very much for your attention.
Well, thank you, Agostino. Is there any question from the audience?
Hi, thank you for your presentation. I've been experimenting a lot with ChatGPT. I also was a alpha tester of the DALI inside ChatGPT before they launched it. And one thing that I noticed with this new model, I don't know if you experiment or if you test this, whenever you want to ask ChatGPT for an image, you can do your prompt and prompt engineering, but then it's going to produce a new prompt. It's like an intermediate between you and DALI. He makes his own prompt, and it's like, I guess, the longest prompt of all other models. It's like a whole paragraph. Did you explore that, or had the opportunity to examine and compare it?
The new, this DALI we never played with, but what we were doing at that time was creating formulas that could churn out consistent results. So just because in this logistic table, for each particular place, we would get a huge chunk of text, and then this has to be output into this formula for Midjourney to understand it. Also, it's funny, these kind of moments where it incorporated music into, for example, Bjork is performing in a space. Suddenly, the training data from all of Bjork's concerts, they start getting incorporated into that. So, it's a funny little thing. And it really didn't truly understand it when we told it just choose visuals, visual ideas only. So it just doesn't know what is that and what isn't, something like that. I don't know, maybe you can expand on it.
Yeah, I mean, there is also something, I think Ludger mentioned it in his very concise opening talk, where he spoke about images and how these kind of LLMs and also the models that use this kind of like transformer architecture, they work incredibly well on text sequences, but they struggle on images. Now, many of you might have been like, oh, but we know all these beautiful images, or like not beautiful images, however one wants to look at them, of like Midjourney or GPT. How can it be that it struggles with images? But it struggles with images because all these images that are generated because they have a text embedded in them. If you would take that text component out, Midjourney would really struggle to develop anything. It would just simply not work. So like the kind of this latest generation of AI that works on LLMs, they are so incredibly powerful and so incredibly contextual because they work on language. You strip the language component out, and you struggle in developing images with them.
Now Sora, this is the technology.
Yeah.
They explain that it's using transformer technology. That's why it's so good. That's the OpenAI explanation on their side. So it's taking what they used in DALI in ChatGPT, like ChatGPT will produce this long prompt, like the large language model is making the prompts to the image generation, and they wrote that, not very technical, I didn't read the technical part of the paper, but they like explain that they're using transformer technology to do the film. So they didn't publish, we don't know how it works, and it's not even open to the public, but I found it interesting that they appointed that this was the changing moment that they could produce those kind of films.
And also, maybe one more thing just to add to that. When these models started coming out, now they're, every day you get a better one that does the same job faster or better, 5 times the speed, this and that. And we were suffering from a lot of FOMO, So it was, how to keep up. And then we were like, okay, let's just step back a little and let's see, is there a possibility for an abstraction that cannot somehow be buried by the performativity of the models that are coming out? So just to kind of explain the motivations for the thing. Yeah, sorry.
It's fascinating and super engaging work. And this, my second time seeing at least parts of it, and when I first saw it, I started thinking, okay, well, basically you're breaking down this sort of like monolith of the transformer into a kind of sociology, where you have a series of actors that are sort of interacting with each other to create these kind of like epiphenomenal effects. But actually, I think there's more. I think there's a more procedural logic than that, because actually you have obviously a very specific sort of sequence to the way that these that the results are being generated. You have a structured way in which prompts need to be answered or replied to. So at first I was thinking about this in parallel or in relation to sort of like human-centered design and sort of like the ethnographic research that's often a part of that. And while there are some parallels, there also is this, probably intentional, but sort of like lack of dissent, for example, from any of these actors, right? So it's not as if any of the actors are saying, well, I reject this, or they have debates with each other, or there's conflict. And actually, this is one thing that I'm a little bit curious about: is there a way to think about these kinds of, social ecologies in miniature and simulation as something which actually exposes some of those disagreements or conflicts, or because I think that obviously in the process of collaborative design, that process of refinement and debate is. It's really essential to get into the sort of like core of the project, to really sort of making it be the most essential version of itself. And so I guess I'm kind of curious if there might be some additional critical elements that actually come into this process to foreground a little bit this the social dynamic, which is sort of incipient, but maybe not fully realized yet. I mean, I say all that just really admiring the work and excited to see where it's going.
Yeah, maybe I can just begin with with trying to collect these thoughts. It's a funny thing thinking about alienation or dissent or arguments and conflicts within the setup, because by definition it is a probability machine. So even if you introduce an alienation, it will be the most probable one. Or something like that. So it's a weird kind of game. What we tried to do was add these alienations manually. Basically, in all of these projects where we took a red pen and kicked out a few of the contributors or a few of their contributions and incorporated some of our own. But yeah, I mean, it's that's the thing with these models. There is nothing that is improbable can come out.
Yeah, it's interesting. I'm curious whether you're interested in creating a world as product or a world as sort of behaviors, right? Because if you have that kind of conflict, it's a little bit more about behavior, whereas if you're creating a sort of world as a representation, it's a slightly different sort of project.
Absolutely.
Yeah, it's a really good comment. It's something to ponder over. I think something that where we would probably be able to tell if there was, let's say, conflict or something like if we can use these kind of terms on these kind of role-playing LLMs, then it's probably if very generic things would come out. If we would pull a leg out to create really interesting combinations of places and things and whatever, and you think this would make something which is completely wacky or interesting or out of what we would have ever imagined, and then something comes out which is completely predictable, then some things along that kind of cascade were just not taken into account, or they were just brushed over by a generic commonsensical kind of blur. And so then this is when we would then go back, or we would just keep generating until we would find, it's catching on to this really weird combination or this really interesting thought, and then extrapolating it into something beautiful.
I'm always curious to know the number of iteration cycles associated with each stage of any particular process, and I can imagine it is substantial still.
There was this very cool image, but we didn't have it in the presentation. Automata at Court, I think we were really sitting there over days going through spreadsheets. It became this insanely ridiculous exercise where we were discussing whether it would be better to have Tom Cruise to make the drinks, or I don't know, Celine Dion. And it was kind of completely insane. And then the second one, LLMs in the City, we just didn't curate anything. We just took the first things that came out, also because we were in a rush. And then the third thing, 1001 in 1, we developed like a proper kind of dashboard interface where we would kind of like can choose together, the three of us, the best kind of responses that like would go together. So like we had like a dashboard, and then like from all the 4 possibilities that like Midjourney would give out, we would take one for the flower, one for the window, one for the table. And so we would have this like, I don't know, this element or this moment of bringing these things into proportion, collecting the things that like would maybe create the most interesting space with the most tension, something like this.
Maybe I can add something to it. So for the first project, what we did was we ran the whole prompt cascade over 10 different temperatures to change the probability ratio. Let's call it that. And then from those, then we selected each one. So yeah, by temperature 1, ChatGPT goes completely drunk. 1.4. 1.4, it goes drunk and it starts uttering gibberish. And it was roughly the zone between 0.8 and 1.3 that we got the most interesting and not commonsensical responses for that. Maybe that's where the conflict game probably comes along as well, right? Perhaps, yeah.
I would like to shift the conversation on to creativity and how we project meaning on top of output. So we were talking about what is, in your talk you had automata and automatic as a pair of concepts that are addressing a similar subject, though from different points of view, complementary but not suppressive from one another. And then it comes to mind the relationship between robots and robota, or at least the idea of having this human and machinic approach to a concept. So here I'm saying this idea of creativity is maybe not part of the robota or the automata, but more on the human. So you are really, like if you think creativity can be a human thing, what will be the automata to that relationship? If you've thought about it, we're talking about knowledge and all of these things, like what will you think? Because you mentioned that you're doing something lively and it's a relationship between human and the LLMs. What will be the relationship between creativity here?
That I'm not too sure about, because I have a feeling if we were to say it, it's a matter of locking it down, you know? So maybe our proxy for creativity as characters, you know, characters that can behave in a way that is outside your control, and then immediately you are in a different space. So then the conversation can get creative. And I don't know, you know, if that thing is creative or I am creative or not, but the conversation, the intelligence of the conversation, let's say, this is what we try to build. But I'm not sure about creativity. I don't know. I don't know. Maybe you neither.
I think like in one of the papers we used the term inventiveness rather than creativity. We had like in the previous discussions of in the previous panels we spoke about this idea, like are things kind of rediscovered, invented in that sense from an inventory of existing things, or are they actually coming out of thin air and are actually new? I think when we're dealing with these LLMs, we are probably way more close to this like former kind of idea. All of that stuff is kind of latent in the LLM, and then it's about teasing it out. And this is what these prompting cascades and these logistics attempt to do, to create sieves or like instruments through which we can sieve out improbable, interesting things. And then if we see something as like specifically creative or innovative, then it's us projecting something in there, a value in there that we see. And then that might actually be, if anything, that creative moment.
Right.
I think we'll just complement this question about these relationship or relations that you were mentioning at the very beginning. I think from both, from the architecture of the algorithm, it's all about an understanding of relationships from input to output, and then as well when you're curating what needs to be into the LLM. So I think relationships is something, or relation or inverticality, this is something related to the conversation, right? So we are doing a different way of relating things. Still, relationships is being built. I don't know if it makes sense. All right.
Yes.
Other questions? I can ask another question. So, you talk about establishing communication, and I think this is something that if you think about if you think about language, so language is one way to encode in the mind and the thinking. When you think about communication that is not related with language, what do you think could that be? And I think this is what you're building. I mean, I'm reading on your work, and I think that's what you're doing. So it will be very nicely for you to explain what is this communication happening on all of your different projects that you show. It's not only about text. That's what I want to emphasize.
No, but this, I think, ties nicely back to your earlier question about creativity. So this, the presence, or not even the presence, let's say the imbuing of life into things which are not human. This is that moment of communication, I feel. You know, this is how we can talk to something without using it purely as a tool, without using it purely as something that follows our orders. You know, so it's I think that's the thing. So it's a weird kind of animism, if I were to call it that. You know, that we try to imbue these things with, thereby characterizing them, making them into characters, or casting figures out of these this generic data set. Yeah, that would be the birth of this kind of communication, I feel.
I think maybe also in terms of communication, something is to be added about this possibility of unlocking another level in which these interactions can take place. Like if we are, like all of these things that we have seen with these kind of LLMs, we did because like we created this like very simple, very crude level of abstraction on top of this like very intricate and very well-trained and massive LLM. And by establishing this kind of like second level of abstraction, suddenly things could arise that like would not be able to arise if this thing would just be left alone. So like by like opening up the second level, one could also say like, it's like an encoding or decoding bridge or something like this, an obstacle that like we are dealing with. That's where like something like communication can arise. And I think this actually ties back a bit to like what we started with, like Wittgenstein, the idea of the language game and language, right? Like it's a possibility of, the idea of thinking of a language game means that there's a possibility of stepping out of language. And this is where really the exciting and liberating idea comes in his philosophy, I think.
Yeah, to imagine a language is to imagine a form of life. So we can replace, I think, communication and language. If we are with language games, I think that is communication, right?
I think it's finding a shared balance. That's what communication really is. It's us all agreeing on something to have the same meaning. And I think that's also why you started with things we recognize in terms of Versailles or Corbusier, these sort of things that have a certain meaning to all of us, maybe slightly different way, but then through this sort of mixing process, they start to gain a life that is reinterpreted. I think the word sifting actually is good, but I think it's really just coming back to the notion of redefining a value system through this communication process. So I think what's the most interesting thing about the project is really trying to communicate, right, all this intricacies of the models, right, to us, right, in this way. So.
Thank you.
All right, is there any last question?
Just as a curiosity, did you try to make a custom ChatGPT? And how long do your conversations last? Because I tend that when the conversation is too long, it can kind of get lost on the responses.
I mean, we'd never worked like everything like we did was with like the API. So like we never had access to like the I don't know, the token ends and these kind of things that you would have if you would chat with GPT. Because like the whole point of this was trying to get out of the chatbot paradigm. So like not chatting to that paradigm, but kind of automating the chatting part and work at another level of abstraction by creating these schemata. So like we don't really know about how much context these models were able to keep.
It's just that through each one of these cascades, the previous results were compressed back and back again. So it always kind of took the most important parts of the previous conversation, and through that we can somewhat continue this thing without losing too much.
So I enjoyed the conversation very much, and I thought you did a great job adding some humor and history and context to the whole AI discussion. I just have a small question. Why Julia Morgan holds a yoga retreat? Did you choose it?
No.
Or that's the first thing that came out? Because is it about biases of women architects in general?
Right.
Which I thought was kind of interesting. She's not making the volcano explode. So how much biases still are present today?
Oh, absolutely. So this is this is absolutely there. But what I do remember from this particular prompt cascade is that Julia Morgan was associated with meditation as a concept. So this was the motive she was supposed to address. So we even biased it further in a kind of troublesome area. But you remember, huh?
Yeah. I mean, I think, but this is then also interesting because this is like, we can also think of this kind of like table or like the outcomes of the table as a kind of a screen, right? So like you see how this like model performs in all of these things. So it renders all of these things as they are. So if these biases are latently present, this kind of screen is a possibility of making them visible and addressing them as we are doing right now.
No, and I truly believe if you pick any single item from any of these frameworks, it kind of falls apart because it's not about the specific things per se, because some of them are quite terrible as well. We've had weird things that were coming out, but it's purely the schema that is within our kind of scope, and then that's why we did 1001 and put it together as a book so that it can never be disentangled into individual elements. So the whole thing needs to live as a constellation rather than an individual, something like that.
Yeah.
Just a little question talking about these biases, because obviously how the large language models react depending on how they were trained and with which information. Do you have maybe any case that you would like to share about a specific bias that you find, I don't know, I mean, for example, in culture or perspective, cosmovision, or I don't know, because I'm not that sure how they were trained, but I can suppose that most of the information was partially taken from, I mean, some parts of the world can bring more information to the web to train these models than other parts of the world. So I guess some bias will be directly or related with culture and other kind of geographically places, let's say.
I mean, sure. It's like, unless you have like a kind of something like, which also in itself is quite problematic, like a kind of a ground truth against you can check against what you want as an output, which is really tricky if you ask for like ridiculous questions like I don't know, like what would Claude Ledoux do in the room of Hercules? then it's very tricky to find out where exactly like a bias might lie. I think something that like we saw and we had to address was this fact that Pete Udolph came up all the time for landscape. So like this is clearly something that like Pete Udolph probably got a lot of recognition on ArcDaily, and since then like whenever GPT thinks of landscape architects, it thinks of Pete Udolph, and so this was something where like we would have to intervene every now and then. But I think this is also this exercise of playing with the schema. In a way, the schema allows the LLM to kind of, it's like to do things that are improbable. Like, despite we're not touching the model itself, and like all the biases that like it also needs to some extent are in there, we kind of force it to go out of its comfort zone with all of these things. And by doing that, we can see how it performs, and we can also push the boundaries of what it's able to do. And I think this is the level of interaction that we went to with this project. I think like we didn't try to systematically, identify biases, also because this is like outside of the scope of our research, and it would require a completely different approach.
Yeah, and in general, it feels like this is what these models, let's say GPT, what this turns out is Western common sense. So whatever you ask it, this is the most widely accepted view of something. And this you have to offset because it gets hegemonic immediately. So you have to kind of play around with it. Let's see when we get other models from different parts of the planet, maybe we can put them into conflict, that should
Will
be
you agree that architecture is biased? Anyway, nothing is unbiased in nature.
Yeah, this is an exercise in embracing bias. Yeah, this idea that you can get rid of biases in databases, this is kind of nonsensical, because this means that OpenAI will be even more powerful, if it knows everything. So it's good that it's biased, it's good that it's weak as such, and it's good to embrace it as such. Yeah, maybe it's a bit too aggressive, but that's that's how it is.
It's YouTube. Well, thank you, Agustín and Adil. We won't have a break. Okay. Because we are going to start the second panel right now, and then after the first lecture, we're going to have a coffee break. So that's when we're having the break. All right.
We do not.
No. We do not. You're not allowed.
This one? No.
Oh.
But I am with this, and that's fine. All right.
I'm gonna pull my laptop out of here.
So we didn't time these talks too well because I am staying because I will moderate the next session. So the next session is called somewhat archaically projecting dimensions in the sensible. This is, I think, better understood by non-native English speakers and native English speakers because it's directly about the senses and how do we navigate through them. So we will explore the concept of dimensional reduction, which is a term that we know very well from neural networks, deep learning, machine learning, and so on, and its relationship to the human senses. We'll examine how, while working with neural networks, we are in a mathematical space that connects billions of data points beyond our sensory perceptions, yet we translate these connections into visual, auditory, or tactile experiences. For instance, OpenAI's GPT model trained solely on text understands that purple lies in between red and blue. This vicarious sensing by AI intersects with our own sensory perceptions, creating a unique form of synesthesia. We will discuss how this phenomenon compels us to rethink, augment, and even invent our senses again. How do we navigate this new scale of AI where sensing is outsourced to non-human intelligences? What new formats, forms of coherence, and storytelling ideas emerge from the sensory collapse? So in the panel, we have 3 talks. One by Mariana Popescu, one by Benjamin Dillenberger, and one with Elena Manfredini. And I would like to invite first Mariana Popescu. Dr. Mariana Popescu is a postdoctoral researcher at the Block Research Group. No, that's an old one. No, it's an assistant. She's an assistant professor at TU Delft, right?
And that's enough of an introduction.
Okay, she's an architect and a strong, and has a strong body of work. Please go ahead.
I think anybody would have still wished to be a postdoctoral researcher at the BRG at this point, so it's okay. I feel right at home being here. Can I do that? Yes. I don't need it on. Thank you. Does that work? Oh, wow, this is very seamless. Amazing. SETH. Seamless. Well, I will talk about a lot of seams, or maybe not completely a lot of seams. I'm very happy to be here. I think the last time I had the honor of presenting on the screen was some 5 years ago in my PhD defense, and it always feels like home, especially now that there's a carpet here. I'm going to have you bear with me in this presentation because it's a deep dive in a bit of a different topic than that one we've seen before. So the relationship between that might be quite a lot in the pixels, let's say, in how this works, in what the pixel wants to be and what we want the pixel to be, and you'll see why those pixels come back every single time throughout the work. Because of NITS. So I entitled my talk "Digital Materials Across Scales" because I do want indeed to have this kind of view on how we deal with material both at the global scale and at the local scale, and how we can create this kind of link or this kind of dialogue between the large scale and the zoomed-in scale. More specifically, if I think of those in terms of geometry. We could categorize those into, so one, the global geometry type of scale, where we think of architectural geometry or structurally informed geometry, and this comes very much from the heritage of having been here and in the BRG, as some might think I still am. They are not mutually exclusive, and sometimes they are actually, they work quite well together. But it's not only always about the global geometry, where we talk about these units, but actually also having a little bit of a deep dive in local geometry. And that local geometry could very well be understood in terms of material geometry, so specifically where we place that material within a structure, and having those tailored material properties. So really being able to say, I would like there to be this type of material here, and I would like it to perform this way, or vice versa if the material wants to do that. What these types of approaches, both at those kind of double scales, can allow us maybe is look into this reduction of raw material use, reuse, functionality, and architectural expression generally, so that we can go across all of those scales. And if we really, if we keep that on the one side, what I'm really trying to do most of the time is couple the way we design, build, and usually that's very specific, and fabricate, so that it can enable us to achieve these goals. And those enablers are actually computational tools. I put fabrication very specifically in between designing and constructing, or designing and building, because most of the work that I do is linked to fabrication, so I would like it to be there explicitly. And I don't talk maybe as explicitly about design, but you'll see how that gets informed through these. To get quite to the point in the deep dive, that's in that sense, I really work on how we could do better with the materials that we have, so that we use less materials. In the PhD that was developed within this building, actually, I looked at how we could build complex concrete structures in a more effective way, because if we have these kind of concrete structures that are thin, filigree, span large spaces, have doubly curved geometries, and so on, as you might see in this image. We can reduce that material use, but what we usually have is a problem in how we build them. And this image is by no means an actual is in any way a sort of criticism to the master builders, Felix Candela or Pierre-Louis Genervi. It's actually kind of an homage to say that these people at that time were also looking into this, into material efficiency and how we might rationalize geometry and build that and come up with systems to build. So if anything, it's looking at that, taking inspiration from that and trying to translate that to the modern day. In that context, the system that I usually talk about is a lightweight formwork system made with knitted textiles very specifically. Now, textiles are used for formwork more often, and they have been kind of explored throughout the past 100 years or so. What's special about what I do is the knitting side of things in that sense. The reasoning behind that is that they're fast to produce. They can allow us to reduce this waste and be used with minimal intrusion. So I'll give you a few examples of that throughout the presentation. The idea behind it is that somehow if we move away from a traditional formwork system, so one that we're used to where you have timber forms or milled EPS forms or whatnot, into one that uses a membrane as a forming system, we have an avenue to use less material, both in the structure and in the building thereof. There are really, how something like this works is we start with a design, hopefully a structurally informed design, so one that uses less material. For that design, you produce a fitting textile, a fitting knitted textile using existing machines. So it's a robot of a different sort. That textile is then taken to site and it's tensioned into a rig. And that tensioning can be done in any number of ways. So you could do this with an exterior frame, as you see here, with cables, with splines, with inflatables, however you see fit, or however the structure deems fit. And then it's coated with a thin coating that gives it an initial rigidity to make the form work. Now, this step so far is quite important because for all of their advantages, knitted textiles are very soft. So if you were to attempt casting anything into them, they'll deform quite drastically, and that doesn't really bode well with us wanting to get the structure that we want to get out of it. So keep that in mind a little bit. There are two challenges in this. The first challenge is if we do have a design, how do we get to the fabricated textile for it? And those can be addressed through computational pipelines. And the second challenge is, if we do have that textile somehow magically fabricated, and it's not so magical actually, you'll see, how do we use it to construct things, to build things? And actually, throughout the examples that I'm giving you today, I'd like to show those two processes. Starting first with the construction side of things, very briefly, very fast. The first time we tested this out was, on the knitting and at the large scale, was during the Knit Candela project in 2018. You'll see that we give these names to projects because they're very much homages to the famous shell builders in question. So in this case, Felix Candela, where we reinterpreted that geometry of the high bars into one that is fully doubly curved and explored how that concrete structure could be built using a textile. What you'll see in I'm not going into details about it because it just shows, it's a project that I've shown a couple of times, and I hope it is one to show how the system works. So then that kind of textile that gets manufactured is tensioned in a rig. It's coated with a cement paste coating in this case on the one side, and then concrete is applied rather traditionally in a manual way, as you can see in that image. And you end up at the end of it, when the concrete hardens, you can take away the frame. And you end up with a structure that looks a little bit like this, that kind of has this, this play between the hard concrete exterior and the soft textile interior. And that's just a video of it in those sense. Why this project is particularly important, or a pivotal point, is because it looks at the construction of the concrete side of things, right? So how we can have such a lightweight system carry a heavy concrete load, or whatever other molding material you might want to mold. And on the other hand, because it actually really looks at how we might scale those textiles and have them very specific for the purpose that we need. And some of the takeaways from that are that, well, the textile themselves, the formwork, the 50 square meters, including cables that were needed, but excluding the outer frame, cost about 2,500 euros, 2,500 francs, 2,500 US dollars in the meantime, you know, well, whatever translates. They weighed about 25 kilos, and the cable net weighed another 30, so in the end, 55 kilos carried 5 tons of concrete. And here is where it gets really interesting, at least for now, is that it took 36 hours of machining time to produce those 50 square meters of doubly curved surfaces, and it would usually take about 750 hours to mill 50 square meters of a comparable doubly curved surface. And it took 14 weeks from design to the structure standing there. And that bodes something, that says something about the kind of productivity that can be achieved if we have the types of systems that enable that. Now, this is a little bit cheeky because, of course, the 14 weeks doesn't take into account the 2 years of development for these kind of things beforehand, but once you have it, it will take you 14 weeks, possibly. But what are those developments that enable this? So what makes this possible, actually? Is the fabrication pipeline side of things, so the first one that I showed you in the image. And that fabrication pipeline is important because usually, though it may seem trivial, these types of machines are usually used for clothes, so for the human scale. And they work with a set of instructions that very much looks like a bitmap. And that's where the pixels come in. So those are the pixels that I promised you in the beginning, and they will keep coming back. But those pixels tell the machine how to work, where to place the material, and their different colors also tell you what type of operation should be done at that particular spot. So it's actually encoding a type of action into a very simple 2D pixel grid in that sense, and that brings out 3D geometry with all sorts of features in the end, if done correctly. Most of the time, these types of things, these types of images or instructions are made by highly skilled technicians that know exactly where to place which feature or which operation so that you would get the geometry or the feature that you want in the end. And that is very laborious because you have to imagine that each one of those pixels represents a square in reality of about 2 by 5 millimeters, sometimes less, sometimes more. But it's a very small resolution to work with if you really need to click it by hand. Now, if we want to do this at a larger scale, what we need is these kind of computational pipelines that translate that design into an instruction for the machine automatically. And that's what enabled this kind of project or the 2 years of development beforehand. What this really does is actually a 3D remeshing, or looking at a 3D remeshing of the object or the geometry that we want into a topology that can then be represented as a 2D grid. And that 2D grid can be represented as a pixel grid that can be then given to the machine. So there's this direct relationship between a 3D object and a 2D representation of that object. Meaning that you actually produce something 2D that is 3D. That's what the machine looks like in general. It's kind of just a plotter that just goes line by line and adds material where you've told it to add material in that sense. I'm showing it because it's not, these types of developments are not only interesting for us, but they're interesting for machine manufacturers as well, specifically because it gives them an into a different field or a different sector that they're not actually active in. So it's nice when you also make other manufacturers happy. Most of the time, it's not only about making them happy, but though we show these kind of machines in isolation, because in a research context, it's usually just one, the truth is that there are many machines like this all over the world. So there are hundreds in factories churning away socks or whatever else they're doing for us. So if we can actually make those types of instructions, we can really send them very lightly wherever and have things be produced locally very easily. So we can really tap into this type of power of production that already exists there. The next project that I wanted to show you was one that we finished in 2022. It started out as just an ETH project, then I moved to Delft, and it turned into a cross-country collaboration in that sense. But let's say it's an evolution of the first one that really looks, again, into the formwork system itself. But not only that, into how we might bring it closer to what something that industry might understand as implementable a little bit sooner than the other. In this case, as the name suggests, it was called NIT Nervi, and it is inspired by Pierluigi Nervi and the Palazzetto dello Sport. So the pavilion was built in at the Maxi Museum in Rome, so just a couple of 100 meters down the street from this. And what you'll see here is this kind of diagrid of ribs, so a ribbed shell structure that is also maybe not as easy to build always. So we look into how this might be built. You'll see that kind of interpretation of this geometry in the funnel shell that you see here. And because, of course, we had Lotte working on it. Lotte is a PhD student still at the BRG, but comes from Stuttgart. So you might see this nice little droplet that's evocative of these kind of Frei Otto geometries as well. What you'll see here in the geometries that we try to make this kind of diagrid structure, you'll see that it looks a little bit more recognizable probably to industry, and it includes reinforcement. This is what it looks like from above in the end, so you'll see the kind of diagrid. It looks small, mostly because in any photo that we take, it's either dwarfed by the museum, that is huge, or it seems somewhere placed alone in space. The truth is, for context, this is about 2 times the size of the previous structure I showed you. So this is 9 meters in diameter and 120 square meters of textile, right? So we have I'm going to come back to this, but we have an order of magnitude of scale in that sense. So this type of process also started with a form-finding exercise in the beginning, right, to get to the geometry of the shell. So you'll see how this is reinterpreted by moving the supports up and down. And in this case, what we also wanted to do is make sure that there is even less, let's say, waste or support structure that's not used subsequently. So in this case, we took the rebars that would be the rebars in concrete. They're a bending active grid shell, and they would become part of the structure, but they are the ones in this case supporting the textile with some 3D printed nodes from it. This is what it looks like during construction, just so it gives you a little bit of an idea of how that bending active grid shell looks like as a structure on its own, and how this gets covered with the textile in the end that would become the formwork for concrete. So if we explode those kind of geometries, it looks a little bit like this. There's some standard scaffolding support, and that's the only part that's not used within the structure eventually, but the standard scaffolding support can be taken away and used anywhere else. So there's really very little waste there. There's the grid shell false work that becomes reinforcement within the structure if it were to be cast, the knitted shuttering, and what would have been the ribbed concrete shell that results from it. Now, full disclosure, if it wasn't clear from the images already, we did not cast this. There are 2 reasons for that, and while you see how the first part was being built up in rather traditional ways, the reason for not casting that was, for one thing, we did it before, so we could reasonably assume that we've shown that you can use it, although you never do until you do. Secondly, it was a temporary exhibition, so if we were going to make a point about being sustainable about concrete use and then make a structure for 5 months and demolish it, we thought maybe the message is not completely there. But third of all, it was in a museum, and the visitors to the museum were not necessarily people from the construction sector or architecture, so it gave us an opportunity to look at how we might offer the visitors an X-ray through the structure or an understanding of what a structure is built up like in general terms, and think of it think of the whole build-up in a fully deconstructible way, so that it's modular and it could be constructed and deconstructed instead of torn down. What we did is we built first the grid shell, so you'll see it ends up looking like this. We measured everything about it. And then decided to start the production of the textile after the grid shell was built, so that you would create an actual tailored fitting textile for it. I'm bringing back this image because in this case, why that's again an enabler is because instead of, as in a normal process, starting to produce all of the components for the building at the same time, because otherwise you wouldn't have time to to deliver it. We could stagger it, so we could wait, get extra information, and start the production of the textile later. But also because it did require a further development of these kind of pipelines. Now we're talking about 120 square meters, not a 50. So we're looking into a little bit of a different scale in terms of computing power or how you generate these patterns. And we also started looking into how we might address very specific material properties locally. So if we start looking, in this case, until now I've been talking about the global geometry of it, but in this project, local geometry starts playing a role in the same way through a real specific tailored materiality locally. So what you'll see is in the transparencies, and this will come, they're a little bit difficult to photograph, but in the transparent parts in between the diagrid, you'll see that there's a little bit of a gradient for each one of, so you'll have graded material properties there that are fully controlled during fabrication, but they're also fully controlled during that generation process. And to do this means that you need to generate your patterns or your pixels in a very precise manner, otherwise it becomes a lot more difficult to control. So in terms of computational pipelines, that meant a development. In this case, we didn't have just 4 pieces as in the previous one, but actually 72 pieces that needed to be made. So you need to generate quite a lot of data and make sure that you can control that. Just to give you a quick idea of it, we started with a density distribution for how we wanted the material to be. The diagrid themselves doesn't have a density variation because that represents the concrete. And then for each one of those pieces, what it would do is generate that 3D topology, right, of points that represents a 2D grid. In this case, just for context, it's about 30,000 generated points to get to one of these. Each one of those understands its relationship to the structure in space, understands what it's supposed to be as a function in the final one. So for example, the magenta bits know that they need to be a channel, and then the other ones know that they need to have a particular density. Now, the 2D representation of it would look something like this, but there's another catch. This type of grid would only mean that each one of those pixels is actually a 4x4 grid, so it needs a post-processing part where you can transform those into actual instructions for the machine. So they've been generated actually on a 4x4 grid instead of very specifically on a 2mm by 2mm grid. That looks a little bit like this. I just go really quickly through it, but it's this kind of post-processing of a pixel into extra pixels that really decide these types of functionality that come within the final product. And then after all of the different steps are there, what you'll get is an image that looks a little bit like this that can actually be fed to the machine to create all of those different densities within the final geometry. You'll see again the machine producing these kind of textiles. You'll see all of the pieces, and the classical, we've put it in one bag and took it to site because it's lightweight and easy to take there. But again, we could just send the instructions. And then this time around, you'll see that you don't need necessarily a qualified team of builders to put things up, but a rather unskilled worker that can just assemble these things in sometimes a little bit more time than they thought. So this is what it ended up looking like in the end. A few views from the inside. And here I think it's a little bit more clear how you can see these kind of transparencies or graded material properties that can be done with such pipelines. Again, that kind of project looks at both the efficient deployable flexible formworks on the one hand, but also at graded material properties and the computational fabrication pipelines that are needed for it. So it's really across different topics at different scales. Now, if we started with 50 square meters and the second project ended up with 120 square meters, it turns out that, I mean, this was 2018, this is 2022. It turns out that roughly every 2 to 3 years, I like to double the amount of textile that we make, and I like to pretend that I'm a construction worker. So this year, we doubled that yet again. So we went to 300 square meters of textile, and being construction workers, because we built a pavilion for Bruges, for the Bruges Triennale. It's called Common Thread. We've done this together with Soil and Summum Engineering. And it was built in, this time around it has nothing to do with concrete or things like this. It's purely looking into how we can apply these techniques and how we can scale them up in a few ways. For the Triennale, the Triennale theme is spaces of possibilities, and actually what they're looking at is, because Bruges is kind of seen as an open air museum, is looking at spaces that are not usually visited and are not accessed, and how we might bring in new life or new use into these spaces. So actually, it's very difficult to see on here, but it's just within it's a structure within a large courtyard that is actually otherwise never really used, but beautiful. It's inconspicuous, so you get there through a garage door that you may or may not find, and it might just give you this kind of wormhole idea and tell you, hey, come in. And if you do, you go through this kind of down the rabbit hole in this simple sort of tunnel, but that flips you inside out in moments and creates this kind of space and this, within the courtyard, to try to thread, let's say, a sort of connection between outside and inside, and between the past and the future. And why I'm saying between the past and the future is because actually what Bruges is also known for is something that is also rather computational in a physical way, but Bruges is known for lace making. So there's a lot of lace making there. So the inspiration there was into using a textile, was into looking into these kind of lace making techniques and how those translate in the same way to our machines, and how we make this type of, well, let's call it digital lace in this case, and how we could transform those techniques. So in this case, again, there's a point of trying to work on those computational tools, this time because I need to get the kind of very specific control over these types of lace that we designed. Actually, everything needed to be generated at a 2x2 pixel grid instead of a 4x4 and so on. So it just gets bigger and bigger in terms of computational needs in that sense. What you'll see is that it's quite, after production, it's quite easy to put up. I mean, it's basically a tent, a lightweight tent that we've put up there. It took about 10 days to put together, so this time lapse really makes it look a bit too easy. It wasn't quite that easy, but we like to make things look easy, and it's a little bit, it looks a little bit like this in the end. It is a very tall structure, so it did challenge both the geometry of things, but mostly in how we create those textiles in the end. And finally, one of the images that I really like is because, to some extent, of course, from the part that is here in looking into the past and cathedrals, this is my textile cathedral instead of a stone cathedral as they usually are. Finally, I have, because I did call it digital materials across scale, and we kept going up and up in terms of scale. The truth is we don't always need to go up and up. So I hope that in 3 years I'm not going to be on a scaffold doing the 1,000 square meter pavilion, but rather, or somebody else might be and I just design it, that's fine. I'm trying to go back down in scale so that we can understand some of these mechanisms a lot better. One of the projects that the last project, bigger project that I wanted to show is one that was born out of having been children of this building. So it was done together with Katrin and Norman, so with TU Braunschweig and TU Munich. And it's actually looking into both an educational side of things, but also in because we did it together with students, but it's actually taking a concept that from each one of us and scaling that up a little bit. So it started with a small bridge that you can see at the end of the corridor here. And we said, hey, let's scale that up and see how we can automate some of these processes. So the textile is not very special. And if anything, compared to all of the other projects, it's the one that went the wrongest of them because of the smaller scale, I guess. And combine that with automated fabrication technologies that are being developed at the other universities as well. So in this case, instead of having a manual concreting process, there's a automated path planning and and robotic fabrication setup to add that first coating and to add all of the other layers on top of it. So it's really trying to solve different parts of the problem in terms of construction and digitalization at different moments in time and at different scales or in different contexts in that sense. So if I were to sum that up, what I'm trying to get at is looking at the structure as a whole, right, at deployable formworks, at graded materials on the other hand, so mitigating these kind of two scales, and how we might have adaptive or hybrid systems, so the different types of materials or models that we can put in there, and how we can address that automated fabrication of it. There are a few hinges in this. First, the computational design one that I've kind of put forward everywhere, so how we design both of those scales. Then how we have those computational fabrication pipelines, so we can get to that automated fabrication at whatever scale it is or for whichever part of the structure. But the more interesting one that at the moment that's really pushing me into the smaller scale or into the pixel scale is that, well, while we might be able to design these materials and we might be able to very specifically fabricate them and control their fabrication, one piece of the puzzle that is missing is that doesn't necessarily mean we know how they behave and we know how to make sure that they have the behavior that we want. So one of the very large missing links here is the predictive material properties, so figuring out how those are, and that would be what allows us to close that fabrication design loop. And in that sense, I'm moving always close now into the more zoomed in scale. And I wanted to just give you very brief examples that are newer work that move into the scale is looking at the different types of textures of the material and the local architectures, how they combine and what kind of an influence they have. So really zooming into the material. How they deform or how they perform, how different combinations of those materials do perform, and how we might be able to start understanding their performance in that sense. In these cases, what you'll see is that we don't have a coating, but we're trying to understand how this works really with the deformation of loads in that sense, and how we might start thinking of these in modular terms. I'm working with a textile, meaning it's flexible. Now, we try to freeze that flexibility with a coating, but what if we were not to freeze that flexibility? That means that we might have an opportunity for reconfiguration, reuse, and modularity within it, because you could get different geometries from the same piece, and you can get different behaviors from the same kind of material grading within. So that's really difficult to understand at the moment, and that's something that pushes me to go there. So there are just some examples of recent work in that sense. So what you'll see here is also this kind of reuse of the same piece over and over again. I'll skip over the other ones because it kind of ties into a structural reuse part of things and how we might map, let's say, a existing domain where we've had a structure into a target domain, the structure that we want to build. So we're exploring these things also with concrete and with wind-blade turbines. So it's really this kind of mapping of two spaces onto each other, regardless of your source or your target space. And at the very, very last, I want to highlight the people that have made my life really, really nice for the past 3 years and have absolutely helped me get there with what I've been showing you. So there's a team of wonderful students and PhD students in Delft, where we work on 3 different topics, basically. A lot of it is the simulation, prediction, and design that I've shown you, but we also look at structural reuse and adaptive and hybrid deployable systems. So although it might not be immediately clear where all of the AI or machine learning comes in, it's in the pixels, I promise you. So thank you very much.
We're ready for questions, if anybody has them.
Yeah, so this is maybe just more technical, but as far as I understand, it's flexible in a way, but also you have to be super prepared, right? You think in millimeters
Mm-hmm.
So when it comes then to building the structure, it could happen that it's maybe too short. Like as far as I understand, with the bridge, there was a problem.
Mm-hmm.
So, but is it then flexible? Can you adapt? Because if you are then on the building side, you cannot change anything for this framework anymore, right?
That's a very good question. The flexibility is both a challenge and an opportunity. So on the one hand, because it's flexible, I'll address the size thing first. First of all, yes, just like with the bridge, we need a calibration step. So you need to make sure that your algorithms produce the things but that's relatively simple. You calibrate, you do something, you test it out, you calibrate it, you'll get there. What I'd like to do is bypass the calibration, and that's where some of these developments on predicting material properties or having those material models help. But let's say that's something that can be taken care of. The flexibility that remains is that you go to site and you'll have something that can move because it's flexible, right? It's not rigid, so I'll span it, and if I step on it, it's going to deform, and it's very difficult to control how this deforms and so on. So that brings a huge challenge with it. On the other hand, it's adaptable. So as opposed to something that's very rigid, and if you get to site and it doesn't fit, it won't fit no matter what you do, there's some room for fitting it in this case. So you could adapt to the site, you could adapt to slightly different support conditions. Stretching it more or less, you stretch it more in one direction, it might stretch a little bit less in the other, so it really depends. But it doesn't need to be millimeter precise in that sense. If you're, I'd want it to be, but that's something else.
I was wondering, what is your take on the industry of construction when it comes to bringing this to an application beyond a temporary pavilion? Because I think when it comes to concrete, you bring to the table Nervi, etc. Certain things, when you look at them, you know they were built in a time where code allowed for that. Nowadays, codes have a different maturity and different requirements, and a lot of what we look into in terms of concrete use and the energy they take, the amount of money, a lot of it is really pinned around the issue of what is required for somebody to build by code.
Sure.
Meaning, and that is one of the major obstacles for certain things that are really linked to fabrication to truly enter the world of construction in a larger scope with a true impact, I think, beyond the research. So I was wondering what's your take on that? Because I feel like if there is a place like ETH where those possibilities can happen, I think this is a good platform where I think the policies of bringing research into the real world have at least a possibility. I'm wondering what is your take on the timeline in which certain things could come to fruition?
That's a very good question. So, and it's very true. One that I get more often nowadays, because I'm in the civil engineering department, they're like, oh, what does the Eurocode say? And the Eurocode doesn't say much about this particular. But the truth is that, so on the one hand, I don't necessarily concern myself with it in the sense that what I'm proposing is a means to get to a structure, and it's usually the structure that needs to abide by the code. So if you can design the structure that abides by the code, then you will be fine. But you're right, the structures that I mentioned are, of course, thinner, less reinforced, and so on and so forth. So the codes might be a little bit different. But I don't think that the problem there might be a paradigm shift or a shift in our thinking about how what the structure in the end needs to be. So that's one of the things. I do less work on that, to be honest, but I think there's plenty of possibility there. Usually it does mean that there needs to be some extra testing that needs to be done just to prove that. So as far as I know, in Switzerland at least, or in Germany, or in most places, these kind of things can be done through testing as well. The formwork itself doesn't change that. It just enables it. It just enables you to create a different type of structure.
Yeah, specific testing to prove that it works, the structure and testing every single element of a building would allow you to pass code, and that's also why the reason in which this thing is done there. Yeah, for real.
Sure.
It's a no-go, and I was wondering if there is a place where certain anomalies, like this one, that produce a certain level of saving, which is really what you're advocating. We're saving using this system. Is there a way in which this could truly enter the reality of building without having to go through that? Like, if the code will become intelligent enough, if AI will become intelligent enough to actually bypass all those testing that make this impossible.
That would be the dream, right?
Yeah.
But no, that would be the dream.
Maybe the AI is not really just about the pixel. I think there is something to make this
That's a very good comment.
truly effective, which is a macro problem, which I think when they ask me about these issues as an engineer, I actually think policy is one of the major issues.
Absolutely.
You're not really our research as architects. But anyway.
I think both, and probably the research pushes that policy to be changed as well. So it's a double one. I'll be honest. I don't work on the policy side of things, right? So that's not that's. I think it's very important. Yes. If I can have an answer to that, we recently got a European project, and there is a construction company that's involved in it. They are very interested in making it work. They think it's very feasible to make it work. So if you can get a construction company that's usually very to say yes, then you're already a step closer, because they will push for it. And if they want to implement it, they will push for that change somewhere, or they'll look for the avenues as well. So for me, the indication that there is room for it is actually in somebody like that joining a project, to be honest. But yes, you're right. Lots needs to be done on that.
I have a question.
Yes.
And, it's more on the sense of how these projects are conceived. Are they, like, I understand that there are projects that are part of a class, so you have students developing the tools, and then you eventually
no, they're
test.
not.
They're not. So that's what I wanted to, because we were here at ETH, and some of the pavilions were a class group. So I wanted to know, how did you come up with the projects? What's your, like, if every of the projects that you show us had a different path, so you have like a firm, or you have an industry partner, or then you have motivation, or you have something to, like, how did they come to be in your repertoire or your portfolio? And how, like, are these collaborative projects? Are they belonging to a class, or this is, like, I would like just to understand.
Yeah, sure.
To give
So generally they're not part of a class. The only one that had an educational component very specifically is the bridge part, and that was meant as a, let's put our technologies together and let's look at it also from an educational point of view. The other ones weren't. They were opportunities somehow. So the first one was the first two, let's be honest, are opportunities at museums that came to BRG. So that's the way. And then they are all very collaborative. None of these things can be. I hope that also the kind of the credits are there. So there are usually big teams behind them that look at all of the different aspects of it, right? So Nit Candela and Nit Nervi were that. The Triennale, I was approached by an architect. So Soil is a New York-based company. They got commissioned by the Triennale to do a installation for the Triennale that deals with the public space. So it's really an architectural intervention, and they wanted to do it with a textile, and they ended up on my doorstep, and it ended up being a collaborative project where we looked at how this could be done with a knitted structure and a tensile structure and so on. So that one was one of the smallest teams, actually. We were just one or two people from the architect, 2 people on our side, so me and a research assistant, 3 people in the engineering team. So they're all different, but mostly they were not educational projects, actually.
Because I wanted to write my idea of what Elena was saying about how do you actually make this into code, and I think a way to make it into code is just to spread the word and have as many people as possible touching it, seeing it work. And I think this also relates to the idea of is it coming from an industry, is it coming from whom?
Mm-hmm.
So then this really makes a change.
Mm-hmm.
If it's coming from you, then you can challenge some code. Like this could really be something like a proof
Mm-hmm.
of concept that then can really share
Mm-hmm.
and be shared.
Mm-hmm. To be quite honest, I mean, all of these things take time, right? So it's not an excuse, but in the beginning you start with, can this even work? So you're trying to make it work. You try to show that these things kind of work till you get to the code. I mean, and now we're getting to the code. So I guess having the discussion of the code is quite nice because it means that at least there's a conviction that, oh, it could work. So now how could we actually make it work, right?
Maybe I can ask a quick question as well. So, big fan.
Thank you.
I really enjoy I really appreciate the fact that you tap into this kind of these industrial processes and even the machines. So it's not some kind of artisanal practice, but it taps into infrastructures that we have available to us already. So this is fantastic. And then yeah, also how these structures come about. I mean, lightness would be the word I would choose,
Mm-hmm.
right? But I'm curious about a few things that you didn't talk about.
Mm-hmm.
So I'm curious about the figures that these pavilions have. I'm curious about the shape that they acquire.
Mm-hmm.
So is it always the flaunting of the means of their production that produces these shapes? Or does it come from elsewhere? Does it drop from the sky, or does it come?
It doesn't. It doesn't drop from the sky, but it is a bit contrived, right? So it's or maybe it's not contrived, but it's always a dialogue between, sure, the global inspiration, right? Which with the Felix Candela and the Pierluigi Nervi comes quite a lot from a rationalization of form and that efficiency and shells and so on. So you look into this and to coming close to compression only. So you take inspiration, those kind of principles. In the last one, it's not so much about that as it is. There are only particular, as it was about. Yes, there's a particular way to work with a textile. It's a tensile system. So you'll have to abide by the rules of a tensile system to get to these geometries. You cannot just do whatever else. So it's always a dialogue of including the principles of what kind of shapes this type of technique can take and what kind of shapes you want to achieve in particular ways. So it's never in a void, because quite honestly, with the usual going about things of saying, I came up with this idea and now we're going to make it with this and then we pass it along, it will never work. So it's always actually a continuous dialogue between those two, and they inform each other, right? So you start with, okay, we have a tensile system, so that informs the types of geometries that we might get, but at the same time we bring other things that inform those geometries and constrain this further. So it's usually this kind of dialogue.
Thank you. Actually, maybe following up on that question, I'm curious because, of course, working with textiles primarily, right? The geometry is informed by that technique. What is your experience, at least in terms of maybe struggling with or trying to incorporate other types of materials? So, like the first project, of course, is concrete. That's forming work, but the project with Soil is fiberglass rods.
Yep, that's correct.
Right, and so besides fiberglass, what are other possibilities that you may have thought about, entertaining, even wanted to try?
Well, some of the easy ones are we've included rebars, or we've included inflatables, so you can use some of those. Something that I haven't shown, but shape memory alloys. That can be used in that. They're not, but that moves a little bit away, and you might have seen it. That moves a little bit away, maybe from the concrete formwork side of things, right? And it goes into functional integration somewhere else. I'm using basalt fiber as well, and we use it as a formwork for glass, for example, in a different project that I didn't show. So technical fibers, but also not so technical fibers. Natural ones. specifically for growth in some situations. But it's really just a dance of putting together flexible with rigid elements. And actually, the last one is it's quite difficult because of the fiberglass rod with they're actually two flexible elements. So the complexities of things kind of compound there. So I usually try to take some of the complexity out somewhere. But I don't know if that answers it, but a few different things.
Yeah, I think it's really interesting because there's always this sort of, let's say, tension between wanting.
Tension is the right word, yes.
Well, yeah, pun not intended. Tension between trying to do everything with one material versus, when you start to incorporate more different layers and systems, and it goes back to the code kind of question is, at what point or how much do we need to ask of a single material, but then how can we connect it to the other systems that are necessary?
But that is very true. I don't believe in single materials, and I don't believe in holy grails. So I don't think that this is the holy grail of everything that should be applied to absolutely anything at any time. It's more of an appropriate tool for the appropriate moment in that sense.
Any other questions?
As a follow-up, first of all, thank you for the presentation. I love all the explorations. I want to start from the precedent you shared with us, Pierluigi Narviso that tells the story of negotiation between material as a premium and cheap labor to make an optimized structure. And looking at the sequence of projects you showed us, you kind of see instances where there's more. Some projects are, one project was more material, kind of intensive, another one was more labor intensive, and the other one was maybe somewhere in between, at least that was my understanding. So my question is, do you see direction or your research converge into a sweet spot where you have a controlled or intentional amount of all these components? Because
I wish.
about there's a lot of machinery involved, so that might have an effect on cost. There's more labor.
I don't think there's a single equilibrium, if that's what you're asking. I think it's very much site dependent, project dependent, and let's call it brief dependent in that sense, and locality. So what you can get. So no, I don't believe that there will be a sort of, and the recipe is this no matter where you apply it. The other constraints will be there, and they will inform this, right? So it will be a sort of, okay, well, in this context, as it has been throughout history and as it has been for Nervi's work or anybody else's work, right? It says, suddenly material is expensive, but labor is cheap, so we can do this and we don't need to do that. Or suddenly material is super cheap and labor is expensive, so you kind of invert those. So I think it will have a lot to do. I think all of those components might have a sweet spot themselves, but then depending on where and for what purpose it's used, it will have a different balance of the different components. Just
Thank you so much for the lecture. It makes the whole concrete framework so easy. It looks excellent. I just wanted to ask, did you ever explain why you chose blue?
Well, it is one of those things that I think is just going to stick with me from now on. It's going to be blue, and that's my signature color. But it wasn't something that was that is intentional. Well, it is intentional, but it wasn't something that intentional. So for the first one, for Niscandela, it just we wanted the colors. It was a nice backdrop. It was just. And it was a little bit of an inspiration of a Jaisco dress that has a lot of these different colors. The second one around, I particularly love that type of blue, so I wanted that. But it kind of got informed by the museum in the sense that the space is so gray or white or concrete that anything you put there needs to be a little bit of a pop of color, but then you don't want it to be red or something of the sort. And there was a fountain in front of it, and the name of the artist escapes me, but he's famous. that had a blue, and we said, why don't we just echo that? So it came to be. I think I'm sticking with the blue though, because I happen to like it very much.
But then have you had a chance to kind of work with other artists or cultural or aesthetic-wise in terms of the fabric or needing? There's a lot of.
There's lots of, but on the fabric itself, no. I mean, in each one of the projects, there's some. Well, the Knit Candela has Zaha Hadid Code group in it, right? And then Soil is an architect is an architecture company, right? They work a lot with textures and materiality in that sense. But no, I got free will on the textile and the colors. I'll look for the people that could help me out with the aesthetics of it more.
Perfect. Thanks a lot, Mariana. Fantastic.
Thank you.
So let's take a short coffee break and then we can return. We're running extremely late with time. All right, so we are going to begin again. I want to introduce our next speaker from right across here, Benjamin Dillenberger. Benjamin is a postdoc. No, not really. Benjamin is a Benjamin is a professor for digital building technologies, based here, right in this building, just here. I will not speak any further. We are running short on time, so please, I can rush this, but you can relax and take your time. Perfect. Thanks a lot for being with us.
Okay, thank you very much. It's my pleasure to join the symposium. It's of course a bit difficult because the people that are in this building see my presentation every 2 weeks. So now the challenge is how to be entertaining still. So I thought that I show some of the projects, but maybe from a different perspective, from the perspective also of the symposium about playing models. I entitled the talk "Building and Drawable." This is an early study where I analyzed Christopher Alexander's pattern. What's the name again? Pattern language, and because I'm interested in how we can support or which kind of instruments we can use in the design process that go. We were first at the previous talks a bit talking about bias, and I'm looking forward to overcome my own bias by using these instruments that help us designing, help us to be more creative, maybe exceed our own, the capacity of my own imagination and being surprised and stimulated by the computer or by the digital. And also the title refers a bit to an older lecture series I did together with my colleague Michael Hansmeyer back 2010. It was also already entitled Drawable. Here we focus only on the computational design aspect, not on the realization. And then back to my background, I'm related also to Ludger Hovestad's group. That was one of my first student works I did together with Ludger Hovestad as a professor about the models of computer games, the levels and how we perceive them as a kind of architecture. So that is closes somehow the circle. Yeah. So I will talk now about the way which kind of processes we use for modeling architecture, for designing architecture, breeding, growing, finding, learning models, but also about how to materialize them. So it's a very important aspect of our work, how we bring our designs back to reality, how we can manifest it, but also how we can play with the process of the materialization. And one first project uses an evolutionary strategy, so it's about breeding architecture. It's an early work where we basically just studied, can we let the computer compose the circularity of a building by an evolutionary process, by creating many, many variations, and we give some target constraints that we want to fulfill, and we let the computer fold this architecture that maybe reminds us a bit about some Koolhaas concepts of a continuous space. But what is interesting for us as designers then is that we can basically just work with the process without a preconception of the space in mind, and then later explore what is the proposed solution. And so that means we take a different perspective towards the design than if we would have drawn here every single triangle by hand. And here some of these studies. We didn't manage yet to materialize those structures. But it's a circulation where you don't cross the path, where you don't need stairs, but you can explore manifold variations. So these kind of evolutionary processes we use quite often also in projects like where it's about housing, where we let the computer just create as free as possible variations, and we basically not control the outcome of the design, but rather the properties. We filter out the properties that we would like to achieve. The growing aspect, so that's more about maybe not about finding optimal solutions, but more about refining geometry, refining form. And here an important work was always done together with Michael Hansmeier about subdivision processes in the computer, where we basically inverse the process of smoothing geometry based on a limited set of control points to increase the surface of geometry by a parametric subdivision process. So you see here a two-dimensional diagram of this process where we would split lines, split and fold the geometry over and over based on a set of parameters. In 2D, that could be comparable to, or 3D, that could be comparable to folding of a paper. And what we control then with the computer is the folding ratios in order to articulate very specific geometric forms. So the input shape of this form is a cube, and it's subdivided over and over. I mean, our subdivision processes are almost integrated in every CAD software, but we don't use it for smoothing, but for rather articulating the shape. And what is an important aspect here is the way we control these subdivision processes. So we have a kind of a data mining between the iterations. So these are millions of triangles that we then classify into different regions according to properties. So we create very specific zones. You cannot do this manually anymore, so we have to do this by basically categorizing them in different fields, and then we apply different subdivision rules in different regions. So that allows us to exaggerate some of the initial properties of the geometry, further articulate them. And it turns out that this kind of process of reacting on already procedural generated geometry and further informing the next procedures based on the distribution of properties of this procedure allows us to replicate existing styles, but also create new ones, like in these studies of domes, where we then breed an entire family of domes based on just variations of these subdivision schemes. Yeah, and maybe a project that we didn't show so often here, that was our contribution to the MoMA PS1 competition phenomena, which uses a similar process. So we are then also interested in really constrained outer boundaries and create this inner fountain grotto-like shape already. That should be the background for the PS1 festival. We didn't won, obviously. At this time, I think the water infiltration system won as a for the. But you see here, geometry that is basically not, none of these geometries is drawn. I mean, none of the geometries that I show in the talk is drawn, but all derived through these procedural methods. In this case, there's no optimization, just aesthetic optimization. So we would breed a set of variations and then filter out the ones that actually inspire us and come closer to our original intention. How to materialize then these projects? A very early study was another model. That's a Modellstadt, again, a city model, a Stadtigel that was created at Ludger Hovestad's chair together with Alex Lehnerer. That was for the Urban Biennale in Rotterdam. So that's one of our first 3D printed models, actually. And how to scale this up, we took inspiration of a work from Mario Botta, which is a basically layered a replica of a Baroque church, San Carlino, that was temporarily constructed at the lake in Ticino. And our previous colleagues, Tom Pawlowski, developed a 3D printer based on this principle that can use cardboard. So it's a one-to-one 3D printer that cuts and glues cardboard layers together. You see here his study, so that's not my design, his study of stools that can be then excavated out of this low-cost but very fast 3D printer. And we use this then to actually build this Stadtigel in 2010 out of thousands of layers of corrugated recycled cardboard. So it's still, I think, one of the most sustainable 3D printing methods. We don't know where this sphere actually ended up. It was suddenly lost at the Biennale, and maybe it's rolling around somewhere in Rotterdam. But so, of course, Michael Hansmeier's work was also based on this principle. Here in the building, laser cut cardboard layers these columns that he did, and just I show it because it's another variation of the theme of constructing in layers. We continued also to investigating the topics of columns, but asking us how can we materialize those in different ways. This is a study together with the MIS 2016 with our postgraduate program. The challenge of this one was just that it was the smallest columns we ever built. So we work with a photoresin printer. So the forest of columns you saw before was just would fit on a stamp. So that was also the smallest exhibition we could ever do. We continued working with this idea of a forest of columns, also with an entry to the Architecture Biennale Venice. So today I show all the non-winning entries we did together, Michael and me. Here, not being mature enough with the 3D printing methods, we designed the columns based on the principle of milling them out of a massive block of foam in this case. Here just some visualizations of how we imagined this forest of columns in the Deutschen Pavilion. Space-defining columns, that's a topic that you probably see also in many of the projects that I'm showing today. And these are also grown, of course, with a similar subdivision process. There was another aspect to this project where these columns would not be static columns, but they would be placed on autonomous vehicles. And so this constellation of columns that we would find in the German pavilion would permanently change. So the columns would interact with the visitors and then form maybe classical configurations or free configurations, and therefore very much changing the appearance of the space. Again, not one, maybe we try it again. That's why we have a little robotic platform over there to test this. So the concept was called Wandelhalle. So just that in this case it would not be the monks that walk around the columns, but the columns walking around the visitors. And then we became more mature with this 3D printer that I show in every talk. What is fascinating is the resolution that this 3D printer can do, the 40,000 by 60,000 pixels per layer. So we were talking before about pixels. Here we have a machine that can help us to inform a material on a very small scale in a very fast time. There was the next column we did for the Architecture Museum in Basel, woven column. So only the column is printed. And assembled here. Also, in this case, some parts are missing, actually. We have one sample over there, but the other two parts somehow went lost. But the idea is here maybe to play around with the topic of weaving a bit, and also, of course, finding geometries that are, in this case, maybe not undrawable, but maybe also very difficult to fabricate out of stone and with different techniques. And then finally, the digital grotesque projects, where the aspect of growing geometry became very important. We did many studies, usually running the computer overnight, and then on the other morning looking at the different variations that it would create out of these 20 or up to 100 sets of parameters that we can finally control in this subdivision process. And these are just some iterations of the design we developed. And it was always the search between chaos and order, between something that is a bit familiar, so not too random, not too chaotic, still relating to some architecture vocabulary, but still also seeking for surprising moments. So that was really an interaction with the computer in the sense, or with this procedure, that we would come in the morning and being surprised what was calculated, and then learning from these results and recalibrating the process. In order to come up with designs that we would not have imagined before. And then the level of scale is important, and also working with physical models. So that is another 3D print in 1:10 that we did back then. But it turned out also that this process of also having a physical output in between still is very important. And it turned out that printing this, you see it over there, the physical model, was at this time also faster than plotting the entire space. We did a one-to-one poster plan here of a grotto design, but printing this one monolithic 1-to-3 model of the grotto also could be done in a single day. So that's an exciting development, that the materialization of the objects becomes also so directly connected to the design instruments. just some surface studies. The idea and the search was about how to code these structures. At the beginning, being very optimistic that should be real gold. We are now maybe checking how can robots do that, but back then it turned out that it's far too expensive. Not in terms of material, but in terms of work. Next scale was then using fake gold, but still manual work, and then at the end this prototype was sprayed in fake gold. So different iterations of surface treatment. Different questions about materiality maybe as well, but for us it's also important to have the right material in order to have this interplay of shadow, the sensatoric experience that we can provoke with these structures. On the technical level, different digital representations of these geometries become very important. This is a self-intersecting cut of one of these subdivided shapes. So nothing is controlled beforehand. All the manufacturing constraints come afterwards in order to have the maximum degree of freedom of the design. So we developed our own methods to clean up. This is a cleaned up section now. Of one of these grottos. We worked here with now voxel-based models, so the pixels that we were talking already before turned into 3D pixels, and at the end the resolution of this is, I think, roughly 3,000 by 3,000 by 1,000 voxels, such a volumetric model that helps us to construct actually at the end the shape, to define the most important aspect of such geometry, the aspect what is inside and outside. But also all the connection details are calculated on the voxel level. I skip a bit the technical part, and also here the illustration of the fabrication you have seen probably already. Assembly here, dry joint connection. So we were pretty precise, and just some illustrations of a test assembly in Switzerland, in Zurich, at Schlieren at the construction hall. So that was an interesting experience because also of the delay caused by the huge amount of data that made it very important to figure out strategies how we can play with these models. Because that means, okay, you have to wait for a day until you can see what you are generating, etc. Important aspect of the work. Maybe just to show how we further develop these methods, because what we found out in this project is that actually our geometric resolution was the limitation. So the printer could deliver more details, but we could not generate more details. So we refined the algorithms that we use to control the geometry. This is the follow-up project Arabesque Wall, where you can see maybe also these different representations, different models that become important into the design aspect. Light simulation, so rendering, but very important, and then finally the materialization. And for us, the little artifacts that you see, depending on the manufacturing process you use, are also an interesting and important part of the entire process. In the second iteration of the grotto, now we work with geometry that is not only folded out of paper, but also cut and glued together. So that means we can work with more complex topologies, more like sponge-like structures. As you can see here, multiple degrees of depth on the surface and many layers. Here just a visualization that this colorization scheme happens based on these classification principles that I talked before. So we paint these structures based on what kind of properties the individual millions of facets have. And here, studies of Grotto 2. Grotto 2 is basically an aggregation of many different of these schemes together composed in one project. So these are just the segments studies. So it's a curiosity also of form. It's a curiosity also how these different kinds of orders come together, also how they can be materialized, and what architecture we can compose out of these structures. This is now a movie from a printed object of the Grotto 2, which maybe also shows the translation now from the rendering that you've seen before to now the physical artifact. Again, I skipped the technical details. Just here some some documentations of the installation at the Centre Pompidou. Computer crashed, I think. It happened before, so we have maybe a little break. Unless you want to sit in front of this image for the next hour. No, but I think I have to really reboot the tab. Huh? No. I think I have to reboot. Okay. Too many triangles, yeah. No, but I think it's... Image of Koto 2 now, I skipped some slides, huh? But you see maybe that really there's different orders and on different scales of magnitude here, but also in different locations. Now maybe quickly a work that was also not authored by us but by Christian Geritz, and so we took over the digital fabrication part, but I thought it's maybe interesting to see here or maybe seek for some parallel aspects in the design process. So that's the incidental space Venice Biennale Pavilion contribution from Christian Geritz. And he worked together with students, I think, building almost random physical models out of gypsum casting and being in the role of just selecting actually the best fitting design to his intention. So it's a very analog process, but I think there's some similarities in terms of how you derive forms. So that these are photos from these gypsum models, renderings. This is the space itself as a negative volume that we had to fabricate. We developed here, again, a method that allows us to automatically generate formwork system for these shapes. Here the structure. And for us, this project was also interesting because it's basically also questions a bit the typical categories that we would use when we are talking about architecture. It's maybe also seeks for, okay, what are the limits of architecture a bit, and working with these geometries, it became interesting that one would classify these parts of the topography that we see here by almost same naming principles that we use when we are talking about mountains. So there are some specific valleys here, or some regions with very refined geometry, some with a rough texture, but everything derived from a physical model. At the end, built in a very performative, actually 20mm concrete shell with the help of Josef Schwarz. And here some photos of the final installation. So this 3D printed formwork, we continue working with this process. It allows us to mediate between the digital manufacturing process and conventional materials, or a wide range of materials. In this case, it's a shape memory alloy reinforced staircase that will be opened next this summer. And we use also machine learning to basically augment the design process. I guess you're all familiar with these topology optimized optimization principles that help us to reduce materials and components. And in this case, we developed a surrogate model approach where the machine learning can predict how an optimized structure would look like depending on playfully placed obstacles in the structure. So in that case, you learn as an input the obstacles, you simulate the result. This takes a long time, but then you have a real-time interaction with the computer. And I think this kind of real-time interaction between the digital model, between the design intention, allows you to really start playing in a different way. So it's a categorical difference. It's not just making it faster, but it allows really to design and play with aspects that probably would be difficult beforehand. And here, a model, and we use this also on different scales, but I think this would go now beyond the talk. Maybe to the physical aspect. The geometry that I showed before was mostly driven, the forms are mostly driven by geometric processes. And we are also interested in discovering new geometries by physical processes. So in this case, it's a printing process that actually is not calibrated well. I think Anna over there, leading the concrete printing research, can tell us more about this. But even those can be considered as failures. We are also interested in what kind of geometry, what kind of form is derived from these processes. We discover new patterns, for example. I mean, at this moment, we are always aware that we have to clean the printer again and again, and this takes a long time. The challenge of 3D printing, as you know, maybe with concrete, is that you have to have the right timing between gaining strength and still being soft enough to bond between the layers. So the process is now calibrated, but the question is maybe what to do with these kind of, you see also here an interesting model in the background that is supposed to be a flat element. But so how can we also maybe make use of these kind of structures? So in the Tor Alba project, a project that we are currently building, we try to make use of these, we call it material-driven ornamentations. So I skip a bit the background. It's if you still have time, it's worth a visit, a Swiss mountain village where the tower will be placed here. Many people are involved, as we heard in the previous talk, so I just have not time to go in detail about all the peoples that are involved here. The final design, the way it is built now, is a composition out of columns. What else? I mean, after hearing my previous projects, we play a little bit with the typology of columns. In the base, it's massive, very volumetric columns, so darker spaces, and you ascend the tower and you come up in a space that is provides an overview to the entire village here. We do fabricate these columns in-house, so they are all printed now already. There's a reinforcement integration, but what I wanted to talk about is rather the level of ornament that we here now not control entirely and directly by geometry, but also by the process of materialization itself. So it's a different category, less control again, but for us also working with similar topics of, okay, how can we introduce different scales of geometry into architecture? And how can we also be surprised about some of the results? maybe I skip here this video, but just to illustrate the entire project. So that is the Moulins village. There's currently 16 inhabitants in this village. 8 of them are in favor of the tower, and 8 maybe not so much, but I think once it's installed, it will be different. Our client is a cultural institution, the Origin Foundation, very generous and also very much involved into the planning process itself. The foundation seeks for unique spaces that allows them to have a counterpart to typical performance scenography in order to stimulate creative processes between the artists and the stage, which is the tower to a certain degree. It's also a stage for the events there. You see the growing of these models here, the growing of the tower, and the topic of the branching column that is that we play with from level to level, introducing also asymmetries and a higher degree of branching. So every single column is printed, and this is the assembly hall, and 2 levels are already assembled now from the tower. This is the lowest level. It's already more than 3.5 meter high. You see there's cast parts, 3D printed parts, and cast parts again. And here just further studies of the ornamentation. That's all the lowest level, so the smallest. The highest level is 6 meter high columns plus a 5 meter high cupola. So other materials we are working with, maybe to wrap up. So we are interested in working with different materials in a single printing process. So in this case, it's a reinforcement printing of carbon fibers. That's a work from Yunchul Kwon here, to create these kind of furnitures. He also integrated SMA, so another dimension into 3D printing, the dimension of time and movement. That is an SMA smart material, so shape memory alloy that is integrated into 3D printed structures and their movement can be controlled by the 3D printed structure itself, as you can see here in these images. We add also additional dimensions by working with different plastic extrusion principles, so not scaling them just up massively, but also working with hollow filaments in the 3D printing process that allows us to increase the structural, optical, and thermal performance of plastic printing, but also adds another aesthetic dimension to the models. And you see here the 3D printing process in action. And what it allows us to do is now, there's Matthias Leschok and Nick working on this process, is to control, for example, the amount of air that we blow into the structure, and therefore adding an additional dimension to the printing process itself. Here are some studies done together with the students. Here you see it very well, that there's some larger inflation and some lower inflation, and all this resulting in quite interesting physical properties of the artifact. Again, a mix between robotic control, geometric control, and material-driven control. I wanted to end with a work from Vasily. He works on ice formwork, that's his research topic. And here this relationship between the material process and the form definition is, I think, very visible, and resulting in also shapes that we would not be possible to maybe design otherwise and fabricate otherwise. The process is quite poetic because it relies on melting the ice in the same speed as the concrete is curing. So that means a very soft demolding and capacity to create these very interesting porous structures. Here are some student works. I mean, Vasily's here, you can ask him later. You can also maybe visit the freezing container where these objects are created. It's one of these structures here. So I would say no very predefined geometric control, but a lot of freedom given to the material process. And that allows to also then control these different degrees of porosity. Yeah, and so I wanted to end here with this. I think we are living in an exciting time because I think we are in a time of convergence between the instruments we are working with, the instruments and how they are manufactured. That's a GPU close-up. The instruments we can use for materializing our designs and designing our designs all this coming together through the digital, and that allows us to further play. Thank you.
Thanks a lot, Benjamin. Maybe just one question. When is it opening, the tower?
Difficult to say. End of September, hopefully, but there's no official date yet.
Do you have to convince a lot of neighbors to approve that?
No, that's already approved. Yeah. So.
Right, questions?
Benjamin, thank you for the presentation. I enjoyed throughout the whole presentation how consistent this idea of geometry and detailing has been throughout your work. And one question, not question, but rather word was coming all the time to my mind, and this is the idea of craftsmanship. And I think this could be interesting to talk in relationship to your work, because we're always thinking about the grotesque or the Gothic as these very intricate, handmade, long process things. And your early work and your latest work is really trying to still have this level of detail, but the long process is being taken over a particular construction system. And then for me also, it will be really nice for you. It will be very nice if you could also elaborate into the mass production of things. Like, what if you see a balance between craftsmanship, the detailing, and mass production?
Good. The microphone works. Yeah. Well, that's of course really an interesting question, and also a question that we are permanently confronted with and asking ourselves. I think so. The original idea is not to romanticize craftsmanship, so we also really conceive our work as not trying to redo craftsmanship, but there's a related aspect. So I think the aspects that good craftsmanship can add to architectural design and architectural space, this is the aspects that we also relate on this work. So working in different scales, working with also variations, and basically also adding an extra effort to the work. And I think that's an important point. So when we are talking about this relationship between mass production and the projects that I've shown, I think that's still a lot of work that we have to put in. But that's also an important aspect, because that means that the value of the spaces we are creating is higher. So it's a lot of intellectual effort. There's a lot of designing behind it. The process is, of course, rationalized to a certain degree, but it's not. You could build a tower of this height. So it's about a certain adding values to architecture by appreciating also what we do or what we construct here as an artifact. But then there's of course also rational aspects that could be in other projects become very important and also industry relevant on really the other level of making architecture more affordable or etc. But the specific projects I've shown here, I think they rather maybe celebrate the extra value we can put into the architecture. So at the moment where I think we would now work with methods that are at the end completely effortless, then probably would look also at a different perspective on these projects. So I think the effort is important.
Maybe I can ask a question. So, big fan. I'm completely in love with all of the projects that you've shown for a very long time. And I'm curious because you never talk about it, but the aesthetics, the quite consistent aesthetics that are present throughout the trajectory of these columns, and now the Storia Alba as well, this Geiger-esque, neo-Gothic. I don't know. I don't want to pin it down, but I'm wondering, how do you reflect upon that? Do you like it being called Gothic or Geiger-esque, or
I think people refer often to Geiger or Giger, a Swiss artist that was responsible for the alien design, but that was not really a reference. But of course, there's maybe some similarities also in the alien-esque, like, because we are seeking for a bit of a different language, but as maybe very well visible in the digital grotesque, that it still relates to an architectural order, but creates an alternative version maybe of it, and that might relate also to the alien aspect of Giger in his works. But so it was not a direct intentional reference, and the idea of these works is that people can interpret it and read it in different ways. So that to be able to interpret these architectures in different ways and read them is an important aspect of the design. Also. So we are happy if not everyone referenced Giger.
Yeah, it was a beautiful presentation. So inspiring seeing all of these different iterations in place on these geometries. As you also just now mentioned, this idea of architectural language and this like searching for new architectural language, I was so incredibly curious when you were saying in these subdivision processes you developed kind of names for certain regions, and then later on you spoke of how like in the other project you were almost referring to it as like geological features. So because this is like, one speaks of architectural language in terms of geometry, but like this is a case where like an architectural language is actually at work when you and your colleague are going to decide what kind of part of that kind of ridge behaves to that rule or to that rule. So I was just super curious, what are the kind of terms that you came up with to describe these features?
I mean, that's really depending on the project, and I think we also learn of how other people. Now we are working in the tower project. There's many people involved in the construction, and they give also names to some aspects. So maybe to give just one example, but that's also not the most beautiful. But so the base level of the tower has also no real name. So first of all, there was a debate if this is level 0 or level 1, because it's actually a non-existing level floor. And then it also has no direct architecture reference. So people would call it a Flaschenhals in German, a bottleneck. It becomes this now currently the terminology that is used for this part. That was not the intention also. But it became very important because now people know what we are talking about, which part of the tower. And yeah, but so in the other project that was designed by or found by Christian Keretz, there it was basically then the many different names. It's a whole category. I should make a diagram of those.
It's really fascinating.
Thank you very much for your presentation. I am just a little bit curious about if you would have to choose a specific material for making this kind of designs. I know that each material has its specific properties and each design has its specific requirements, but which material do you think is the most reliable for, in general, to use or with this kind of techniques?
Also a good question, and I think a constant search, because I think now including also Michael, who does much more project also with this, the range goes from styrofoam to marble, and so I think very interesting materials are materials that come with a certain inner life already, as maybe a marble stone, where you have an additional level of surprise and you have an additional layer in your design, the inscribed texture. But we did also projects where we printed artificial marble and made an algorithmically generated marble texture that would spatially go through a synthetic material. So I don't have a direct answer, but I think ideally it's a material that can also surprise us in these systems. Yeah.
All right. Thank you very much, Benjamin.
Thank you.
I think I can Just let it go. So we are finally at the last talk of the day. So the last talk is by Elena Manfredini. I'm extremely happy you could make it. Elena is the principal and owner of Atelier Manfredini in Los Angeles and the graduate programs chair at SciArc, and also my ex-boss. I'm extremely happy that you're here. Please, it's yours. The stage is yours.
I just want to mention that I love your work for a long time. And it's such a pleasure to see it. I'm a fan. You know, so you know, you have a fan in me. What is this? Is the wrong one? Is the wrong one? Hold on. Let's see. Mm-hmm. Yes, let's inject. And let's see if this one's gonna work out. When AI grows up. So 2002 has been the year of the text to image. I think we've seen incredible work done by colleagues and friends today. AI is on everybody's mouth, and I think it's been some kind of wildfire technology that has a foreseeable impact on the current creative economy. And these are some experiments with AI, which I will talk to you about soon. And among all this image generator, I think these are all done with Midjourney. And I think I want to talk about aesthetics a bit, because I think Midjourney differentiates from others because of the reliability in terms of being pretty by default, and its capability to produce this overall fine art aura that made it a democratizing tool for aesthetic in a variety of style. And I think this tool is associated with reliably aesthetic images, often delightful and whimsical. And I think truly the tool is designed to unlock the creativity of ordinary people by giving them the tools to make beautiful pictures just by describing them. These are the words of David Holt, Midjourney founder. This was my first project with Midjourney. By the way, I will not show you things. I'll show you very personal things today, not research project. These are really absolutely personal experiments and Project Midway. Because I thought maybe there is something to be said about these tools being personal and democratizing tools. And these were a series of experimentation with the first generation of Midjourney when it was still beta version and it was still not very well trained. And I thought I actually produced more interesting things because it did not exactly know what to do and it was not trained yet. It was really at the beginning of the beta version. And this AI technology can be a valuable tool, I think, clearly for content creators looking to enhance their creativity. And I'll talk a bit about creativity. I think there was a great question before, where creativity comes from, and improve the quality of their work. AI content creators can take advantage of all of this. And I'll talk also about biases that AI has. So this is the little image that I did with Midjourney that then became an NFT and then became a real piece. So design, as we know it, will no longer belong to a relatively small group of well-trained individuals, which I think is what we are here. Actually, visualizing one's imagination will be a fully democratized practice, taking place in online communities where we are co-working and co-imagining. And these new human aesthetic open source visions will spill into the real world. And it's not a so distant future when visualizing one's imagination will be open source, real time, three-dimensional, interactive, and physical. So what was once upon a time a very clear dichotomy between the intuitive mind and the rational mind. By intuitive mind, I mean the aesthetic, agency, authorship, inspiration, creativity, whereas the rational mind was maybe analytic, optimization, prediction. I think in the post-human design environment, we surpass this dichotomy, and I think somehow issues of creativity have to be really looked through a completely different lens than the one of the 18th century genius, personal ability, etc. And also the difference between the esprit de géométrie or the esprit de finesse of Pascal. I mean, this is a long dichotomy that I think has been part of philosophy, or our way to see ourselves, or even to define our own value in the world as human in relationship to all the other beings. I think today, with the hegemony of this digital media identity as also to be refined, AI poses a big question and a big anxiety of how we define ourselves from others, or how we define our role in society as creatives. And this is not just about jobs, I think, which is a bit about jobs, I think, at least, but yet I think it's about our role and how we see ourselves in this new economy in which AI, I think, has questioned our capacity to create and to be the top at logics and things that we thought belonged to being humans and now belong to being machine produced. I would say, actually, looking at what I've seen, that we're not great generators as humans, but we're great discriminators. We know what we like immediately. So if there is a role we still have, I think, is not the one of creativity, it's the one of discrimination among the things that are created. This small project was a first test when I started using Midjourney, and I kept on doing the same thing for a year. So I show this to you as a small assignment, where it's called Pick Me. And this grapples with the issues of identity today in the time of an emerging AI. So these images could be loosely associated with a series of self-portraits, but instead of using a selfie or a phone, I was actually using Midjourney. I wanted to see what would come out and how the same exact input would change accordingly to the different versions of Midjourney through one entire year, which was, I think, the big year of Midjourney. 2002, 2003 is when I did this. So these are not produced with a cell phone camera, it's produced with Midjourney. There is a single text input, and it's a temporal progression of faces. And scrolling through the faces, the viewers notice that the age of the women oscillates from childhood to womanhood, and the initial manga cuteness transforms into disenchantment very quickly. Because it was a very specific word which I wanted to test into the prompt, which was cuteness. And I think Xian Gai does a very good job in her book on our aesthetic categories, the zany, the cute, and the interesting, and she defines cuteness as a way of aestheticizing the powerlessness. It hinges on a sentimental attitude towards the diminutive and or weak, which is why a cute object, formally simple or non-complex, and deeply associated with the infantile and the feminine and the unthreatening, get even cuter when perceived as injured or disabled. So there is a sadistic side to this tender emotion. And so these AI-generated images had one word in the text which was cute. And within the time in which I started and ended, this was the first image, that was the last image. Clearly something has happened through the collaboration between me and everybody else on Midjourney. And so this piece is really a display of the ways AI tools are subtly proliferating, dominating cultures within powerfully beautiful images. They are all beautiful images, they're attractive, and yet they do have a cultural social capital in them. Not very different from the work of Tomoto Sawada, I think she does. She takes pictures of herself every day, different tools, but somehow it's, again, a commentary about identity and truly fast forward this in time of the internet, social media, face filters, mask, gaming, and avatars. We understand this is a big deal today, how we see ourselves and how we proliferate images. Sherman, standing artist that puts herself into the picture and really subverts this visual shorthand we use to classify the world around us through the idea of ourself. So this was just a simple project that questions stereotypes, conventions, while exploring attributes such as aesthetic, self-image, and gender. And so essentially, AI is holding a mirror to our society, explains Prisma Labs about the existence of biases in Stable Diffusion. And while it's impossible to fully eliminate biases from the human-made tools, which is really, again, AI is human-made, it is important to question if AI-generated images might end up reinforcing dominant culture while they simultaneously produce speculative visualization, which is why I asked the question about Morgan, why. Ultimately, really, the work wants to make a case for cultural sensitivity and wide representation. I told you it was personal, this one. And I think the biggest triumph of the digital age is truly the transfer of our identity on the digital space. And this is not merely a mental transition. Our bodies, our voices, our text messages, our geographical location, our feelings, our connection, our public space lives online. And we live into this interconnected shared data that define who we are. Our phones know more about our personal life and secrets than ourselves sometimes. Therefore, I think our sense of self is split between who we are in real life and how we represent ourselves online. These avatars, these face filters, this deep fake are just the beginning of the manifestation of a larger global transition of our sense of self into the cloud. This was a small exhibition I've done in Los Angeles. I brought it here because part of it was an AR experience coming from artificial intelligence. I made 1,000 women faces. It was really an exercise about portraits. These are all cadavers, by the way. These are all dead women on a plate displayed as food. Nobody knows it, but Midjourney does because they blocked me so many times while I was doing the project because there is now a way to block it. And so all the time I would input this data. So there is, they were not happy about what I was writing, but in reality, so the experience was to start taking all this AI images into the reality. And it's not just the reality of the women printed on the mirror and being displayed between consumption of female culture and food, but also how then they become part of the space through augmented reality. So we did an app. First of all, we brought the bidimensionality to three-dimensionality, which was its own task. Because it still is on task, so I'm looking at NVIDIA to make this faster for us, but it's not fast yet, so there is a lot of work to go from 2D to 3D. And then we started creating phone apps so people could interact and bring these women back home. And we did QR codes for all these 1,000 women, and everybody who came to the exhibition brought one back. And I think somehow, clearly these are artwork, they're commentary on technology, gender, and where we're at with things, but also personal expression. I told you today it was personal. Adil is already worried about this lecture I'm giving. I will also show stuff from the past. I think this also wants to say that there's designers, which I really think you do. I mean, you did not talk about aesthetic in design, but I think the work you do is amazing because design is just incredible. So besides the craft. So as designers, I think we are now asked to do something that is between physicality and also the imagination. So the AR, AI, all these things that happen in our phone, in reality, I think are becoming not just an issue of technology, truly. It's an issue of culture and engaging with the fact that we are all using our cell phones for everything. Our first encounter with anything is online. And so the idea that I think the average American is in front of the screen for 7 hours and 5 minutes, and I think all of you sympathize with the fact that if it's not 14, we've not worked enough. I mean, we're all in a different realm, and if it's not the screen of your computer, it's the screen of your cell phone. I think we mediate our views through a screen for a long time, and I think that has become a place of the public imagination, has become a place of our public identity, has become our main interaction, and has become also the place of desire for our designs. We are looking at the screen and the light from the screen. We make these images, we produce these images, and then we want to build them. And I think that's not a small issue, how to bring this kind of qualities into the space. And so a lot of the work lately has been truly trying to capture this idea of physicality and also this digital footprint, which I think is hidden behind, is a cultural aspect, the most hidden behind what we're doing today with AI, I think. This is a project done for Lane Crawford. It's 8 stores in China, 4 in Hong Kong and 4 in mainland China. You know, this is where it comes from, but let's say that's not. Sorry, it's my fault. So this is the digital component of this, and a lot of the issue was then how do I bring this into the reality of a fairly static space, which is the one of the shopping windows. And so we started creating this wallpaper, and the wallpaper had patterns, and the patterns started triggering AR experiences. So that was the trick to somehow bring the still life, the natura morta, to life into everybody's cell phones. So these are all the different shopping windows. We had many. It was a big job for us. And I'll show you a bit the application so you can see how then you can point the app from the cell phone, choose pattern, then the AR experience starts. You can start seeing insects and flowers and sounds moving around the clothing. It is a for a clothing company, by the way, yes. It's a luxury brand. I didn't mention. And so the idea that there is always a physical footprint in every job we do, but then there is also this digital footprint, and which is the most important encounter in reality beyond the moment in which you will see the project. I'm just showing some stuff that I'm doing right now is really under construction while I'm here, with all the issues about that. So this is a project I'm doing in San Diego with Gensler, and I'm doing some of the interior facades and graphics. And again, so there is a static, there is this, let's say, design, which comes first, and then how then you bring this into a project. So it's a series of panels that are printed, and then part of the interiors, we use vinyl to occupy it. And also there is a component of animations when you scan the QR codes and you start seeing what is behind each of these projects. So it's a bit of a creepy carousel of trees. A few more. And and these are other examples of ways in which our social media devices, our phones bring another layer of interactivity. I'm also working with Anju University to do interactive rings, smart rings. Really what I do is a form, they do the software, to be honest. But so in the software, there is all this AI behavior that are integrated. We are doing for him and for her, and it's called Not Formality. And so we're having fun doing this stuff. So AI also can be integrated to small apparel, interactive apparel. A project for the East Family Library for children. The beautiful star students. So again, this is for a children's library. We're making carpets that occupies all the plain area for the children, and there is this AR application that goes with it, somehow scavenger hunt. So illusion and reality, I think it's a state of being right now, nowadays. This is for elderly people. Like, if you know this movie, you're my age.
This is your last chance.
I think we need more sound for this.
After this, there is no turning back. You take the blue pill, the story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes.
But the choice between the blue and the red pill is not really a choice between illusion and reality. Of course, Matrix is a machine for fictions, but these are fictions which already structure our reality. If you take away from our reality the symbolic fictions that regulate it, you lose reality itself. I want a third pill.
Clearly, this is Zizek. I just wanted to use his take on illusions and reality, because I think somehow it's part of where we're at today. And I think AI, AR, all the things we do through our cell phones has become a second nature, and frankly cannot go back to not being there. A few last words about still nature, which I think is maybe something where AI should be more interested in. So in the current state of affairs, I think as environmental issues take center stage in the public discourse and AI is expanding in its application, I think the representation of nature has undergone a profound evolution, and I think still nature has never been this interesting. And I think contemporary portrayals of nature delve into this intricate web of interactions, dependencies, and impacts that define our relationship with the environment at a planetary scale. We are entering an era in which our pressing challenges exceed the narrow concerns of human beings. And this issue demands a departure from conventional human-centric views of the world and its governance towards approaches and structures that transcend planetary boundaries in scale and significance. I think AI tools offer us a capacity to envision novel species and prospective futures. There is sound, but you cannot hear. I think these AI tools harness this power to somehow transcend the constraint of the present moment, and they foster a sense of wonder and curiosity. And I think somehow they expand our collective dream and our understanding of the world by generating visually realistic depictions of hypothetical worlds, creatures, and phenomena. I think AI tools allow artists, or in general everybody really, to explore alternative realities and project futures that diverge from our own. And so I think that there is a collective intelligence, there is a collective imagination. Also, they prompt a contemplation on the evolving relationship between humans and other forms of life. And I think create new breeds that invite reflection on the potential of collaborative efforts to shape the course of life on Earth, transcending the limitations of singular perspectives. I think AI raises the question of multi-species representation. And spark an unorthodox way of seeing things. And so they somehow ask what life will be. I have much more, but I think I would stop it here for questions. Or should I go longer? I have more, but fine, okay. All right, thank you. Any questions?
I'm really bad at sharing, so therefore.
Okay.
I'm going to take this first question. I'm sure there's more coming after. I want to challenge you with your first statement on AI. So humans are about discrimination because we are not only about generation. Like generation, we don't have to care. I think this is more or less what you were saying, that we are more becoming curators to this new upcoming way of creating. So I challenge this.
I guess what I was trying to say is that we might not be the fastest creator, but we're really fast at discrimination. Which doesn't mean that we're just editing, but I think that's something we truly do fast. I mean, even if you think about Midjourney, your role in this is training the AI. This bigger, this one, mix this with that one, I prefer this one. And everybody trained it, paying, by the way, $40 a month, the system, because we are the discriminator. So our role is not, there is a machine generating stuff, and we're discriminating whether or not is what we wanted out of it. Isn't that what happened? Because I feel like that's what happened.
But it's not the only way that you can do this.
Yeah.
That's why it's too reductive to say that we are just faster at doing.
I think it's innate if they cook for you, that you tell me, I like it, I don't like it. I mean, we taste something, you know immediately if you like it. Visually, we know immediately. And I think on the other hand, the creation process is a much slower one. I just think that computer became pretty fast. I'm not saying that's the only thing we're good at, but there is the AI produced fast. I mean, I cannot. This is why everybody has an anxiety with AI. Not here, because here we are a very selected group of people that is a positivistic idea about AI, which I share. But I go to panels and there is an anxiety about AI because AI takes away your identity in society. This is a little bit what I was trying to say. So you have to reinvent yourself, because what you thought were the characteristic of being human, your cell phone in your pocket is faster at generating images, generating text, logics, sounds. It's becoming the things that we did as designers are now something that we control as a workflow. and we discriminate and edit and initiate, but I think we cannot. This is a collaboration, and our role is not the one of generation, I think.
Only, maybe.
Only, yes.
I think I was looking for your one of the statements that you had, which was that they were showing where not to go sometimes. And this was on the very first project when you were saying where I was investigating with this beta version, and I realized that I knew what I don't want. So I have the feeling that now these extremely powerful, fast generative algorithms that are trained to every image, more images that we can ever see, they can point towards directions, and even they can show you where not to go, because you will actually, by just seeing kind of this panorama of everything that can happen based on what they've seen, we can choose to do otherwise. I think that's what I was looking for.
I think, I don't know, I'm not an expert, I'm a user. I'm like your grandma using it, I feel like I use it, and I like the fact that I'm using a democratizing tool in a democratic way, because I'm a technical person quite a bit, but there are certain things that I think are worth fighting and some not. But anyway, and it's okay. People here are investing time in the development of certain things, which I think there is a major rush towards what AI can do and which companies will make it and dominate certain market. I mean, and I come from the United States, and it's like every other company does this right now. And eventually certain companies will win the market. There is a strong race, and certain things will go back. So, and I think universities like this one have actually probably certain tools to develop your own system. Certain other universities that are not research universities do not. There is a certain level of positivistic. I think certain companies will simply jump on top of everything that the university will do. That being said, that's my point of view coming from the United States, where I think the kind of investment that right now is going on is very strong and high. That doesn't mean that there are certain very specific niche where one could develop certain tools within that framework and control it more, and that should be the case. But I'm also realistic about what it takes to do that. Just that. They are extremely NVIDIA will tell us, they're extremely expensive in R&D. No, you know what I mean? So certain universities, can support that kind of race up to a point. I don't know, even in our university, we had people doing AI, and there was a moment where that simply surpassed everybody else. And that's, that will continue to happen for a while, I think, until there is domination, until there is a way in which people can monetize out of this. It's much more clear what the intellectual property will be and how this data can actually be used or not. It's a bit of a Wild West still. So I'm not sure I'm answering your question, but I think you have faith in certain aspect of control, and I understand. It's not mine. I believe more that these kind of tools are actually belonging to the crowd needs and economy, and not a single person research. But that's, I don't know. I'm not answering the question? I did, okay. Not to say it's a waste of time. I think, but I believe that the force at play are strong. And I'm not a player in the race. I'm just staying away from it. And this is like, a big revolution in terms of the economy, of the workflow economy, yes. And the stock market and what happens to it, and it's just something to, ETH though is a force of nature. If there is a place where certain things can happen, it's this place. How about that? And MIT probably. That's it. Yes.
I do have a follow-up question, because I think that's an important point. And I would tend to agree with you that we are curators and we're not good at generating, but there's an aspect though that I don't think we always go in the right direction, and meaning that when I work with my students, I tease them that they always upscale the wrong image, right? Because I think that there are like better directions where to take the process that you talked about, like the collaboration with the tool to get to a final image. So I'm wondering if you have, what's your take on I guess the influential cultural components that help us create an aesthetic sense or visual literacy?
You know, the older I get, the less dogmatic I get. As a teacher especially, and I support, I'm in a role where I support people to do their work, so I don't feel like I need to project my own onto students, nor faculties, nor researcher. I'm much more a platform for things to happen, and I'm a promoter of many. I would say promoting the conversation is more important than deciding which one of the 4 images to scale up. And promoting a place where certain conversation about aesthetics can happen, I think is important, so that actually we can discriminate and having a conversation about that. But I live in Los Angeles. There are a lot of miss and some hits, and I appreciate the experimental capacity of students and faculty to take risks, and I learn my lessons, and I have my own practice. What you see is my really personal practice, and I could go on buildings and stuff, but I didn't show on purpose any of the students' work or faculty work. There is no, I think academic work should, I truly believe in freedom of speech and creativity, and my role is more promoting as a platform of conversation.
Okay, maybe I have a question as well. Before I give it to you, I was actually incredibly surprised at the last or the first project that you showed with the cadavers.
Okay.
And I'm really trying to chart a path through which we get to this kind of super dark kind of representation of these things. And then, of course, when I look back, then you have still life, you have the what do you call it, the tableau vivant, and these kind of things. So there's always this kind of interplay between what is dead, what is alive, what is a reflection, what is yourself, and this and that. I'm just wondering if these are oppositions for you, or are they always part and parcel of any kind of existence?
I think this kind of work was part of the idea that we live in a moment where identity, personal identity, is challenged. And we live in a place where there is a role play between who we are and what we project of ourselves out there. I mean, from the Zoom mask filters to the icon you select for every single social media, the kind of images you put out there, the filters you use. I mean, there is an aestheticization of the self that I think it's become quite predominant. I mean, the deep fakes and all this, I think it's quite a cultural spread phenomenon. And all this AI truly move very fast towards what is used by everybody. And we all are participating in this new role play, avatar/existence in the digital space. And I think as architects somehow, we always consider the public space being the public space of architecture. You have your tower, I have my buildings, I have and then yet there is a public space which is truly the one we participate in, which is the digital footprint of everything we do. And now we broadcast everything we do, even as professionals, and this is Play Models has an Instagram account. So I just think this is a public space that somehow is being designed. And usually it's been designed by insecurity, vanity, desire to aestheticize ourselves or project a certain image. So I think there are certain macro trends that I don't think are just there for a second. I think these are just our anxieties of who we are in society are out there, and as architects and designers, that space exists more and more as a cultural space, interactive space, public space. And so that's that.
Are we doomed to drown like Narcissus in the face of our reflections? Because I'm specifically interested in the mood of the cadavers. Okay, maybe we could
No, I don't know. It was a critique clearly of the, of beauty, of gender, like what is that it means to be consumed aesthetically. But yeah, that was, was, again, I told you, this is a very personal lecture. I'm showing very personal work that, that. Yes.
Yeah, also a question about maybe the starkness of it. So earlier you were talking about the intuitive mind and the rational mind, and then you were claiming that in a post-human design environment we have surpassed this dichotomy.
Yes.
And I just wanted to ask you, what is this post-human design environment, or are we in a post-human era, or what is this? It has something dark to it as well.
Yes, I think we're in a post-human design when we work with AI, yes. It is a human-made tool, but I think we're collaborating with the database, and I think, yes, we're in a post-human design environment. That's what I would define, what has happened in the past few years. And I just simply think that somehow as a creative, we're always consider our creativity, I think, has been considered somehow a super, a talent, a thing you have and is innate, and all you have is something that distinguishes you from anybody else, is this idea of the genius. It's a very specific idea. It has something creative is something new, something that has not been seen before, something nobody else can reproduce. There is a sense of uniqueness in creativity. And also there is a sense of this being a godlike quality that only few people have. And I think we're still a bit stuck in that kind of ideas of the genius. And when we talk usually about this creativity, we talk about the intuitive mind, the thing that comes to you because you have this inspiration, no? That you have this specific quality. I kind of think that that has never been true, by the way, but it's truly nowadays a past characterization of the creative person. Usually intuitive minds was against the rational mind, so the rational mind is the analytic mind, the optimization, the prediction, all the kind of things that maybe the engineer would do, the architect would be the intuitive mind, the creative mind, etc., the designer. Or if you go beyond architecture, there are many fields in which the genius is the person that is superhuman, etc. I just think these two distinctions are, and the fact that only the humans are creative, no? That's like, oh, this is what sets us apart from everybody else. We're creative. There is something special about us. In reality, that might not be the case. That actually creativity is, you don't create in void. It's actually a collaboration. Has been always a collaboration. It's part of a cultural humus that is around you. A university are clearly a great place where certain things come to play. And nowadays, when you are in front of a machine that is trained with all the data out there, I think that is even less true. You are truly, the myth of creativity has been a single act of a single person that has something to give to society because they're better than others. I think it's completely past. I think creativity is, the genius is in everybody, it's in the crowd, and the crowd and all these learning models are the one, and the data model are really the one that produce certain kind of interaction and produce the thing that we call first to be intuitive. I think and anybody who worked on the computer understands, I think, and you didn't need the AI to understand that the creativity comes from hard work every day in front of the computer, or whatever you do, whatever your art is, there is a lot of grind between you and that creation, and that is the most analytic and work ethic driven effort to create something that might be different from what there is out there. So it's kind of a direct, yeah, anyway, so that's all I want to say. I think we're in a post-human design environment because we use tools that interface us with a data set that is still human, but we interact with that.
We have more questions? No, we don't?
Yes, we do.
We do. Sorry, just a quick one, please.
Yeah.
Which do you think is the role of the augmented and mixed reality technologies in the field of architecture and design? I mean, not just for visualizing the things, but do you think there is any other role?
Yes. I think it's gonna, I mean, I think it's still a rough technology, so it's still not that good. And it's still heavy, glasses and cell phones. Yeah, there is a role. There is a role. I think it just will start overlaying a series of things and information and visuals and a depth of data onto things that we will see more and more. So, I mean, if I have to imagine, I think it's already kind of there, but I think the technology is still a bit raw, and so it's not visually that beautiful, and it takes quite a lot to load on the cell phone. So there is, I think it's the infancy of this, but I do think that it starts creating a layer of imagination and informations and data on top of reality, which I think there is a space for, at least. I mean, I'm not sure this is going to be our life in the future, but, what are you going to, yeah, I do think that it will become easier to have, and I think it will be part of our daily life. But again, I don't have a crystal ball, but.
Do you see using it in your real or your daily profession?
I use it not for myself, generally speaking, but I use it for clients a lot, yes. Because again, I think everybody understands that there is one geographical location, but in reality, there is a footprint, which is a digital footprint that happens only when certain level of activity, interactivity happens around a place. I mean, clearly, some of the projects I showed are commercial, and there is a desire to move beyond the person that comes to the space. And I think this AR or phone apps start engaging user towards image trafficking and spreading, I think, the public interaction towards another audience. I mean, at some point, I think James Turrell had a show at the Guggenheim. And James Turrell, the light artist, he said, my work cannot be experienced unless you are in the space. And so he prohibited everybody to take pictures at his Guggenheim show. And so there were signs everywhere, don't take picture, because he thought it's not a non-vicarious experience, which, it's fair to say for an artist to say that. And yet, I think the Guggenheim, everybody took out the cell phones anyway, and they couldn't police it, and there were images everywhere. And it was like the most important footprint of the Guggenheim, after which they actually decided to take away this non-picture sign, because they realized that it is true that you don't control the image of the space, you do not control the story, but that maybe is a good thing. So there is a participatory force when you allow people to have their say or take their picture or share their ideas about an artistic piece. Clearly, it's dangerous, Of course, a museum or an artist or an architect would always want to control the experience of the piece and put a caption and tell you how the visual culture should be read, should be understood. So there is an educational component behind it, not to mention the dogma and controlling version of this. But let's say, and the first moment you allow people to upload and not just download, this is a two-way stream information. That means that the reality that you create is part of it as well, and you're part of that. So Wikipedia, when you go to the page, you read Wikipedia, you go to the page behind it, and you realize that this has been edited until a second ago. And so you understand even the encyclopedia knowledge is not really the truth. The truth is what we create and we agree upon that is the truth. So I think all this comparticipation in social media has the capacity, I think, to allow everybody to have agency. And I don't think we're going to go back to say that only certain institutions have the agency to say what the truth is, what art is, what you should buy or not. You know, I think we're in a society where the totalitarian idea of certain institutions owning knowledge is ended. And so all these tools that layer information on top of reality, I think, allow for this participation, and I think it will keep on working like this. And you know, with all the difficulties of the deep fake and elections, I don't know, the data manipulation, metaverse, you know, you name it. But that just tells you how big that force is. Okay, we got into global politics. Okay, after this, yeah. So there is another question from your friend.
I would have another question, but no, we might as well.
We just need drinks now. No.
Sorry, just took a while to come up with a question, but I really enjoyed your talk. What I remember from our little experiments with Midjourney, that there are these kind of funny parameters like dash dash raw dash dash stylize and these kind of things.
Yeah.
And it's interesting how you described how the first of these portraits that you showed at the very beginning and the last one with probably the model going under fine-tuning, who knows what, and they change in terms of their attitude, in terms of their two-dimensionality, whatever. They get different. And it's interesting how there's this machine at work and this training, unsupervised, supervised, nobody knows exactly what's going on. But there is something like a prettiness factor or something like this that seems to factor in. And if, I guess in the 20th century, if we'd go to a museum and think of art, we wouldn't, if something is super pretty or not, it would not be the first thing that one would be conditioned to at least discuss, right? It would be about the context, I don't know, the context in which this kind of artwork is situated, the kind of cultural sensibilities it taps into, these kind of things. If something is pretty or beautiful, or how to beautify, one wouldn't, it's not a category in which one would think of art that much. And now with these Midjourney things, there is this kind of suddenly this very unarticulated way of tweaking the stylized parameter, make it more stylized, make it prettier. And so I'm wondering if as people who deal with these kind of nets, and we will probably deal with them more and more, if we need to find a new vocabulary towards referring to these aesthetic things, and also acknowledging that maybe a new relationship towards the idea of kitsch, and also, how to articulate in this kind of new realm that suddenly seems to open up between,
I think, I'm going to say this, that beauty has been part of the arts for a long, long time. Before Midjourney, I think has been the depiction of beauty, whether or not the standard of beauty has changed, to which they have been there for a long time. Maybe my Italian, I don't know. So you go to any place and there is a painting of anything, and the aesthetic moment is the desire for an aesthetic moment, I think, is part of the artistic engagement. I mean, I think this, the idea of the beauty and sublime, etc. So I think it's part of the aspirational component. Not everybody, but I think there is always a position towards aesthetic. I'm not sure if artists don't have one, if they have against it, or they have a different style. But definitely, what I think Midjourney does, I mean, he has been trained on, and not that I know exactly, but on a lot of artists, and so the best. You can tell. In this style of this such and such, and you will get phenomenal results today. And this is why a lot of artists whose work has been used to train these models are on a war path. And have you ever seen the Netflix documentary? Oh God. When, the streaming service for music. Spotify. So have you seen Spotify? The force. Okay, I recommend it. When people think about AI today, I recommend to watch that documentary because it explains, I think, a little bit where we're at now. Spotify is basically a moment where music goes from old record industry that had physical things and sold the physical item to digital format and then gets distributed and downloaded. And how that came to be and how artists got ripped off for a certain amount of time because it was a pirate issue. Like they just copied them and they put them online, people downloaded them until this became fast enough. And then until these people lost their business, meaning all these big companies thought, okay, now what do we sell? They, at that point, start negotiating with the new technology and giving rights to the artists. So this, I still think, is where we're at. So there was a moment before, there is AI, where they have this tool that has been clearly trained on artistic, human, and you can name these people, and they are used, but they don't get any of your $40 a month. So, you know, if I type in, do a job, etc., right, you know, I can name the artist, and nothing goes to the artist in terms of that $40 a month I give. That is the big issue here, I think, that we're having. There will be a point, I think, where all of this will be sorted. We're not there yet, and I don't want to get into that because I think these are the logistics of a giant, you know, that's why people have been striking in Hollywood, because their voices, their faces, and their work is used to do things. Apart from us, Midjourney, and the dead artist that maybe from 500 years ago that I used to make this image. But when you start actually doing things that are using commercially viable, alive artists, I mean, there is a big issue there. And I think that kind of sorting still needs to be done. It will somehow find this resolution that you and I are not part of. And I, you know, but at some point, I think that is the monetization of an art, either its beauty, its aesthetic, its painting, whatever it is that we're using through these models, I think will, you know, that's a discussion to be had, and I think they're having it. And I will close saying that this AI did not have a legislative regulation. The intellectual property is not recognized because it's made by a machine, but the machine is trained on intellectual property. And so I think there is just a loophole in terms of what is allowed today. Eventually, something will need to happen when there are going to be mega products, and certain things will need to be solved. So I'm not sure answers your question, but I still think that aesthetic is part of most production. Like there is this area of that. The problem is the stylized component of aesthetic that comes from, or sound, or music, or other things. I mean, we talk about Midjourney, but in reality, there are so many of those. The writers, I mean, when they're very much alive, yes, what's up? That's it. Yeah, what?
Thank you.
Thank you.
So we're at the end of the first day. Please join us tomorrow. We'll start at 10. We have coffee, and right now we have some drinks. So let's proceed to the back of the room. Right, thank you.